Welcome to the next course in database engineering. The focus of this course is on database clients. Let's take a few moments to review some of the new skills that you'll develop in these modules. You'll begin the module by learning about the MySQL Python connection, and you'll learn about using pip to install packages or software. You'll then learn how to install a front-end Python client and connect it to a back-end MySQL database. You'll then explore how to establish communication between Python and MySQL to perform CRUD operations. Once you've established a connection, you'll then access a cursor object. Once you access the cursor object, you'll create a MySQL database and table using Python. You'll then learn how to commit changes in a MySQL database using Python. In the third and final lesson of Module 1, you'll explore the concept of a cursor in a MySQL database. You'll learn how a cursor works in Python and MySQL. You'll also review the key characteristics of cursors and discover that they're read-only, non-scrollable, and asensitive. You'll then learn that the cursor class is used to translate communication between Python and a MySQL database. And you also learn how to identify different cursor classes. And you'll also review the basics of interleaving requests. The second module focuses on performing create, read, update, and delete, or CRUD, operations in a MySQL database using Python. You'll start the module by learning how to create and read records in a database. You'll review the steps for this process and discover how Python communicates with a database to carry out these actions. You'll then explore how to perform MySQL update and delete operations using Python, and you'll learn how to commit the changes to the database. You'll then complete this first lesson by performing a series of lab exercises in which you demonstrate your ability to carry out CRUD operations in a MySQL database using Python. In the second lesson of Module 2, you'll review advanced queries in a MySQL database using Python. The first of these queries involves filtering and sorting data in a MySQL database using Python. You'll recap the basics of MySQL filtering and sorting techniques from earlier courses and learn how these same techniques are applied to Python. Next, you'll learn how to perform a range of different join operations to combine data from different tables in a MySQL database using Python. You'll receive an opportunity to test your ability to perform advanced queries in MySQL database using Python through a series of labs. Module 3 focuses on advanced database clients. The first lesson in this module begins with an overview of how to use MySQL functions with Python. You'll begin by learning how to identify the importance of MySQL functions, and you'll review the different types of functions available in MySQL. Once you finish recapping the basics of MySQL functions, you'll then learn how to implement or access MySQL functions using Python. You'll also explore datetime functions in Python and learn how to make use of these functions to update a MySQL database using Python. You'll then demonstrate your ability to make use of these functions in lab exercises. In the second lesson in this third module, you'll explore using MySQL stored procedures with Python. You'll recap the basics of stored procedures, learn how they differ from functions, and how they're created in a MySQL database using Python. You'll then learn how to access stored procedures through Python with the use of the callproc method. And you'll also review the use of delimiters. The third and final module focuses on connection pools. You'll begin by developing an understanding of the concept of database connection pooling. You'll learn how database connection pooling works, and you'll find out how to identify the advantages of database connection pooling. You'll then review the steps for creating a connection pool for a database, including the process for implementing the MySQL connection pool module. You've reached the end of this course introduction. It's now time to begin the next chapter of your database engineering journey. Good luck.
There have been instances in my career where they were interdependent and I had to release them both at the same time. And so the only solution was to release code in the middle of the night when we had the lowest traffic and hope that for the 5 minutes we were down with one while the other one was updating, that only a few users ran into the issue. And sometimes it's the only thing you can do. Hi, my name is Moxie Herrera. I use they, them pronouns, and I'm a software engineer at Meta in the Menlo Park office. I work on donations products, so making sure that we are tracking who is donating to which fundraisers, to which charities. This is very important that we don't get this wrong. We want to make sure that we're storing the right data and getting the right data to display to the right user. And what we mean by that is we want to ensure the data validity. We want to ensure that we are making sure that we are only getting the data that the specific user should see, that we are saving the right data. These are very important concepts when designing a database, that you want it to be reliable. You want to make sure the relationships make sense. And we need to make sure that we're not accessing any data that a specific user shouldn't see. The integrity and quality of a database and its design is one of the first and primary steps to ensuring that our data is protected, our data is being stored in a safe way, and our users can trust that their data is not being mishandled. This requires us to have a well-designed database that is thoughtfully thinking about the different relationships that data can have with each other, as well as having some plan for changes in the future. The process I generally follow when designing a database is to first come up with a core data model that I need for a product to work. I start with that because for me, it's the easiest to conceptualize how we're going to access the data we need from a product perspective. And then after that initial data model is built, I start drilling down into specific privacy and validation uh, details that we need. So should certain data be encrypted? Should certain data be only accessible via certain servers? These are all different questions that we are going to have to ask. And depending on the type of data you store, could be credit card information, could be user information. There's going to be even more checks that you're going to have to integrate into your database and database design in order to accommodate that. The core considerations for a well-designed database at Meta are to first and foremost respect user privacy and user safety. A user should know where their data is and have access to it, and that they should know that it's not being used in any products that they are not comfortable with. The other thing we need to ensure is scalability. Um, it does not matter if you have a really well thought out data model if it cannot scale up with the billions of users that Meta products see every day. I think one of the most common challenges when you're working with a database isn't the initial time you built the database, because you have this concept in your model of a relationship, and then something comes along and changes it. The first thing to do is really be thoughtful about how you can change your database in the future, how it will scale not only with volume of users, but with types of products. The other thing that is very important to think about is how to modify an existing database. This is going to be a very challenging thing, and the majority of the work around databases is a lot of this stuff. We have this old data model, it doesn't suit our needs today. We're going to overcome this, and that requires just a lot of thinking and planning on your part, how to migrate the data. These are big tasks that take time to kind of figure out, but that is some of the ways that you become better at managing database and building better data models in the first place. As a database engineer, you're going to have access to a lot of data, and you really need to keep in mind how integral that is to user trust or the trust of anyone trusting you with this data, even if you think it's kind of trivial data. There's a lot of trust being put in you to make sure that you're being responsible. I really want you to walk away knowing that database design, database engineering is critical to the overall product experience and integral to user trust in the product that you're building.
Many of the web applications that you use every day rely on a MySQL database to send and store data, and many of these same applications are developed in Python. Database engineers can send and store data from a Python-based application to a MySQL database using a MySQL Python connection. In this video, you'll explore the basics of this important connection and learn how it works. Over at Little Lemon, the restaurant needs to connect a Python application with its MySQL database. They need to form this connection so that they can perform basic MySQL tasks using Python. And they also need your help with these tasks. But first, you need to understand how the connection between MySQL and Python works. So, let's take a few moments to explore the connection between Python and a MySQL database. A connection is established between Python and a MySQL database using an Application Programming Interface, or API. An API is also commonly known as a driver or client. The API is a written set of programs or software that acts as a bridge between the front-end Python application and back-end MySQL database. This connection can be created using different APIs like SQL Alchemy, MySQL Client, and MySQL Connector Python. MySQL Connector Python is the most common API and the one that you'll focus on in this course. A useful way of understanding the connection between MySQL database and Python is visually. Picture a diagram with a Python application on one side and a MySQL database on the other. In between these two elements is the MySQL Connector Python API. In a typical interaction between these elements, the front-end Python application sends a connection request to the Connector API. The connection request is the Python application asking for permission to access and retrieve information from the database using Python. The API forwards the request to the back-end MySQL database. The database accepts the connection. It then sends a message to the Python application back through the API confirming that the connection has been established. In other words, MySQL gives the API permission for the Python application to access the database. Now the Python application sends a connection request to the database. Once the connection is established, you can then instantiate an instance of the cursor from the connector class. And when a cursor object is created, you can then execute SQL queries in the MySQL database using Python. Let's look at Little Lemon's database as an example. Little Lemon need to check what time a guest is arriving for dinner using their Python application. The date and time data for the guest's booking is stored in the backend database. So, the Python application uses the execute module from the cursor object to carry out the customer's demand. The records are returned through the cursor object in the form of tuples that show the booking slots of each guest. Once the request has been fulfilled, the cursor object and database connection can be closed. You should now understand and be able to explain how a connection works between a Python application and a MySQL database. I look forward to teaching you more about the MySQL Python connection in other videos. As a database engineer, you'll frequently work with Python to perform CRUD operations in a MySQL database. But before you can work with Python, you first need to install and configure Python software on your system so that you can create a connection between Python and MySQL. Let's look at the installation and configuration process for creating this connection. The first step is to download the most recent version of Python from the python.org website. Follow the site's installation instructions. Once you've installed Python, you then need to open the application. Select the search icon and access the command prompt. Type python-version to identify which version of Python is running on your machine. If Python is correctly installed, then Python 3 should appear in your console. This means that you are running Python 3. There should also be several numbers after the 3 to indicate which version of Python 3 you are running. Make sure these numbers match the most recent version on the python.org website. If you see a message that states Python not found, then review your Python installation or relevant document on the Python website. Now that you've installed Python, you need to choose an IDE or Integrated Development Environment to run your code on. This is software that you can use to display your code. This course uses the Jupyter IDE to demonstrate Python, so it's probably best if you also use the Jupyter environment. To install Jupyter, type python-m pip install Jupyter. Once Jupyter is installed, type python-m notebook. This opens a new instance of the notebook for you to use within your default browser. Now you can set up your working environment. Select the New button in Jupyter, then choose a new folder. This action generates an unnamed folder. Rename the new folder to MySQL Python Course Content, and then access it. You can now save your projects and other files in this location. Now select New again and choose the Python 3IPY kernel option. This opens a new tab in which you can enter your code. You now need to connect Python to your MySQL database. You can create the installation using a purpose-built Python library called MySQL Connector Python. This library is an API that provides lots of useful features for working with MySQL. The MySQL Connector Python needs to be installed separately using a package installer called pip. The pip package is included with the Python software you just installed. Rename the notebook instance to Configuring MySQL Connector. Now you need to use pip to install the MySQL Connector Python. To install the connector, type an exclamation mark and then pip to call the package. Type the install command, then type the name of the library, which is MySQL-connector-python. Finally, press Shift and Enter, or select Run to execute the code. The output of this code is that the installation steps have now been performed as required, and a list of libraries have been installed. Python can now access the functionalities of all these libraries. You can import libraries in Python by typing the import command, the name of the library, and an alias. For example, to import MySQL Connector Python in a cell in your Jupyter notebook, just type import mysql.connector as connector. The import syntax tells Python that there is a library you want to import and make use of. The MySQL syntax refers to a subfolder that pip has installed, which hosts the connector. The dot before connector is known as an access operator. It tells Python that you want to access the connector subfolder using the dot operator. Finally, the use of as is a method of renaming the import using aliasing. This is like the aliasing that you encountered in previous database courses when working with joins. Aliasing is a common practice in Python development. You can use custom names, but best practice is to make use of common aliases that other developers are familiar with. Now that you've typed the code, it's time to run it. If there's no output in the console when you run the code, then this means that the connector has been successfully installed. You can now communicate with your database. You should now be familiar with the process of installing MySQL Connector Python to create a bridge between your Python and MySQL environments. And you also know how to install and configure a Python environment. Great work! A Python-based application needs to be able to communicate with MySQL databases to perform database operations. So, this means that you need to create a connection between Python and MySQL. For example, Little Lemon need to create a connection between their website, which relies on Python, and their MySQL database so that customers can view data like menus and booking slots. Let's take a few minutes to find out how a connection is established between Python and MySQL. At this stage, you may be familiar with the MySQL Python Connector API software package. This API facilitates the connection between Python and MySQL. But first, you need to import it into your Python program. To import the Connector API, type the import command followed by its name, mysql.connector. Then select Run. However, typing the mysql.connector each time you need to work with the API can be tedious. So, let's create an alias instead. You can create an alias for the mysql.connector called connector. You can then make use of this shorthand to make your coding more efficient. To create an alias, you can type import mysql.connector again or use the existing code. But this time include as connector within your statement. The as keyword instructs Python to recognize import mysql.connector using the connector alias in all future code. Now each time you need to use the MySQL Python Connector API, you just type its alias, which is connector. but make sure that you have installed the connector API first. Otherwise, you'll encounter a module not found error. You've now successfully imported the connector API, also called the package or software. Now you can begin to make use of its modules and functionality using the access operator or the dot. For example, you can help Little Lemon to make use of a connector to establish a connection between their Python-based website and MySQL database. First, create a variable to access the connector from the connector module. Call it connection and assign it the value of connector.connect. Next, pass the key arguments to the connect module within a pair of parentheses. These arguments are the database username and password. Only an authorized user can access the database. So, in this instance, the user is Mario and the password is cuisine. By default, a connection is established between Python and the database installed locally on your machine. This database is called localhost. It can also be accessed through its IP of 127.0.0.1. You'll learn more about the localhost and other arguments at a later stage in this course. For now, you should be able to create a connection between Python and MySQL. Nice work. You might be asking yourself, what actions can I take once I've established a connection between a Python client and a MySQL database? Well, some actions you can perform include creating databases and tables. In this video, you'll explore the process for creating databases and tables in a MySQL backend database using Python. Little Lemon uses the MySQL Connector Python client, or API, to communicate with their MySQL database. They need to communicate with the MySQL database to create a database and tables in which they can store data. Let's see if you can help them out. The connection between Little Lemon's existing MySQL databases and their Python application has already been established within a connection object. So, the first step is to create a cursor object that lets you communicate with the MySQL database. You'll learn more about cursors in a later lesson. For now, you just need to know that a cursor object can be created by invoking the cursor module from the connection object. A cursor object points the Python application to the location in the MySQL database where the required data is stored. Once you have a cursor object, you can run queries to the MySQL database. The cursor accesses an execute module that carries the SQL queries as Python strings to the MySQL database. You'll learn more about cursors at a later stage in this course. Now it's time to create a new database. Create a SQL statement as a Python string and pass it to a variable called createDatabaseQuery. The statement must create a database called Little Lemon. You can use triple quotes to change your statement to a Python string. You could also use single quotes to create a string. But the advantage of triple quotes is that you can use them to split a SQL query into multiple lines. And it's much easier to read and manage a SQL query over multiple lines. You now have a SQL query that you can run using the execute method from the cursor. Pass the variable createDatabaseQuery as an argument to the execute method on the cursor object. Execute this code to create the Little Lemon database. Next, you need to set the database for use. The first step is to create your SQL query as a Python string and pass it to a variable called useDatabaseQuery. The query lets you make use of the Little Lemon database through the use command and the name of the database. Then pass the variable as an argument to the execute method. You now have a new database ready to use. The next step is to create tables for the database. Create a variable called createMenuItemTable for your SQL query. Then create your SQL query as a Python string so that you can pass it to the variable. Create the query using the createTable command to create a table called menu items. The columns that Little Lemon need in this table include item ID, name, type, and price. The item ID column must hold the ID for each item on the menu. It's assigned an integer data type and rendered as auto-increment. This means that a new ID is assigned to each item in numeric order. The name and type columns display the name of each item in the menu and the type of cuisine that it's associated with. Both the name and type columns are assigned a data type of varchar and character limits of 200 and 100 respectively. The price column must display the price of each item in the menu. It's assigned an integer data type. The item ID column is assigned the table's primary key. Then execute the Create Menu Item table by invoking the Execute module from the cursor object. You can use this same method to create further tables within the database. Just update your SQL query as needed. Little Lemon now have a new database and table in their MySQL database. And you should now be familiar with the process for creating a database and table in a MySQL backend database using Python while developing a Python-based front-end application. When accessing a MySQL backend database using a Python front-end client, your Python application needs to know where the data required to complete your query is stored. A cursor indicates where this data is positioned on the database. Over the next few minutes, you'll explore the concept of cursors, their key characteristics, and learn how they work. Let's look at an example of cursors from Little Lemon's database. Little Lemon need to retrieve a guest's booking details. They can carry out this task with a SQL select query using Python. However, the Python front-end client needs to know where the data is stored within the back-end MySQL database. The MySQL database can use a cursor object to point to the records that Little Lemon needs. This cursor helps the Python client locate the required data. This example offers a good understanding of what database engineers mean by the term cursors. A cursor is a pointer that directs the Python client to the results of your SQL query within the MySQL database. The cursor indicates the location of the queried data by identifying specific rows or records. You can use a cursor to read, retrieve, and move through individual records within the results of your query. Cursors have several key characteristics or features that are particularly useful to database engineers. For example, cursors are read-only, so you can't update the data that they are associated with. The results can't be modified. They're preserved by the cursor. Cursors are also non-scrollable. They fetch records in order, which helps to keep track of your position when processing individual records. You can't skip or jump between records or fetch them in reverse order. And cursors are also asensitive. This means that they point to the original data within the MySQL database instead of a copy. This is faster than using insensitive cursors, which take longer to return results because they can only point to a copy of the data. So, how can you use a cursor in a MySQL database query? The first step is to declare the cursor. Use the declare statement and assign your cursor a custom name, followed by the cursor keyword. Then use the for keyword and a relevant SQL select statement to determine the purpose of the cursor. Next, you need to open the cursor. Type the open command and call your cursor's name to establish the result set. Now the cursor is pointing to the set of results from your select statement. The next step is to fetch or retrieve the results of your statement. Type the fetch command and the name of your cursor. Then type the into keyword followed by the name of the location the results need to be transferred to. For example, the results can be transferred to a local variable to be used in your Python application. The final step is to close the cursor. Type the close command followed by the cursor name. Closing a cursor is always good practice to release the memory associated with it. As you learned earlier, a cursor is non-scrollable. It works through the results set in order, so once it reaches the last result, it no longer needs to remain open. So, close the cursor to free up the memory it uses. Now that you're familiar with how cursors work, let's return to Little Lemon's query. Little Lemon can use a cursor to retrieve the booking data for their guest. First, they declare a new cursor called Guest Booking Details. This is followed by a SQL select statement that targets the guest's data from the Little Lemon MySQL database. They then open the cursor. Next, they fetch the data and store it in a variable within their Python client called Booking Data. You should now be able to explain what cursors are in a MySQL database, describe their key characteristics, and explain how they work. You'll explore cursors in much more detail as you progress through this course, so this is a great start to your MySQL Python journey. At this stage of the course, you've explored how cursors can be used to point to the location of the data you require in a MySQL database. However, it's also important to understand how Python makes use of the cursor class. The cursor class converts MySQL records to more Python-friendly code. With Python, you can also change or alter the behavior of your cursors using cursor subclasses. In this video, you'll explore the cursor class and subclasses and develop an understanding of how they work. Little Lemon need to find out how much one of their guests spent on their meal. They can query this data from their MySQL database in a more efficient manner by using cursor subclasses to create their Python strings. Let's take a few moments to find out more, starting with building an understanding of what database engineers mean by the term cursor classes. Cursor classes are a method of translating communications between Python and a back-end MySQL database. Python sends SQL statements to a MySQL database in the form of string objects. Cursor classes take these Python string objects and parse them into MySQL-friendly commands and data types that can be understood by the database. Python then uses the cursor class when retrieving these results to parse them into Python-friendly code. The cursor class contains several subclasses which can be used to parse string objects in different ways depending on your needs. At this stage of the course, you may have seen some examples of subclasses in action in the form of attributes and methods. For example, the column names cursor attribute returns the column name of a result set from a SQL statement. Row count returns an integer that represents the number of rows affected by a select, insert, or update statement. Or there's the execute method. The execute method is the most common cursor function. It binds the parameters of a Python string argument to a MySQL query statement so that it can be executed on a MySQL database. Cursor subclasses inherit the properties of the parent cursor class. In turn, the subclasses vary the parent class to improve the efficiency of the code. Let's explore some examples of cursor subclasses. One example is the cursor raw subclass. This subclass returns the results of your variable without pre-processing them to more Python-friendly interpretations. So, it uses less processing power, leaving you free to create custom conversions of the results. However, the disadvantage is that it requires more coding to process the targeted variable. Little Lemon can use the cursor raw subclass to create their own custom data type conversion. This could save time if the initial conversion type is not the one required. Another example of a subclass is the MySQL cursor dictionary class. This returns each row as a dictionary, which helps with accessing variables. You can access variables by using direct variable names. Little Lemon can make use of this subclass to return a result set in the form of a dictionary. This lets them use the actual column names of the database columns instead of working through a list of unnamed tuples. And finally, there's the buffered cursor class, which takes a subset of data and stores it in a buffered memory. The advantage to this subclass is that your code doesn't need to repeatedly request each row from the server. The disadvantage is that the data needs to be stored on local memory. So, you can only use this subclass to return small data sets. Little Lemon can use a buffered cursor class to retrieve data. This lets them make interleaving SQL requests. Interleaving of SQL requests is when you take part of a SQL query result and use it to make a subsequent request from a database. Let's take an example where Little Lemon need to find out how much a guest spent on a meal. They can interleave a SQL request to carry out this task. For their first query, they create a MySQL query as a Python string that retrieves the guest's booking ID. Once they have the result of the first query, they then create a second or subsequent query that uses part of the first result, which is the booking ID, to find the cost of the meal. In other words, Little Lemon can use part of their first query within their second query to make a subsequent request from the database. A database can return multiple results from the first query. If you use the first result within your subsequent query before all other results are returned, then MySQL encounters an error called unread result found. So, it's best practice to finish your loop and let all results print from the first query before you make any subsequent queries. However, you can avoid this if you first buffer the results using a buffered cursor. The buffered cursor returns all rows, while a standard cursor requires you to send an individual query to each affected row. Now that you're familiar with the different cursor subclasses, let's look at the syntax for instantiating them. The syntax is very similar across all subclasses. You just pass a keyword argument to the cursor that alters its behavior in a particular way. To create a standard cursor, you create the cursor as an object. So, to instantiate an instance of a cursor subclass, you add the subclass as a keyword argument that alters the behavior of the cursor. For example, you can pass buffered as the keyword to create a buffered cursor, or pass raw as the keyword to create a raw cursor, or dictionary to use a dictionary cursor. Little Lemon can use a cursor subclass to request all data from the orders table in the MySQL database. They can create 2 cursor instances, one buffered and the other a standard implementation. They pass their SQL select statement as an argument to both cursors. Once executed, the cursors return all items from the orders table. You should now understand the concept of cursor subclasses and how they can be used to alter or change the behavior of a cursor. Great work! Congratulations! You've reached the end of the first module in this course. You should now be familiar with the basics of how to interact with a MySQL database using Python. Let's take a moment to recap some of the key skills you've gained in this module's lessons. In the first lesson, you received an introduction to the course in which you developed an understanding of how a connection is formed between Python and a MySQL database using an application programming interface, or API, also known as a driver. You now know that a front-end Python application sends a connection request to the connector API. The API forwards this connection to the back-end MySQL database. A cursor connection can then be established. Once the connection is established, data can be sent between Python and MySQL. You also learned about the different APIs that can be used to create this connection, and that, as a database engineer, you'll rely on the MySQL Connector Python API. During this first lesson, you also learned how to install and configure Python software on your system so that you could create a connection between Python and MySQL. You learned how to download Python, make use of pip, and import the different packages that you require. And you also learned how to use aliasing to create custom names to facilitate easier communication with the database. You then explored a working example of how to connect to a MySQL database using a Python client. You saw how the API is imported into a Python program and can be used with an alias. And you now know how to make use of its modules and functionality using the access or dot operator. And you also know how to pass arguments to a connector module like usernames and passwords. You then ended this lesson with an overview of the process for creating tables in a database using Python. You learned that you need to create a cursor object that you can use to communicate with the MySQL database. The cursor object accesses an execute module that carries queries as Python strings to a MySQL database. Once your connections are set up, you can then create data in a MySQL database using Python, like databases and tables. In the final lesson in this module, you learned about cursors. You learned that cursors are used to indicate where data is positioned in a MySQL database so that it can be accessed by a Python client. The cursor lets you read, retrieve, and move through individual records within the results of your query. You then explored the key characteristics or features of cursors that are particularly useful for database engineers. You learned that cursors are read-only, so they can't be modified and preserve results. You discovered that cursors are also non-scrollable. They fetch records in order, which helps you to keep track of your current position when processing individual records. And you also found out that cursors are asensitive. This means that they point to the original data within the MySQL database instead of a copy. You then explored the code required to use a cursor in a MySQL database. You can now use commands like declare to declare a cursor, the open command to call the cursor's name, the fetch command to fetch results, and the close command to close the cursor. You then explored an example of this process from Little Lemon's database. In the next part of this lesson, you explored different cursor subclasses, and you learned how they can be used to change or alter the behavior of your cursors. You discovered that cursor classes are a method of translating communications between Python and a MySQL database. Classes take Python string objects and parse them into MySQL-friendly commands and data types that can be understood by the database. You also explored some common examples of cursor subclasses. Subclasses inherit the properties of their parent cursor class, like the cursor raw subclass, the cursor dictionary subclass, and the buffered cursor class. You also learned about the interleaving SQL requests, which involve taking part of a SQL query to make a subsequent request. You then explored the syntax for creating and using subclasses, and you also explored an example of subclasses from the Little Lemon database. You should now be familiar with the basics of how to interact with a MySQL database using Python, including establishing a MySQL Python connection and working with cursors. Great work! I look forward to guiding you through the next module in which you'll learn how to perform queries in MySQL using Python. As you're aware, working with a database in MySQL involves CRUD operations. Working with databases through Python also involves CRUD operations. The key difference is that the SQL statements used to carry out your operations must be processed in Python as strings. In this video, you'll discover how to execute, create, and read operations in a MySQL database using Python. Little Lemon is populating the restaurant's database with the records of upcoming bookings. Little Lemon also need to retrieve or read this data from their database so they know which guests are attending for dinner. You need to help Little Lemon create and read data in their MySQL database using Python. But first, you need to understand how to create and read data in a MySQL database using Python. Let's get started with creating data. So far, you've learned how to create data in a database using an insert statement, like an insert into command. For example, Little Lemon must use an insert into statement to add the names of customers and the time slots they've booked to the customer name and time columns in a table called bookings in their database. However, there are a few more steps to this approach when working with Python. Create your SQL statement as normal. Then use quotation marks to convert it to a Python string argument. This string argument is passed to a MySQL database through a connector, which parses it into a format that MySQL can understand. So, the first step in the process is to write your SQL statement. Then add a pair of quotation marks to convert it to a Python string argument. Finally, create a variable in which you can store the query as a Python string. Next, Python sends the string to the database through the cursor. The statement is then executed on the database. Little Lemon can use Python to add booking data from guests to their MySQL database using the MySQL insert query variable. The SQL data just needs to be passed in a string format. As you should know by now, you can also retrieve or query data from a database using a select statement. And a SQL select query is also the first step to complete when reading data using Python. Python can read data from a MySQL database using a select statement. And just like with your insert query, you create a variable in which the query can be stored as a Python string, and you write your select query. Make sure that it's written within quotation marks to convert it to a Python string. Little Lemon can use a read data query string object to retrieve all data from their bookings table. They just need to write the select query as a Python string, then use the execute module from the cursor object. Now that you know how to create and read data using Python, let's see if you can help Little Lemon. For the purpose of this demonstration, a connection has already been established between Python, the API, and the MySQL database through the MySQL Connector Python API. So, your first task is to instantiate the cursor object from the connection using the cursor method. The next step is to execute the MySQL insert query by passing it as an argument to the execute method. Once the query is executed, commit the change to the database using the commit method of the connection object. Now, each new instance of customer data is added to the bookings table in the database through the MySQL insert query. For the next stage of development, Little Lemon needs to read or retrieve the data in their database. Some sample customer data has been added to the database to test the read functionality. You need to develop the functionality and retrieve this data. As you learned earlier, the first step is to create a SQL statement as a Python string that you can pass to a variable. In this case, you need to create a SQL select statement that retrieves all data from the bookings table in the database, and pass this statement as a string to the Python variable called readDataQuery. Now you need to pass your query to the execute module on the cursor, just like you did when creating data. Once the query is executed, you need to retrieve the results using the fetchAll method on the cursor. Create a new variable called results, then pass the results of your query to this variable through the cursor object. The results variable is a list data type, and it shows each record in the form of a tuple. So, the results variable is essentially a list of tuples, and each tuple is a single extracted row from the bookings table. In this instance, the items in each tuple in the results variable are ordered in the same way as the columns in the bookings table. They are ordered this way because you're reading all records from the table. You can retrieve the column names by creating a new variable named columns and calling the column names from the cursor object. These values are then stored in the columns variable for later use. Don't forget that it's also good practice to close the cursor object and connection when you no longer need them. You now know how to execute create and read operations in a back-end MySQL database using a front-end Python application. That's a great start. I look forward to guiding you through more CRUD operations in Python. Updating and deleting records in a MySQL database involves routine CRUD operations. They're also common operations for a Python-based application that interacts with the MySQL database. Over the next few minutes, you'll learn how to execute update and delete operations in a back-end MySQL database using Python. Little Lemon needs to update and delete the records of the restaurant guests in the bookings table in their database using Python. You need to help Little Lemon with this task. But first, let's take a quick look at the bookings table. This table holds the booking data of each guest. This includes their booking ID, table number, first and last name, booking slot, and the ID of their waiter. Little Lemon must update and delete data within this table using Python. Let's begin with updating records. As you know from previous courses, data is updated in a database using update statements. Little Lemon needs to update the booking data of a guest. Let's see if you can help them out. You can start by writing a SQL update query that uses a where clause to let Little Lemon update a guest's table number. The update query is created as a string. It's then passed to a string object called update bookings. Little Lemon just needs to update the specific values of each query. Let's test this query by updating the booking information for guest 6, Diana Pinto, who has been moved to table 10. Use the execute method to run the query and update the records in the bookings table in the database. To commit these changes to the table in the database, use the commit method. To check that the data was updated correctly, you can run the print cells of the Jupyter Notebook. The guest with the booking ID of 6 is now assigned to table 10. The update query has worked. There are also times when guests cancel their bookings. When this happens, Little Lemon needs to delete their records from the database. To carry out this task, write a SQL delete statement that deletes the record of a specific guest from the bookings table. Your statement can use a where clause of booking ID. The delete statement is created as a Python string. It's then assigned to a string object called delete booking ID. You can test this query by deleting the booking information for Marcos Romero, who was assigned the booking ID of 4. Use the execute method to run the query. Then commit the changes to the database. Now it's time to check that the query worked with another printout. You can rerun the cells with the initial select query from the Jupyter Notebook. The printout changes if the database has been altered. There's no data in the table for Marcos Romero. This means that your delete statement was successful. You can also amend the where clause in your delete statement to check for null values next to table and employee IDs. If the value is null, then you can set the bookings to be deleted. You now know how to perform update and delete operations in a MySQL database using Python. Great work! When you query records in a database, your query can often return hundreds, thousands, or even millions of results, depending on how much data there is. But you might only require a fraction of these results. As you saw in earlier courses, you can use filtering and sorting techniques to target only the data you need from these results. When querying a MySQL database using Python, you can apply these same techniques to ensure that your query targets specific data. Over the next few minutes, you'll recap some basic filtering and sorting techniques and learn how to filter and sort MySQL data using Python. Over at Little Lemon, the restaurant is currently querying the bill records of each customer in its database. They need the records of all bookings with a final bill greater than or equal to $40. They also need the bookings to appear in ascending order with respect to the total bill amount. Filtering and sorting techniques are a great way to carry out this task. Let's find out how these techniques work with Python and then help Little Lemon. One filtering technique that you should be familiar with is the use of the where clause. Let's begin with a quick recap of the where clause. As you should know by now, you can use this clause to filter and extract records that satisfy a specific condition. For example, Little Lemon can use the where clause to create a SQL select statement that targets the booking ID and bill amount columns in their orders table. The statement returns all values in the bill amount column equal to a value of 40. The where clause helps to filter the records from the database, but not to the extent that Little Lemon require. As you saw earlier, Little Lemon need the records of all bookings with a final bill greater than or equal to $40. You can use comparison operators to specify the exact data you require from a database. For example, Little Lemon can replace the equals operator in their statement with the greater than or equals to comparison operator. This operator targets all records from a database where the bill amount is greater than or equal to a value of 40. This narrows down the records even further, returning much more specific results. Another technique is the order by clause. As you should know, the order by clause is an optional clause that can be added to a SQL select statement. It helps to sort data in ascending or descending order. So, to filter their records even more efficiently, Little Lemon can add the order by clause to the end of their statement. They target the bill amount column and then type the ascending keyword. Once executed, the query returns all bill amounts greater than or equal to $40 in ascending order. Now that you've recapped some examples of filtering and sorting techniques, your next question might be, how can I use these techniques in Python to query a MySQL database? Well, as you saw earlier, Little Lemon need to query the records in their MySQL database using Python. Let's help them create this query using the filtering and sorting techniques that you just explored. To recap, Little Lemon need the records of all bookings with a final bill greater than or equal to $40. They also need the bookings to appear in ascending order with respect to the total bill amount. First, write a SQL select query as a Python string stored in a variable called MySQLQuery. The query must target the booking ID and bill amount columns from the orders table. Use the where clause and a greater than or equal to comparison operator to target all records that are greater than or equal to the value of 40. Then use the order by clause and the ascending keyword to order all records from the bill amount column in ascending order. The next step is to establish a connection through the MySQL Connector Python API between the front-end Python application and the back-end MySQL database. Then get the cursor object from the connection using the cursor method. Run the query using the execute method from the cursor object. Once the query is successfully executed, you can fetch all the results in a new variable called results that satisfies the conditions given in your query. Just use the fetchAll method on the cursor object to grab the query results. All the retrieved data is in results as a Python list of tuples. You can display the list on your dashboard for Little Lemon. Little Lemon now have the data they need, and you should now be able to explain how to make use of filtering and sorting techniques to target records in a MySQL database using Python. Great work! At this stage of your database engineering journey, you should have experience of using join operations to extract data from multiple tables. There are also instances in which you'll need to perform a join operation on a MySQL database using Python. In this video, you'll explore the process for executing join operations using Python. Little Lemon are adding a new menu feature to their website. This feature lets customers view menu items, their prices, and the type of cuisine each meal is related to. The data that the feature requires is in two different tables in their MySQL database: menu and menu items. Little Lemon need to use a join to combine the data from these tables to create their menu feature. Let's quickly recap the concept of a join. A join is created using the SQL join clause. It targets a common column between the two target tables. These common columns are used to join the tables together and extract the required records. Some examples of joins used in MySQL include left join, right join, inner join, and outer join. All these joins can be used with Python. Let's explore an example of the syntax and process for creating an inner join. First, a SQL query is created using join as a Python string that can be passed to a variable. The query is then run using the execute method from the cursor object. Once the query is executed, you can retrieve its results into another variable. Use the fetchAll method on the cursor object that holds the results of the join. The data is retrieved as a list of tuples. For example, Little Lemon can create a join query as a string object in Python that combines the menu items and menu tables. This join is performed using an inner join on the item ID column, which is common to both tables. When executed using Python on a MySQL database, this statement returns all required results. Now that you're familiar with the process for joining data from different tables using Python, let's see if you can help Little Lemon to create this query. As you learned earlier, Little Lemon need to use a join query to extract the data for the new menu feature on their website. They begin by creating the join statement as a string object in Python. Store it in a variable called myJoinQuery. The join query must target the name, type, and price columns from the menu items table, and it must also target the cuisine column from the menu table. An inner join is created on the item ID column, which is common to both tables. Let's assume that the MySQL Connector Python API is running a connection between the front and back end, and that the cursor object is also available. This means that you can now execute your query using the join statement. Run the query using the execute method from the cursor object. When the query is executed, you can fetch all the results from the cursor object in a new variable called results using the fetchAll method. The results are retrieved as a list of tuples, one for each row. Little Lemon can view the order of each individual entry. They just call the column names attribute on the cursor to return the names of the column in order. At this stage of your database engineering journey, you should have experience of using joins to extract data from multiple tables. And you should now be familiar with extracting data from a MySQL database using joins in Python. Well done! Congratulations! You've reached the end of the second module in this course. You should now be familiar with how to perform queries in a MySQL database using Python. Let's take a few moments to recap some of the key skills that you've gained in this module's lessons. In the first lesson, you learned how to perform create, read, update, and delete, or CRUD operations in a MySQL database using Python. You started this lesson with a recap of how to create data in a MySQL database using an insert statement. You then learned how data is inserted into a MySQL database using Python. First, it's created as a Python string argument. This argument is then passed to a MySQL database using a connector. The connector parses it into a format that MySQL can understand. You then explored an example of the syntax used to render a MySQL database query as a Python string argument. And you explored an example of creating and reading data using Python from the Little Lemon database. Next, you recapped how to delete and update records in a MySQL database using update and delete operations. You learned how to create these queries as Python string arguments, and explored some examples from the Little Lemon database. You then undertook a series of lab exercises in which you received the opportunity to perform CRUD operations in your own MySQL database using Python. And you tested your knowledge of these topics by completing several quizzes. In the second lesson of this module, you learned how to perform advanced queries in a MySQL database using Python. You began the lesson by learning how to filter and sort records in MySQL using Python. You recapped the basic filtering and sorting techniques that you learned in other courses. These include the use of the where clause to satisfy one or more specific conditions, utilizing the order by clause to sort data in ascending or descending order, and the inclusion of comparison operators to specify the exact data required. You then discovered how these techniques are used in Python by exploring several examples from the Little Lemon database. The next part of this lesson focused on joining data from different tables in a MySQL database using Python. You recapped the basics of the join clause and how it can be used to target a common column between two target tables. You then learned how join can be used with Python to extract data from a MySQL database. A SQL query is created using join as a Python string. The string is executed using the execute module on the cursor object. The results are then retrieved from the MySQL database using another variable that satisfies the query's conditions and the fetchAll method. You also explored an example of this process from the Little Lemon database. And, just like the first lesson, you also completed a lab exercise. In this lab exercise, you performed a join operation using Python to extract data from a MySQL database. You then tested your knowledge of the process in a quiz. You should now be equipped with the skills and knowledge required to perform queries in a MySQL database using Python. Well done! I look forward to guiding you through the next module, in which you'll explore the topic of advanced database clients. There are many different types of tasks that you need to perform when working with a MySQL database. Functions are a great way to store the syntax that you need for these tasks as reusable blocks of code. These code blocks mean that you don't have to retype your code each time you need to use it. Over the next few minutes, you'll recap the basics of functions and learn how they're used with Python. Little Lemon's MySQL database holds a lot of data on different aspects of the company, like customer behavior and sales revenue. Little Lemon can use functions to perform specific operations on their database and return results. They can then use the data from these results to improve the restaurant's performance. So, let's quickly recap the basics of MySQL functions. As you probably already know, a MySQL function is a piece of code that performs a specific operation and returns a result. In other words, it's a task that combines a set of instructions and produces results in the form of an output. MySQL functions provide a lot of advantages for database engineers. Some MySQL functions accept parameters or arguments, while others don't. They're great for manipulating data in a database. You can also create custom functions that combine several tasks in a block of code. You can then store these functions within your database and invoke them when needed. And, as you've just discovered, MySQL functions are reusable, so they can be used to complete repeat tasks. At this stage of your database engineering journey, you've probably made use of many different types of functions. The most common built-in functions available in MySQL include string functions, numeric functions, and date and time functions. There's also comparison and control flow functions. Let's take a moment to recap the basics of these different types of functions and look at how Little Lemon can make use of them. Let's begin with string functions. These functions are used to manipulate string values, like adding strings together or extracting a segment of a string. An example of a string function is concat. Concat combines data from two separate tables into one string. Little Lemon can use a concat string query function on their database records to extract information on each customer, like how much money they spent. You can also use numeric functions in MySQL. Numeric functions include aggregate and math functions. These functions are used to carry out common tasks on numeric datasets. For example, Little Lemon can use the average numeric function to determine the average dollar amount that each customer spends with the business. Another example of MySQL functions includes date and time functions. Date and time functions can be used to query a MySQL database to extract date and time values in a range of different formats, depending on the query. Over at Little Lemon, they often extract date and time data to analyze the behavior of their customers. They can use this data to find out how long guests spend at the restaurant and which days are the busiest. Next up is comparison functions. You can use these functions to compare values within a database, and they can be used with many different types of values, like numerical, strings, and characters. Little Lemon make use of comparison functions to identify the best and lowest selling items on their menu by using greatest and least comparison functions on their sales data. And finally, there's control flow functions. Control flow functions are used to evaluate conditions and determine the execution path or flow of a query. For example, as you learned previously, the case function runs through a set of conditions within a case block. It then returns a value once a condition is met, or a null value if no conditions are met. Little Lemon often rely on control flow functions to determine which items on their menu are loss-making and which items have turned a profit. Now that you've recapped the different functions available in MySQL, let's find out how they work with Python. Let's take the example of numeric functions and see how Little Lemon calculate the mean or average bill for each customer. They can create a select query that uses the average function to determine the average bill amount. This query is passed to the database to be executed. Once the query is executed, Little Lemon can access the results and see the average dollar amount each client spent with the business. This is just a basic recap of MySQL functions and a short demonstration of how they work in Python. The rest of this lesson will explore methods for accessing MySQL functions using Python in more detail. I'm looking forward to exploring this topic in more detail with you. As a database engineer, you can use date and time functions to extract time and date values from a database. And you can perform similar tasks using the functions available in Python's native datetime library. In this video, you'll learn about the different datetime functions available in Python and how you can make use of them. Little Lemon has received several bookings from guests for tonight. However, the restaurant has encountered a scheduling conflict, so they need to push each booking slot forward by 1 hour. Python's datetime functions are a great way to solve this problem. Find out how datetime functions work, then help Little Lemon to update their booking slots. Let's begin with an overview of datetime. Datetime is a Python class with several built-in functions that can be used to format and change time and date variables. It's native to Python, so you can import it without requiring pip. Let's review the functions that Python's datetime library offers. The datetime_now function is used to retrieve today's date. You can also use datetime_date to retrieve just the date, or datetime_time to call the current time. And the time_delta function calculates the difference between two values. Now let's look at the syntax for implementing datetime. To import the datetime Python class, use the import code followed by the library name. Then use the as keyword to create an alias of dt. You can now use this alias to call the library instead of typing datetime every time you need to use a function. you now have a datetime object created within your Python environment. So, let's find out how to make use of its functionality using the dateTimeNow function. Begin by creating a variable called currentTime. Next, type the DT alias as the module name. Then use it to call the dateTimeNow function. Finally, instruct Python to print the current date and time values. Execute the code to print the time and date of your location. Python returns the date and then the time. The date is displayed in year, month, day format. The time is displayed in hours, minutes, seconds format. But what if you just need to know the current time? Or maybe you just want today's date? You can use the same code again, but this time give Python two separate print instructions. The first instruction tells Python to print the current date, and the second instruction tells Python to print the current time. When the code is executed, Python displays each value separately. Let's look at a slightly more complex function, time delta. When making plans, it can be useful to project into the future. For example, what date is this same day next week? You can answer questions like this using the time delta function to calculate the difference between two values and return the result in a Python-friendly format. So, to find the date in 7 days' time, you can create a new variable called week. Type the DT module and access the time delta function as an object instance. Then pass through 7 days as an argument. Finally, instruct Python to print the results of the variable. When executed, Python returns the value of the date 1 week from now. Now that you know how datetime works, let's see if you can help Little Lemon. As you learned earlier, Little Lemon have encountered a scheduling conflict. To resolve it, they need to push each booking slot forward by 1 hour. You can carry out this task by instructing Python to retrieve the data from the bookings table and then adding 1 hour to each booking. Let's assume that Little Lemon have already passed through their login details, created a new cursor instance, and pointed the cursor at their database. Your first task is now to import the datetime library so that you can work with datetime. Use the import keyword and import the library using the alias DT. This alias is used for greater efficiency. Next, write a SQL select statement to return all data from the bookings table. Pass the statement to the execute module from the cursor as a string argument. Before entering the loop, instruct Python to print the column names from the bookings table so that you can view each item in the row. You can assign these values to variables and create a new variable called new booking slot that holds the values for the updated time slots. To add an hour to each time slot, pass an argument of 1 hour to the time delta function, and then add the function to the booking slot variable. Finally, instruct Python to print the values for the new booking slots in the form of a text string. This text string details the values of each booking ID along with its respective old and new booking slots. Loop through the results from the query and extract the rows from the booking ID and booking slot columns. As the results show, booking ID is the first value and booking slot is the fourth value. You should now be familiar with the different datetime functions available in Python and how you can make use of them. Working with datetime functions can be difficult, but you've made a great start towards mastering this topic. As a database engineer, you can use date and time functions to extract time and date values from a database. And you can perform similar tasks using the functions available in Python's native datetime library. In this video, you'll learn about the different datetime functions available in Python and how you can make use of them. Little Lemon has received several bookings from guests for tonight. However, the restaurant has encountered a scheduling conflict. So they need to push each booking slot forward by 1 hour. Python's datetime functions are a great way to solve this problem. Find out how datetime functions work, then help Little Lemon to update their booking slots. Let's begin with an overview of datetime. Datetime is a Python class with several built-in functions that can be used to format and change time and date variables. It's native to Python, so you can import it without requiring pip. Let's review the functions that Python's datetime library offers. The datetime_now function is used to retrieve today's date. You can also use datetime_date to retrieve just the date, or datetime_time to call the current time. And the time_delta function calculates the difference between two values. Now let's look at the syntax for implementing datetime. To import the datetime Python class, use the import code followed by the library name. Then use the as keyword to create an alias of dt. You can now use this alias to call the library instead of typing datetime every time you need to use a function. You now have a datetime object created within your Python environment. So, let's find out how to make use of its functionality using the datetime_now function. Begin by creating a variable called current time. Next, type the dt alias as the module name. Then use it to call the datetime_now function. Finally, instruct Python to print the current date and time values. Execute the code to print the time and date of your location. Python returns the date and then the time. The date is displayed in year, month, day format. The time is displayed in hours, minutes, seconds format. But what if you just need to know the current time? Or maybe you just want today's date? You can use the same code again, but this time give Python two separate print instructions. The first instruction tells Python to print the current date, and the second instruction tells Python to print the current time. When the code is executed, Python displays each value separately. Let's look at a slightly more complex function, time_delta. When making plans, it can be useful to project into the future. For example, what date is this same day next week? You can answer questions like this using the time_delta function to calculate the difference between two values and return the result in a Python-friendly format. So, to find the date in 7 days' time, you can create a new variable called week. Type the dt module and access the time_delta function as an object instance. Then pass through 7 days as an argument. Finally, instruct Python to print the results of the variable. When executed, Python returns the value of the date 1 week from now. Now that you know how datetime works, let's see if you can help Little Lemon. As you learned earlier, Little Lemon have encountered a scheduling conflict. To resolve it, they need to push each booking slot forward by 1 hour. You can carry out this task by instructing Python to retrieve the data from the bookings table and then adding 1 hour to each booking. Begin by creating a connection between the front-end Python client and the back-end database. Then pass through your login details. This creates a new cursor instance and points the cursor at the Little Lemon database. Before you can begin working with datetime, you first need to import the datetime library. Use the import keyword and import the library using the alias dt. This alias is used for greater efficiency. Next, write a SQL select statement to return all data from the bookings table. Pass the statement to the execute module from the cursor as a string argument. Before entering the loop, instruct Python to print the column names from the bookings table so that you can view each item in the row. You can assign these values to variables and create a new variable called new booking slot that holds the values for the updated time slots. To add an hour to each time slot, pass an argument of 1 hour to the time_delta function, and then add the function to the booking slot variable. Finally, instruct Python to print the values for the new booking slots in the form of a text string. This text string details the values of each booking ID along with its respective old and new booking slots. Loop through the results from the query and extract the rows from the booking ID and booking slot columns. As the results show, booking ID is the first value and booking slot is the fourth value. You should now be familiar with the different datetime functions available in Python and how you can make use of them. Working with datetime functions can be difficult, but you've made a great start towards mastering this topic. Stored procedures provide database engineers with a useful way of storing and recalling code when needed. Over the next few minutes, you'll receive a quick recap of MySQL stored procedures and how they work. Let's begin with a look at how stored procedures can help Little Lemon. Little Lemon checks the online bookings in its database every morning for a list of customers attending the restaurant that day. They rewrite the same code each morning to extract this data. But they could instead invoke a stored procedure that extracts the required data without the need to rewrite large blocks of code every morning. Before you find out how they can do this, let's recap the basics of stored procedures. A stored procedure is a block of code, or one or more pre-prepared queries that can be stored in your database. You can then invoke or call the stored procedure as required. As you might already know, this is similar to how a function works, but don't forget the key difference between the two concepts. Functions can only have input parameters, but a stored procedure can have both input and output parameters. There are 3 main steps to complete when using stored procedures. You should already be familiar with these. First, you create a stored procedure, then you call a stored procedure, and finally, you can drop or delete a stored procedure. Let's begin with a recap of the benefits of stored procedures. Your code is more consistent. The same code block is used each time it's invoked. You know exactly what to expect from it. Your code is reusable. You can use it as many times as you need across all your database tasks. And your code is easier to use and maintain. It's stored as one block that can be invoked, edited, or dropped as required. Next, let's quickly recap the syntax for creating a stored procedure. To create a stored procedure, begin with the create procedure command. Then write the procedure name and a pair of parentheses to hold the parameters. Make sure that you include all required parameters within the parentheses. Finally, write the rest of the procedure logic. Then, when you need to invoke the procedure, you just type the call command followed by the procedure name. Don't forget to include the parentheses. And if you need to remove or drop a stored procedure from your database, then just type the drop procedure command followed by the procedure name. In this instance, you don't need to include any parentheses. Little Lemon can use this code to create a stored procedure that extracts the details of the customers due to visit the restaurant. They begin with the create procedure command. Then they name the procedure, daily_customer_details, and add the parameters. Finally, they write the logic of the procedure. Now, each morning, they just need to type the call command followed by daily_customer_details. The stored procedure then extracts the required customer data from the database. So, now that you've recapped the concept of stored procedures, you might be asking yourself, how do stored procedures relate to Python? Stored procedures increase the performance of Python applications and reduce traffic between the application and the MySQL database. The application only needs to send the name of the stored procedure and parameter to the database, instead of a large block of SQL statements. You're now familiar with the benefits of stored procedures and how to create, invoke, and drop them in a database. You're now ready to learn how to perform these actions using Python. Great work! You should be familiar with creating stored procedures in a MySQL database, but how can you make use of stored procedures using Python? In this video, you'll learn how to access stored procedures using Python. Little Lemon Restaurant have a new promotional campaign where they give vouchers to all guests who spend $50 or more on a meal. To find out which guests qualify for vouchers, the team need to retrieve the guest names, booking IDs, and bill amount data from the bookings and orders tables in the database. You can complete this task using a join operation, but performing a separate join operation for each guest is time-consuming. A better solution for Little Lemon is to create a stored procedure they can call using Python. Let's see if you can help Little Lemon to build a stored procedure using Python. The first step is to create the stored procedure as a Python string stored in a variable called stored procedure query. Next, type the create procedure command and then the name of your procedure, which is get customers and bills. Then create a begin-end block. Type the logic of your stored procedure within this block using a SQL select statement. The statement concatenates the required data from both tables with the use of an inner join for all customers who've spent $50 or more. Don't worry about setting the delimiter before and after the procedure. The cursor executes the entire Python string as one MySQL statement. So, unlike with a traditional MySQL query, there's no need for a delimiter. In Python, the stored procedure is passed as a single Python string. It can also include multiple SQL statements. When executing MySQL statements through an API, the required closing semicolon is automatically appended to the end of the string. When executing a stored procedure, you need to store a block of code on the MySQL database that you can invoke when required. You can trigger this block with the cursor call procedure or call proc method. The cursor carries the stored procedure as a string in its execute module and stores it in the MySQL database. You are now ready to execute the stored procedure statement and store it on the MySQL database using Python. Call the execute method from the cursor object and pass the procedure to it as an argument. If executed successfully, the procedure is stored in the MySQL database. Now you can call this procedure. First, you need to call or invoke the procedure. You can do this using the cursor object's call proc method. Pass the name of the procedure to the module on the cursor object as an argument. Next, you need to retrieve the procedure's results. You can make use of Python's built-in next function to complete this task. Invoke the stored results module as an argument to the next function and store them as a Python variable called results. The next function is used to return the next item from the stored results iterator. The entire result set from the MySQL server is then buffered in the results variable. Now you can invoke the fetchAll method on the results variable and save it as dataset. Once the code has been run successfully, the dataset returns a Python list of tuples. Each tuple is an individual record or row from the stored procedure. You can index the dataset or run the for loop to print all records. The results of the procedure show that there is one guest who has spent $50 or more with Little Lemon and qualifies for vouchers. You now know how to access stored procedures using Python. Great work! A MySQL database needs to provide access to many users at once, and each connection must be secure and stable so that only authenticated users can gain access and there's no risk of their connections failing. But managing secure and stable connections requires many resource-heavy actions. So how can you perform these actions efficiently? The answer lies in database connection pooling. In this video, you'll explore the concept of database connection pooling, investigate how it works, and learn about its advantages. Little Lemon's website has a Python-based application that lets guests book time slots with the restaurant. The application sends the guests' bookings as SQL statements to the Little Lemon database. However, the website needs to provide each guest with a secure and stable connection to the Little Lemon database. This is so that they can input their booking data without any risk of connection failure. Little Lemon can manage these connections with the use of database connection pooling. Let's find out more. Database connection pooling involves creating and managing a pool of connections to run faster, more efficient, and optimized connections between clients and a MySQL database. To gain a better understanding of how connection pooling works, let's explore a visual example. Visualize a pool of 4 open connections to a MySQL database. 2 of the connections are currently being used by clients to access the database. The other 2 connections are free and ready to use by any new user. A new user can arrive and request access to the database. The connection pool then assigns this new user one of the open connections. Shortly after the new user is assigned their connection, the first 2 users complete their tasks, end their sessions, and leave the pool. Even though the users have left the pool, the connections remain open. Technically speaking, the connections aren't closed. They're just placed back in the connection pool where they remain available for new users. There are now 3 free and ready-to-use connections that can be assigned to new users. But what if all 4 connections are in use and a 5th user wants to join? There are only 4 connections available. So how can you serve the fifth user's access request? To avoid this situation, the best approach is to create multiple pools with a specific number of connections assigned to each pool. This means that different users can be assigned to different pools. So, there's always an available connection in at least one pool for new users. You can also program the system to create a new connection within a pool if an appropriate connection isn't available in other pools. Little Lemon can use this approach to manage connections to their MySQL database. They can create a series of connection pools that their guests can use to record their bookings in the database. There are a few key advantages to connection pooling. Connection pooling makes efficient use of available resources. It reduces the time and effort required to establish connections. Connection pools simplify programming models, and they increase the performance of the Python application when connecting to the MySQL database. You should now be familiar with the concept of database connection pooling, be able to explain how it works, and to describe its advantages. There's lots more to learn about connection pooling in this lesson, but you're off to a great start. Database connection pools are a great way of providing secure, authenticated connections to a database for multiple users. And the MySQL Connector Python API provides a useful method for developing connection pools in the form of the MySQL Connection Pool module. In this video, you'll learn how to create a connection pool for a database using the MySQL Connection Pool module. Little Lemon need to provide secure, authenticated connections to their database for their team of web developers. They've decided that the most efficient way of providing these connections is through connection pooling. Let's take a few minutes to find out how to build a connection pool. Then use your new skills to help Little Lemon build a secure connection pool. A database connection pool is managed and maintained using a module called MySQL Connection Pool. The module is held in a directory called mysql.connector.pooling. You can import the module into your working environment and access its functionality using the import syntax. And the from keyword is used to identify the module's location. In other words, the code is instructing Python to access the subdirectory and return the MySQL Connection Pool library. The MySQL Connection Pool module has many useful functions and attributes that you can make use of. Let's look at a few of these. The pool name class attribute is used to identify the name of the pool to be used in the connection. If you don't specify a pool, then one is automatically generated instead. You can create as many pools as you need. The pool size attribute states the number of connections that have been created for a pool. The default number of connections is 5, but you can create up to 32 connections for a single pool. And finally, there's the connection ID attribute. This is a unique ID assigned to each connection in the pool. There are also many class methods available in the MySQL Connection Pool module. You can use the getConnection method to request a connection. The pool then assigns a free connection if one is available. If no connection is available, then you'll receive a pool exhausted error instead. The isConnected method is a Boolean function that returns either a true or false value depending on whether a connection has been made. This is a useful way of avoiding errors. Finally, the close method informs the connection pool that a user has completed their session. The user no longer needs the connection, so the connection can be placed back into the pool as an available connection for any new users who need it. Now that you're familiar with the module connection pool, let's see if you can help Little Lemon. As you learned earlier, Little Lemon want to create a connection pool to provide users with efficient access to their database. Before you can create a connection pool, you first need to import the MySQL Connection Pool library using the MySQL Connector Python API. Once you've imported the connector, the next step is to make a connection to the database. Call the pool Little Lemon Pool, then use the pool size attribute to specify 4 connections. Use the local host as your host and place the pool on the Little Lemon database. Then type the username and password. All this code is passed as arguments or parameters to the MySQL Connection Pool module and assigned to the pool. Next, you need to create a Python list of users for the connection pool. You can call this list users. Populate the list with members of Little Lemon's guest list. You then need to create a SQL select statement. This statement must accept an integer. The integer must correspond with different ID requests accessing different data points as database users. Now you need to use the for loop. You can use it with the range function. The range function is used with the pool size attribute. This means that no matter how big the pool is, the loop always runs to the end. The next step is to set up the application's connection. Write a statement that checks if a connection was successfully made within the pool. This statement also avoids any errors appearing in your code. Then write a statement that instantiates a new cursor from the existing active pool connections. This action must occur for each new live connection that's successfully made with the pool. Next, create a print statement that displays the following information on screen: the user requesting information from the database, the unique connection assigned to this user, and the unique booking ID that they're requesting. The print statement is formatted using curly braces. These symbols take the specified variables in the order that they are specified from the format function. So, this means that the information is printed in the order you specify. The next line of your code is a parameterized select statement. This statement uses the initial SQL select statement from earlier and combines it with the incremented I to assign a different booking ID to each user. Then you can use the fetchAll method to return all information that corresponds with this SQL select statement and print the information on screen. You can also create an else statement that generates an error message on screen if a live connection cannot be found. Finally, use the close method to return a user's connection back to the pool when they have ended their session. You should now know how to create a connection pool for a database using the functions and attributes available with the MySQL Connection Pool module. Congratulations! You've reached the end of the third module in this course. You should now be familiar with how to make use of functions and stored procedures in a MySQL database using Python, along with creating and managing database connection pools. Let's take a few moments to recap some of the key skills that you've gained in this module's lessons. In the first lesson of this module, you learned how to make use of MySQL functions using Python. You began with a quick review of MySQL functions by reminding yourself of the advantages that functions offer. Their main advantage is that they eliminate the need to carry out repetitive tasks. You also familiarized yourself with many of the common MySQL functions that you explored in earlier courses. These included string, numeric, and date and time functions, as well as comparison and control flow functions. You recapped how string functions are used to manipulate string values. You learned how to make use of numeric functions to perform tasks on numeric datasets. You saw how you can extract date and time values from a database using date and time functions. You received a reminder of how to compare values within a database using comparison functions. And you reviewed the process steps for using control flow functions to evaluate conditions and determine the execution path or flow of a query. You then learned how to access MySQL functions using Python by exploring examples from the Little Lemon database. And you also demonstrated your new skills and knowledge in the lab and quiz activities. In the second lesson of this module, you recapped the basics of stored procedures. You learned once again that a stored procedure is a block of code that can be stored in your database and invoked as required. Stored procedures offer several advantages, like consistent code, reusable code, and the ability to maintain code as one single block. You then recapped the syntax used to create stored procedures, including the create procedure, call, and drop procedure commands, and the begin-end block. And you examined the advantages of using stored procedures with Python. You saw that they increase the performance of Python and reduce traffic between Python and MySQL. In the next item in this lesson, you learned how to access stored procedures using Python. You explored some examples of stored procedures from Little Lemon, like the inner join operation. You saw how they made use of these stored procedures in Python to query a MySQL database. You also learned how to call or invoke a procedure in Python using the callproc method, retrieving results using Python's next function, And you saw an example of the use of fetch all method. Once a stored procedure has been successfully run using Python, the data is returned as a list of tuples. You can index the dataset or run the for loop to print all records. You then demonstrated your ability to use stored procedures in Python in a lab environment. And you tested your knowledge of Python and stored procedures in a quiz. In the third and final lesson of this module, you learned about connection pools. During this review, you learned that connection pools are resource efficient, provide faster connectivity, simplify programming models, and increase the performance of Python applications. You then learned about Python MySQL connection pools. You learned that a database connection pool is managed and maintained using a MySQL connection pool module. This module is imported into your working environment so that you can access its functionality. The module also offers many useful functions and attributes that you can make use of. This includes pool name, pool size, and connection ID. And there are also several class methods available like getConnection, isConnected, and close. These methods are useful for managing and maintaining the module. You then explored an example of how to create a MySQL connection pool using the MySQL Connector Python API. You also explored the concept of database connection pooling. You learned that database connection pooling involves creating and managing a pool of connections to run faster, more efficient, and optimized connections between clients and a MySQL database. Connections are managed between clients, and users can drop in and out of sessions by using active connections. And you can create multiple pools with specific numbers of connections so that there's always an available connection for every user. You then completed a lab in which you worked with connection pools, and you tested your knowledge of connection pools in a quiz. You should now be equipped with the skills and knowledge required to work with MySQL functions and stored procedures using Python, and you should also now be able to create and manage database connection pools. Well done! I look forward to guiding you through the next module in which you'll work with a database client. In this course, you learned about database clients. Let's take a few moments to recap the key lessons that you encountered in this course. You started the module by learning about the MySQL Connector Python API and how to make use of the pip package. You then learned how to install a front-end Python client and connect it to a back-end MySQL database. You then explored how to establish communication between Python and MySQL to perform CRUD operations. Once you established a connection, you then accessed a cursor object. Once you had access to the cursor object, you created a MySQL database and table using Python. You then committed changes in a MySQL database using Python. In the third and final lesson of Module 1, you explored the concept of cursors in a MySQL database. You learned how cursors work in Python and MySQL. You also reviewed the key characteristics of cursors and learned that they're read-only, non-scrollable, and asensitive. You then learned that the cursor class is used to translate communication between Python and a MySQL database. And you also learned how to identify different cursor classes. And you also reviewed the basics of interleaving requests. The second module focused on performing create, read, update, and delete, or CRUD operations in a MySQL database using Python. You began the module by learning how to create and read records in a database. You reviewed the steps for this process and discovered how Python communicates with a database to carry out these actions. You then learned how to perform MySQL update and delete operations using Python. And you learned how to commit the changes to the database. You completed this first lesson by performing a series of lab exercises in which you demonstrated your ability to carry out CRUD operations in a MySQL database using Python. In the second lesson of Module 2, you learned how to perform advanced queries in a MySQL database using Python. The first of these queries involved filtering and sorting data in a MySQL database using Python. You recapped the basics of MySQL filtering and sorting techniques from earlier courses and learned how these same techniques are applied to Python. Next, you learned how to perform a range of different join operations to join data from different tables in a MySQL database using Python. You then received an opportunity to test your ability to perform advanced queries in MySQL database using Python through a series of labs. Module 3 focused on advanced database clients. The first lesson in this module began with an overview of how to use MySQL functions with Python. You began by learning how to identify the importance of MySQL functions, and you reviewed the different types of functions available in MySQL. You also learned how MySQL makes use of functions using Python. Once you finished recapping the basics of MySQL functions, you then learned how to implement or access MySQL functions using Python. You also explored datetime functions in Python and learned how to make use of these functions to update a MySQL database using Python. You then demonstrated your ability to make use of these functions in lab exercises. In the second lesson in this third module, you explored how to use MySQL stored procedures with Python. You recapped the basics of stored procedures and learned how they differ from functions and why they're used with Python. You then learned how to access stored procedures through Python with the use of the callproc method. And you also reviewed the use of delimiters. The third and final lesson in this module focused on connection pools. You began by developing an understanding of the concept of database connection pooling. You learned how to explain database connection pooling, and you learned how to identify the advantages of database connection pooling. You then reviewed the steps for creating a connection pool for a database, including the process for implementing the connection pool SQL module. You've reached the end of this course recap. It's now time to try out what you've learned in the graded assessment. Good luck. You've reached the end of this course. You've worked hard to get here and developed a lot of new skills along the way. You're making great progress on your MySQL journey, and you should now understand database clients. You were able to demonstrate some of this learning along with your practical MySQL skill set in the lab project. Following your completion of this lab project, you should now be able to interact with the MySQL database using Python, perform queries in MySQL using Python, and make use of MySQL functions, procedures, and connection pools. The graded assessment then further tested your knowledge of these skills. However, there's still more for you to learn. So, if you found this course helpful and want to discover more, then why not register for the next one? You'll continue to develop your skill set during each of the database engineer courses. In the final lab, you'll apply everything you've learned to create your own fully functional database system. Whether you're just starting out as a technical professional, a student, or a business user, the course end projects prove your knowledge of the value and capabilities of database systems. The lab consolidates your abilities with the practical application of your skills. But the lab also has another important benefit. It means that you'll have a fully operational database that you can reference within your portfolio. This serves to demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. And once you've completed all the courses in this specialization, you'll receive a certificate in database engineering. The certificate can also be used as a progression to other role-based certificates. Depending on your goals, you may choose to go deep with advanced role-based certificates, or take other fundamental courses once you earn this certificate. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.
Welcome to the next course in database engineering. The focus of this course is on advanced data modeling. Let's take a few moments to review some of the new skills that you'll develop in these modules. You'll begin the course with an introduction to the topic of advanced database modeling. You'll learn that a data model provides a visual representation of different data elements and shows how they relate to one another. You'll also discover how data modeling is used at Meta. You'll then explore database modeling in more detail by learning about different kinds of data models. You'll discover that there are 3 levels of database models. There's the conceptual data model, the logical data model, and the physical data model. You'll also review different kinds of models that you can use to design your database. Next, you'll learn how to structure your tables to remove anomalies using database normalization. These include the insertion anomaly, the update anomaly, and the deletion anomaly. You'll also explore an example of a data model and design a database model in an exercise. In the next lesson of this module, you'll receive an introduction to MySQL Workbench. You'll learn that MySQL Workbench is a unified visual tool for database modeling and management. It offers a range of useful features for creating, editing, and managing databases. You'll then discover how MySQL Workbench is used to build a data model diagram. And you'll then learn how MySQL's Workbench forward engineer feature is used to turn this model into a database schema in MySQL. You'll also learn how you can use MySQL to reverse engineer a model. This means you can create a data model, or ER diagram, from an existing database. This is essentially the opposite to the forward engineer feature. And you can print the model, share it, or apply changes and push it to the database using the forward engineering method. You'll also complete this lesson with a quiz item and an exercise in which you'll design your own database model in MySQL Workbench. In the next module, you'll explore the topic of data warehousing. In this module, you'll learn about the architecture of a data warehouse and build a dimensional data model. You'll begin with an overview of the concept of data warehousing. You'll learn that a data warehouse is a centralized data repository that loads, integrates, stores, and processes large amounts of data from multiple sources. Users can then query this data to perform data analysis. You'll then discover that a data warehouse is defined by 4 key characteristics. It's subject-oriented, it's integrated, a data warehouse is also non-volatile, and finally, data warehouses are time-variant. You'll also review the different forms of data that a data warehouse handles, including structured data, semi-structured data, and unstructured data. You'll then explore the architecture of a data warehouse and learn that it includes the following components: data sources, the data staging area, which includes the ETL process, the data warehouse itself, and data marts. Once the data has been loaded from the data sources, it is then integrated and stored in the data warehouse. It's then organized in data marts, where users can perform data analysis and present their findings. These components control the flow of data from different sources. They also process and integrate this data so that the user can perform data analysis. You'll also explore a case study of a real-world data project. In the second lesson of this module, you'll explore dimensional data modeling. The lesson begins with an overview of the fundamentals of dimensional data modeling. You'll learn that it's based on dimensions and facts, and it's designed using star and snowflake schemas. You'll then explore some examples of dimensional data modeling in practice and learn that there are 4 key steps to follow when creating a model. Choose the business process to explore, choose the grain or level of granularity, choose the dimensions, and choose the facts. Once you've made all these choices, you can then create the schema. Finally, you'll undertake an exercise in which you'll create your own dimensional model. In the third module of this course, you'll explore data analytics in the context of dimensions and measures, and you'll learn how to perform visualized data analysis using an advanced analytics tool. You'll start with an overview of data analytics. You'll recap the basics of data analytics and the key types of data analytics that you've made use of at other points in your database engineering journey. You'll also learn that there are 2 generic types of data you'll deal with: quantitative data, which refers to numerical data, and qualitative data, which refers to non-numerical data. When you've determined what kind of data you need, you can process and analyze it using 4 measurement scales: the nominal scale, the ordinal scale, the interval scale, and the ratio scale. Next, you'll learn about the topics of data mining and machine learning. You'll learn that data mining is the process of detecting patterns in data, while machine learning is the process of teaching a computer how to learn. Machine learning makes use of data mining models to process data like classification analysis, the associate rule, clustering analysis, and regression analysis. You'll then learn about data visualization. You'll learn that when visualizing your data, you must consider your audience and the information they're looking for. You'll then need to choose an appropriate chart that best communicates this information. Finally, you'll conclude this lesson with a discussion around what kind of data analytics reports you make use of. In the final lesson of this module, you'll review the topic of data analytics and learn how to make use of data analytics tools like Tableau. As part of your introduction to Tableau, you'll learn what its key features are and how they help you perform data analytics. You'll then learn how to use Tableau to analyze data. You'll learn how to download, launch, and navigate Tableau, load and prepare data for analysis, filter and visualize data, and create an interactive dashboard. Finally, you'll complete an exercise in which you'll perform data analysis in Tableau. Now that you've reached the end of this course introduction, it's time to get started on your advanced data modeling journey. Good luck.
The way the industry has developed with the internet, Web3, the metaverse, you are going to be working on systems that connect to a database. There are very few jobs that won't require this, so this is one of the most important fundamental skills that you can learn for a successful career. Hi, my name is Moxie. I use they, them pronouns. I am a software engineer at Meta in the Menlo Park office. There's not a one-size-fits-all process for data modeling. The process for developing a new data model for a new product is very different than retrofitting an old product to add a new feature or to comply with a new regulation. And so you will have to adjust your process accordingly to the needs that you're encountering. And that's why these skills are so important to learn. Data modeling is conducted by different people depending on the context we are changing or creating a data model for. If we are building a new product and we already have the business case, this will be led by a lead engineer, generally discussing what the high-level needs of the product are. If we are changing data model for user privacy or for a specific feature, the person leading that discussion may be the individual engineer, or it could be someone involved in the regulatory processes. One thing that's very important about Meta is that every engineer is empowered to add to the discussion and change things. And so even though it may be a lead engineer that's designing the first data model and bringing it forward, every engineer is expected to be able to talk about it and bring forward their ideas to improve our data models for our user needs and our product. One of the challenges at Meta around data modeling is making sure that we are using our user data properly, and that when we are accessing new data, that we are being responsible with that data. This is a big challenge because there's a lot of data that we have access to, and we want to make sure we're only using the specific needs that we have and getting actually approvals for all these things. And this can be a very arduous process because we do have to justify where we're getting our data from, how we're using it, how we're storing it, how long we're storing it for. There's a lot of details, and you have to be very prepared for those meetings and very prepared to justify why or why not you're including some data. Managing changes to a database is a very complicated process, and there's a lot of teams at Meta dedicated to ensuring that the data is stored securely, that it's reliable, that there's fallbacks. There's a lot of considerations you have to take into from an engineering perspective, but from an overall infrastructure, there is a lot of teams managing and deploying the code and the database changes in order to make this work. So something like Meta or Facebook, with its billions of users, is not going to be maintained by a single individual. And so I think it's important to understand that because a database is a common point for all the products, that we have to take great care when making changes, and we have to coordinate with a lot of different other teams. If you really want to get good at data modeling, you have to really think about where you're getting your data, how you're storing it, and how you're protecting it. So you really have to think about the trust that is being put into you when doing that, especially if you have user information. There are a lot of considerations that you're going to need to build a good data model. And the questions you need to ask are sometimes tough questions, and you need to think about trade-offs. I hope you walk away from this video learning that Databases are very complex systems that require a lot of coordination. And even though one singular data model may be designed by one person, you are still going to need to be able to coordinate with lots of other technical and cross-functional partners in order to build a successful database.
When developing a database system, you need to make sure that it operates efficiently and that you can extract information from it quickly. The best way to create such a system is to first design a data model. With the data model, you can plan how data is stored and accessed within your database before you create the database system. In this video, you'll explore the concept of data modeling and review different levels of data models. The jewelry store Mangueta & Gallo, or M&G, are in the process of designing and building a database system to store data on customers, products, and orders. But their current design is very inefficient. However, if M&G first focuses on creating a suitable database model, then they can design a more simplified and logical database system. Explore the basics of database modeling, then see if you can assist M&G. Let's begin with the term data modeling. A data model provides a visual representation of data elements and shows how they relate to one another. In other words, it demonstrates how your database system is structured. This structure helps you to understand how data is stored, accessed, updated, and queried within the database. And it also ensures a consistent structure and high-quality data. Data modeling is used to develop all kinds of databases, particularly entity relational databases. These databases are planned with the use of an entity relationship diagram. There are 3 different levels of data modeling: conceptual data models, logical data models, and physical data models. Let's take a few moments to explore these different types. You might already be familiar with conceptual data models from previous courses. A conceptual data model consists of a high abstract level of data elements called entities. The relationship between the data elements, or entities, links related records of data within your database system. The purpose of a conceptual model is to present a high-level overview of the database system through a visual representation of the entities it contains and their relationship to one another. M&G can make use of a conceptual data model to create their database system. They can present their customers, products, and orders as entities, then document how these entities are related. The conceptual model provides the basis for the logical data model. Again, you should have a basic familiarity with examples of a logical data model from previous courses. The logical data model builds on the conceptual model by providing a more detailed overview of the entities and their respective relationships. It identifies the attributes of each entity, defines the primary keys, and specifies the foreign keys. M&G can build on their conceptual data model by using it to create a logical data model. Their logical data model must include all attributes required for each entity, like a list of the attributes each entity contains. It then needs to define which of these columns serve as the primary key for each table. For example, the client ID column is the primary key for the clients table. And M&G's logical data model also specifies the foreign keys they're using to create relationships between the tables. In the current model, the client table is connected to the orders table through the client ID foreign key. A physical data model is used to create the internal SQL schema of the database, which is implemented in the database management system. The physical data model must outline features like the data types, constraints, and attributes. For example, M&G need to define a specific data type for each attribute, like varchar for the full name attribute in the client's table, or integer for the contact number attribute. They also need to apply relevant constraints. They can impose a constraint of not null for each column in the client's table to make sure that each one contains data. There are also a range of tools available to generate and execute the internal schema of a physical data model. You'll cover these tools in later lessons. You should now be familiar with the basics of data modeling and the importance of the role that it plays in the development of a database system. You should also be able to differentiate between different levels of data models and explain how each one contributes to the creation of a database system. Great work! When creating a database system, you first need to design a data model. But there are many kinds of data models that you can choose from. So how can you determine which one is best for your database system? In this video, you'll learn how to choose between different types of database models and find out how they can be used to create databases. Mangata and Gallo, or M&G, need to build their database system so that it meets the needs of their business. So, they need to choose a data model that fulfills their data requirements. Explore the different types of data models, including their advantages and disadvantages, and see if you can help M&G figure out which model is best for their business. There are many kinds of models that can be used to build a database system. In this video, you'll explore the following data models: the relational data model, the entity relationship model, and the hierarchical data model. You'll also review the object-oriented model and the dimensional data model. Let's begin with a look at the relational data model. You might already be familiar with the relational data model from previous courses. It's a popular and widely used database model. It represents the database as a collection of relations. Each relation is presented as a table that stores information in the form of rows and columns. A key advantage of this model is that it's much simpler to use than other models. You can quickly identify and access data. But the relationships between the data in this model can become more difficult to navigate with complex relational database systems. And you might also need to structure and organize the data differently when performing data analytics. Next is the entity relationship model. This model is similar to the relational data model. The key difference is that you can present each table as a separate entity by assigning each one its own set of attributes. The model also covers many different types of relationships between entities, such as one-to-one, one-to-many, and many-to-many relationships. For example, M&G can use an entity relationship model to visualize the relationship between their clients and orders tables. The two entities are connected through the client ID column using a one-to-many relationship. In other words, one or more orders belong to a specific client. There's also the hierarchical data model. The hierarchical data model organizes data in a tree-like or parent-child structure. Each record of data has a parent node, and it can also have its own child node. The main disadvantage is that it can only be used to record one-to-many relationships between nodes. Each child node can only have one parent node. M&G can use this model to depict the relationship between their orders and clients' entities. Clients are connected to their root node, and each order is connected to the related client, while each client can be connected to many orders. M&G can continue to add nodes as required. Another option for database developers is the object-oriented model. This model is based on the object-oriented concept. This is where each object is translated to a class that defines the object's characteristics and behavior. A key advantage of this model is that you can define different types of associations between objects, like aggregations, compositions, and inheritance. This makes object-oriented databases suitable for complicated projects that require an object-oriented approach. This model also relies heavily on the inheritance feature. This is where one class inherits its attributes from another. You can create a parent or superclass, also called a base, to hold the common attributes. Each child class that follows inherits the attributes of the parent class. However, if you do make use of this model, then you need a good understanding of object-oriented principles and related programming skills. M&G can make use of an object-oriented model to retain attributes between classes. They can create a base or parent class called person entity that contains attributes and operations. The staff and client classes then inherit these attributes and operations from the person entity class. So each staff member and client are a person. Finally, there's the dimensional data model. This model is based on two key concepts: dimensions and facts. Facts are measurements obtained from a process. For example, sales facts obtained from M&G's business data. Dimensions define the context of these measurements, like a specific sales period. So, sales facts measure how many quantities of a particular product M&G sold in each week. The key advantage of this model is that it optimizes the database for faster data retrieval and restructures data for more efficient data analytics. You'll explore the dimensional data model in more detail later in this course. You should now be familiar with the different types of data models that can be used to build a database system, and some of their key advantages and disadvantages. You're making great progress on your database modeling journey. At this stage of your database engineering journey, you should be familiar with the concept of database normalization. When working with database tables, you can often encounter anomalies that can lead to inconsistent data. You can solve these anomalies by applying the normalization process. Over the next few minutes, you'll recap the importance of database normalization and the methods for applying it within your databases. Mangata and Gallo, or M&G, are building a database that holds data related to product orders. They've built some tables that contain order, product, and client data. But these tables also contain several challenges around anomalies. Review the database normalization process. Then help M&G to resolve these anomalies within their database tables. Let's begin with a quick recap of database normalization. Normalization is an important process used in database systems. It involves structuring tables in order to reduce data duplication, avoid data modification implications, and simplify data queries from the database. As you learned earlier, database tables that don't follow the normalization process often give rise to anomalies. The most common of these anomalies include an insertion anomaly. This is when new data is inserted into a table, which then requires the insertion of additional data. An update anomaly. This occurs when you attempt to update a record in a table column, only to discover that this results in further updates across the table. And a deletion anomaly. This is when the deletion of a record of data causes the deletion of more than one set of data required in the database. So, let's quickly recap how the 3 levels of data normalization can be used to help resolve or avoid these anomalies. First, normal form, sometimes referred to as 1NF, enforces data atomicity and eliminates unnecessary repeating groups of data in database tables. In other words, there must only be one instance of a value per field. Repeated groups of data cause data redundancy and inconsistency. For example, M&G's products table stores the engagement and diamond ring products in the same cell of the item column. This violates the atomicity rule. There should only be one instance of a value per column. You can resolve this issue by creating 2 new tables. First, create a products table that holds all data related to the product entity. Assign the table a products ID column to identify each unique record. Then, create a clients table that holds all data related to the client's entity. And once again, create an ID column to identify each unique record. This solution removes all unnecessary repeated data from your tables. Next, let's look at second normal form. For a table to meet second normal form, or 2NF, it must already be in first normal form. It also cannot contain any relationships built on functional or partial dependency. The table must be defined with a composite primary key. For example, the delivery status table from M&G has a composite primary key that consists of the order ID and the product ID. To comply with the second normal form, you must identify if there's any non-key attributes that depend on one part of the composite key. The order data in the delivery status table is a non-key attribute. It can be determined by using the order ID column only. This is called partial dependency. This isn't permitted in second normal form because all non-key attributes must be determined by using both parts of the composite key. This can be fixed by removing the order date attribute from the delivery status table. In other words, keep the order date column in the orders table. Your table now meets second normal form. All non-primary key attributes depend only on the primary key value. Finally, there's third normal form. Third normal form, or 3NF, removes unnecessary data duplication. This ensures data consistency and integrity. Again, a table must adhere to first and second normal form before you can apply third normal form. Third normal form resolves issues of transitive dependency. This is when non-key attributes are dependent on one another. For example, the city and zip code in the M&G orders table are non-key attributes. However, it's possible to determine the city value based on the zip code value. And if you change the zip code value, you need to change the city name value. This means a non-key attribute depends on another non-key attribute, which violates the third normal form. To solve this, you can split the table into two tables, an orders table with all related data, and a city table with two columns, the zip code and city name. All non-key attributes are now determined only by the primary key in each table, so the tables now meet the requirements of 3NF. Applying the three fundamental forms of normalization is a good way to resolve any anomalies that could arise within your database. You can resolve any issues of data redundancy and inconsistency by modeling your database so that it's easy to use, access, and query. You should now be familiar with the process of normalization and how to apply it to your database. Great work! As a database engineer, you need to create, implement, and manage a database system that meets the specific requirements of your business or organization. These can be complicated tasks to carry out, but there are a range of tools and technologies you can use to support your work. One example of the tools that you will make use of is the MySQL Workbench tool. In this video, you'll explore the basics of the MySQL Workbench tool. You'll also learn how the tool can be used to help model and manage your databases. Over at M&G, the company is developing a new MySQL database management system. The database system must follow some key requirements, particularly in relation to operating systems, data migration, and editing tools. M&G can build a database that meets these requirements using MySQL Workbench. Take a few minutes to review the basics of MySQL Workbench, then see if you can help them out. Let's start with an overview of MySQL Workbench. MySQL Workbench is a unified visual tool developed by Oracle for database modeling and management. It contains several key features that are useful for creating, editing, and managing databases. Let's review some of MySQL Workbench's key features. MySQL Workbench is open source and cross-platform. It can be used with multiple operating systems. It simplifies database design and maintenance, and it offers a visual SQL editor and other tools that support developers. It provides auto-complete and highlighting features for writing SQL statements, and it facilitates data migration between different versions of MySQL and between MySQL and other relational database systems. You'll make use of MySQL Workbench in this course to model and manage data in your MySQL database. But first you need to download, install, and set up MySQL Workbench on your operating system. Download a copy of MySQL Workbench from dev.mysql.com/downloads. Make sure that you download the correct copy for your specific operating system. Once you've downloaded a copy, you then need to double-click the file to install it on your machine. Next, follow the installation wizard with the custom setup. When you run the wizard, make sure that you install the following software: MySQL Server, MySQL Workbench, and MySQL Shell. If you encounter any difficulties, read the MySQL Workbench installation file for guidance. Next, let's open the MySQL Workbench and find out more about how you can use it to establish connections. Once you've downloaded a copy of MySQL Workbench, you need to set it up. Launch the program and view the MySQL Workbench home screen. The home screen contains a welcome message, links to documentation, blogs, and discussion forums, and provides access to various tools and features. You can use the home screen side panel to access MySQL connections, models, and MySQL Workbench migration wizard. Select the Connections option to view a list of connections to local and remote instances of MySQL. You can use Connections to load, configure, group, and view information about each of your MySQL connections. Models displays the most recently used models. Each entry lists the date and time the model was last opened, along with its associated database. You can also select the plus sign to add a new model, select the Folder button to browse and open saved models, and select the More button to access additional commands. You can also open the Migration tab to display an overview of prerequisites for using the wizard, start a migration process, open the ODBC administrator, or view documentation. Let's look at the process steps for creating a new user. Creating a new user is the most secure way to connect to your MySQL database because you can manage user roles and privileges. Make sure MySQL Connections is selected. First, log into the MySQL server using the root user. Enter the root user password you set when installing MySQL. Save the password for future reference if required. Next, select Users and Privileges under the Management menu to view a list of current database users. Select Add Account to add a new user. This opens a new window in which you can enter the new user details. Name the new user, admin1. Enter a password, confirm the password. You can also use this window to control user privileges. Let's review these privileges. Account limits is used to limit a user's maximum number of queries, updates, and connections. The Administrative Roles tab lets you assign a role to a new user or assign them associate privileges. In this case, select DBA that grants the right to perform all tasks. Schema Privileges lets you control new user access privileges. Select the Apply button to create the new user. The next task is to create a new MySQL connection. From the MySQL Workbench home screen, select the plus icon to open the Setup New Connection form. Fill in the form to create a new server instance. You can now use the following values. Use test server as the server instance name. In the username text field, type admin1. You can use the default settings for all other parts of the form. Finally, make sure your hostname is 127.0.0.1 and the port number is 3306. Click the Test Connection button to check that the settings work as required. Enter the password you set for admin1 user. If you set it up correctly, then MySQL Workbench should confirm that the connection was successful. If not, return to the form and check that you've entered the information correctly. Select OK to save the connection. Your new MySQL connection is added to the home screen. You can now use this connection to begin working with database schemas and SQL queries. You should now be familiar with the basic features of the MySQL Workbench tool and know how to use it to help model and manage your databases. You're well on your way to understanding advanced data modeling. As a database engineer, you'll frequently need to create complex and robust database systems. This can be a difficult task, but luckily you can use tools like MySQL Workbench to create database systems quickly and efficiently. In this video, you'll learn how to use MySQL Workbench to create databases and tables and view, insert, and select data. Over at M&G, they need to create a database system to manage staff records. They've decided to create this new database using MySQL Workbench because of its SQL editor, GUI, and other useful features. Let's help M&G to create their new database using MySQL Workbench. The first task is to create a new database schema. Choose a MySQL Server instance and select the Schema menu. To create a new schema, select the Create Schema option from the menu pane in the Schema toolbar. This action opens a new window. Within this new window, enter mg_schema in the database name text field. Select Apply. This generates a SQL script called Create Schema mg_schema. You are then asked to review the SQL script to be applied to your new database. Click on the Apply button within the review window if you're satisfied with the script. A new window screen appears asking if you'd like to execute the Create Schema statement. Select the Finish button to create the MG schema. The schema has now been successfully created and is listed in the Schema menu. You might need to select the refresh icon from the menu to view new schemas. To view information on the MG schema, select it and click the Information icon. This action brings up a new window that contains several options like tables, columns, triggers, and more. You can also double-click the schema name to view a submenu of all created tables, views, procedures, and functions. If you want to delete the schema, right-click the name and select the Drop Schema option. The next task is to create a new table inside the MG schema to hold the staff information. Right-click the Tables option in the submenu, select Create Table from the list of options that appear. This brings up a new table form. Enter staff in the table name text field. Use the default settings for all other fields. Fill the column details in the middle window as required. Change the name of the first column to Staff ID. Define the column as integer and set it as the primary key using the checkboxes. Add the following remaining columns using the same method: full name, contact number, role, and email. Set each column's data type. Then declare each column as either null or not null as required. Finally, click the Apply button to generate the relevant SQL statement. You should now be able to review the SQL statement that creates the staff table. Click the Apply button to generate the relevant SQL statement. Review the SQL statement and click Apply to execute the statement. Then select Finish to save your changes. You can now view the staff table in the MG Schema database. Select the information icon to view the table's structure. The information window appears and shows options for columns, indexes, and other table elements. Click the Columns tab to show the column structure. Another method is to type Describe Staff in the SQL editor. Then click the Run button to execute the statement. This displays the details of the staff table structure. Your next task is to create a virtual table in the schema called Staff View. First, right-click the View submenu of the MG schema. Select the Create View option to open the SQL editor. Type a Create View SQL statement to create the virtual table. Create a basic view to show the staff full names and contact numbers. Click the Apply button to bring up the review window. You'll see some SQL code with suggestions that you can either accept or amend as required. For now, amend the table by creating aliases for the columns so that they're easier to view when querying the table. Finally, click the Apply button. Then click Finish to create the table. You can now view the virtual table in the MG Schema submenu. Next, MG needs you to populate the staff table with data. To insert data in the staff table, you'd usually use the Insert SQL statement in the SQL editor. However, with MySQL Workbench, you can populate the table grid directly. First, right-click the staff table, then select Rows from the list of options that appear. Enter the MG staff records into the table. Click the Apply button to generate an automatic Insert Into statement. Then click the Apply button again once you've reviewed the statement in the Review window to execute the statement. Finally, select Finish. The staff records are now stored in the staff table. Your final task is to query data from the M&G database. You can query the database using MySQL Workbench's SQL editor. Write a select query that extracts all data from the Staff View table. This query outputs all data that exists within the Staff View table into a table grid. M&G have now created their staff table and populated it with required data. M&G have now created their staff table and populated it with the required data. And you should now be familiar with how to use MySQL Workbench to create databases and tables, as well as view, insert, and select data. Great work! At this stage of the course, you understand the importance of database models. But how do you create these models? You can create database models using professional data modeling tools such as MySQL Workbench. In this video, you'll learn how to use MySQL Workbench and make use of the forward and the reverse engineer features. M&G need to develop a basic database to maintain information about their customers and orders. They can use MySQL Workbench to create the model. Then they can use MySQL Workbench's forward engineer feature to transform the data model into a SQL schema and implement it automatically into MySQL. Let's help M&G create their database using MySQL Workbench. In the MySQL Workbench home screen, click the Models view from the left sidebar. Then click the plus icon next to the models to display a new window. This action creates a new schema called MyDB. Double-click the schema name and change it to Mangeta_Gallo. The next step is to create the data model diagram. This diagram is essential for using the forward engineer feature. You can create the data model in MySQL Workbench and then transform it into a SQL schema that can be implemented automatically in MySQL. First, double-click Add Diagram to create the ER diagram. This action opens the ER Diagram Designer page. Now you need to create the tables. Click the Add Table icon and then click a square within the view. This action creates a table entity. Double-click the entity to load the table editor. Change the default Table 1 name to Customers. Now you need to add columns to the Customers table. Double-click a cell. This creates a default ID Customers column. Change its name to Customer ID. Keep the data type as integer. Check the primary key, not null, and auto increment boxes. Then add 3 more columns: full name, contact number, and email. Set the data types as required and mark all 3 columns as not null. Follow the same steps to create the orders table and set the data types as required. You also need to create the orders table foreign key. Define the table's customer ID column as the foreign key using the Foreign Keys tab at the bottom of the window. Type Customer ID FK in the foreign key text field. Double-click the corresponding field in the reference table. Then select the Customers table. Check the Customer ID referenced column. Then mark it as On Update Cascade and On Delete Cascade. You now have a visual representation of the M&G schema ER diagram with the customers and orders tables. Save your work by clicking File, Save As, and name it Mangata_Gallo_model. Now that you've created the data model, you can synchronize it to the MySQL server using the Forward Engineer feature. Select the Database tab, then the Forward Engineer option from the menu. This opens the Forward Engineer to Database wizard. Select the connection that you created earlier to connect to the MySQL server. Leave the default setting as is. Click Next. The wizard lists some advanced options. You can ignore these for now. Just click Next. A new window appears called Select Objects to Forward Engineer with a series of options. Check the Export MySQL Table Objects box, then click Next. The next step displays the SQL script to be executed on the MySQL server to create the internal schema. Review the script to ensure that it creates the schema as required. Click Next to forward engineer the SQL script. A message appears stating Forward Engineer finished successfully. Click Close to close the wizard. The M&G database has now been created in MySQL. You can confirm this by examining the schema list in the Navigator section, or executing a Show Databases statement inside the Workbench SQL editor. M&G also need to use MySQL Workbench to reverse engineer a data model. This means building a data model ER diagram from an existing database. The first step is to go to the Database tab, then select the Reverse Engineer option. Once you're happy with the connection details, click Next. Each connection must be configured appropriately to connect with MySQL Server. If you're not happy with the existing connection, you can choose another one and click Next. A message appears stating Execution completed successfully. Click Next. A list of available schemas on the server is displayed. Select the database schema you want to reverse engineer. Then click Next. A message appears on screen stating Retrieval completed successfully. Click Next. A new screen appears in which you are presented with the option to select all objects. The screen confirms that all objects have been retrieved. Click Execute. Once the retrieval process has been successfully executed, a message is displayed which states Operation completed successfully. The selected objects have now been reverse engineered successfully. Click Next again. A final screen is displayed which shows a summary of the import. Click Finish to complete the process. MySQL Workbench creates the new ER diagram from the internal MySQL schema. You can print the data model as a PNG image, share it with others, or apply changes and push it to the database using the Forward Engineer feature. M&G have now developed a basic schema in their database using MySQL Workbench, and you should now know how to make use of the Reverse Engineer feature in MySQL Workbench to develop a data model diagram. Well done! Congratulations on reaching the end of the first module in this advanced data modeling course. In this module, you learned how to design a suitable database model, resolve any anomalies, and then implement the model in your database using MySQL Workbench. Let's take a few minutes to recap some of the key skills you gained in this module's lessons. In the first lesson, you reviewed the concept of data modeling and learned that a data model demonstrates how your database system is structured. You also discovered that there are 3 different levels of data modeling. The conceptual data model presents an abstract overview of the database system through a visual representation of the entities and their relationship to one another. Then, there's the logical data model. This model identifies the attributes of each entity and defines the primary and foreign keys of each table. And the third and final level is the physical data model. This model provides the detailed level required to implement the internal schema in the database management system. You then explored different types of data models available to database engineers. You reviewed their advantages and disadvantages to determine which is best for your needs. Some of the models that you reviewed included the relational data model, the entity relationship model, and the hierarchical data model. There's also the object-oriented model and the dimensional data model. You also recapped the topic of database normalization. You discovered that normalization is the process of structuring tables to resolve anomalies such as the insertion anomaly, the update anomaly, and the deletion anomaly. You also recapped the 3 levels of data normalization that are used to resolve these anomalies. First, normal form, or 1NF, which focuses on the issue of data atomicity. There's second normal form, also called 2NF. This involves fixing any relationships built on functional dependencies. And finally, there's third normal form, or 3NF. This is a method of resolving transitive dependencies. In this lesson, you also explored an example of a data model. You then demonstrated your new skills by designing your own database model in an exercise. The second lesson in this module introduced you to MySQL Workbench. MySQL Workbench is a unified visual tool for database modeling and management. It offers a range of useful features for creating, editing, and managing databases. As part of your introduction to this tool, you learned how to download and install it on your operating system. You also saw how to use the tool to create a new user and establish a connection to a MySQL database. You then discovered how MySQL Workbench can be used to manage databases. You saw how to use the tool to create and navigate a database schema, and you learned how it can be used to create and view tables, including virtual ones, and query their data. The next topic in this lesson provided an overview of database modeling in MySQL Workbench. With MySQL Workbench, you can create new database schemas. You can also build a data model diagram using MySQL Workbench's Forward Engineer feature. This process involves creating a data model in MySQL Workbench and then transforming it into a SQL schema that can be implemented in a MySQL database system. MySQL Workbench can also be used to reverse engineer a data model by building a data model ER diagram from an existing database. You can print the model, share it, or apply changes and push it to the database using the Forward Engineer feature. You then put your new skills to the test in an exercise in which you were challenged to design your very own database model in MySQL Workbench. You should now be familiar with the basics of data modeling and management. I look forward to guiding you further through advanced data modeling in the next module. A regular database collects, stores, and processes data from transactions in real time. But what if you need to aggregate and analyze data from multiple sources? In these instances, a data warehouse is the perfect solution. It can aggregate data from a range of sources and analyze it using different tools. Over the next few minutes, you'll learn what a data warehouse is, explore its main characteristics, and review the different types of data that can be used in data analytics. The online e-commerce platform Global Superstore has seen a significant drop in sales recently. They want to perform data analytics to identify the reasons behind this downturn. The company has large amounts of data from multiple different sources like online transactions, social media interactions, and website data. Analyzing all this data requires powerful tools. A data warehouse is the perfect solution. Let's explore the concept of data warehousing in more detail and find out how Global Superstore can make use of it. A data warehouse is a centralized data repository that aggregates, stores, and processes large amounts of data from multiple sources. It separates the data analysis workload from the standard transaction workload of a regular database management system. Users can then query this data to perform data analysis. This type of database is called Online Analytical Processing, or OLAP. A regular database focuses on collecting, storing, and processing data in real time. It's also known as Online Transactional Processing, or OLTP. There are 4 key characteristics of a data warehouse. They're subject-oriented, integrated, non-volatile, and time-variant. Let's explore these characteristics, starting with subject-oriented. When building a data warehouse, you need to choose one or more subject areas to explore. For example, Global Superstore can build a data warehouse that focuses on sales. They can then use the warehouse to find all relevant information on their sales processes, like best and worst selling products. Integrated means that a data warehouse integrates data from a range of different sources. This data must be integrated in a consistent format. Integrated data must also resolve issues such as naming conflicts and data types. Global Superstore's data warehouse integrates data from online purchases, website interactions, and social media. The next characteristic is non-volatile. Non-volatile means data should not be deleted once it's loaded to the data warehouse. The purpose of a data warehouse is to analyze data as it exists. The more data you have, the better the results of your analysis. So, the data that Global Superstore integrates must not be deleted. The final characteristic is time variant. A data warehouse aggregates data over a long period so that it can measure changes in data over time. This helps users to discover trends, patterns, and relationships between data elements. For example, Global Superstore can use data from the last few years of sales to find out why their profits have declined. Now that you're familiar with the characteristics of a data warehouse, let's look at the different forms of data that it encounters. There's structured data, semi-structured data, and unstructured data. Let's start with a look at structured data. This is data that's presented in a structured format within a well-defined data model. The relational database model is commonly used for structured data. The organized tables help users to access, manage, and search for data using SQL. A data warehouse typically uses structured data. This data type is organized for a specific purpose, so it's easier to gain insights from and uncover answers to specific questions. Semi-structured data is data that's only partially structured. It requires more effort to perform data analysis. An example of semi-structured data is an email message. It can contain structured data like a sender and subject. But the body is unstructured and can contain several different kinds of data like text, images, and videos. The final type of data is unstructured data. This data type doesn't adhere to any specific predefined data model. It can include any kind of data like text, video, or audio. This data can be collected and stored without applying any form of data model. But analyzing unstructured data requires advanced data analytics mechanisms like machine learning and data mining. You'll explore these techniques later in this course. Semi-structured and unstructured data are more suited to a data lake. This is like a data warehouse, but it can handle unstructured data. Data lake is used more widely by data scientists. Businesses prefer working with structured data in data warehouses because of its accuracy. You should now be able to explain what a data warehouse is, outline its main characteristics, and the different types of data that can be used in data analytics. That's great progress. I look forward to guiding you further through these topics. At this stage of the course, you should be familiar with the concept of a data warehouse. But you might still have questions like, what does a data warehouse look like? And how does it work? In this video, you'll explore the architecture of a data warehouse and understand how its components work together to facilitate data collection, integration, and analysis. Over at Global Superstore, they've begun building a data warehouse that can aggregate, integrate, and analyze data to help inform their business activities. As a database engineer, it's important that you understand the architecture of a data warehouse. So let's explore the architecture of Global Superstore's data warehouse and discover how it works. Let's begin with a quick overview of the purpose and basic composition of a typical data warehouse's architecture. A data warehouse's architecture must be constructed so that it can control the flow of data from different sources. It needs to be able to process the data it encounters and integrate it in a consistent format. This is so that the users of the data warehouse can perform data analysis and extract useful insights. To facilitate this process, the architecture of a data warehouse is comprised of several different components. Each of these components plays a key role within the data warehouse to support data analytics. These components include data sources, data staging area, the data warehouse itself, and data marts. Once the data has been collected and integrated within these components, the data warehouse users can then perform data analysis and present their findings. Let's explore these components and find out more about how they contribute to the data analysis process. The first component of a data warehouse's architecture is the sources of data that it relies on for its insights. These include external sources like Global Superstore's online surveys or social media data. Internal sources like information collected within the company database on customers and products. Operational data produced by day-to-day business activities like customer orders. And data sources can also include flat files. These are files without an internal structure, like customers' online behavior or data log entries. Make sure that the data sources are accurate so that you can avoid irrelevant or poor data analytics. The next component is data staging. The data staging area includes a set of processes known as the ETL, or Extract, Transform, and Load pipeline. You'll explore these terms in more detail later in this lesson. Now that you've sourced and staged the data, the next stage is to store it. Data is stored in the data storage component. This is a central database repository that serves as the foundation of the data warehouse. It organizes data in relational databases. It also includes a metadata repository that holds different kinds of information about the data, like where it was sourced from, the features of the data, and the tables the data is stored in, along with their attributes. What does metadata mean in the context of a data warehouse? Metadata is essentially a table of contents for the data in the data warehouse. It helps database engineers manage and keep track of the changes within their source systems, methods, and processes. For example, Global Superstore's metadata contains information like where the data was sourced from. It also shows when each file was created, who created it, and other important information. The next component in the data warehouse is data marts. These are subject-oriented databases that meet the demands of a specific group of users. Each mart contains a subset of data that focuses on particular parts of the business or organization. For example, Global Superstore's data marts relate to specific departments and business functions. They can use these marts to perform focused analytical processes on specific parts of the business. Finally, once the data is ready, you can perform data analytics. Data analytics is performed using different analytics techniques like data mining. Once you've analyzed the data, you can then present it. The data can be presented in the form of reports like interactive reports, analytics reports, or static reports. Global Superstore's data analysts can analyze the data within their repository using different techniques. They can then produce reports that provide information on sales, profits, and other important aspects of the business. Now that you're familiar with the components of a data warehouse, let's take a quick look at some best practices to follow when creating and working with the architecture. First, always separate the analytical and transactional operations. Make use of scalable solutions so the data warehouse can process increasingly larger amounts of data. And build a flexible architecture that can incorporate and implement new functionality. There are also several other best practices you should follow. For example, make sure your architecture contains data security features. Develop a simple and flexible architecture that can work with different forms of data. Create a data warehouse that's easy to understand, implement, use, and manage. And document the development of the data warehouse. This makes it easier to incorporate new functions. You should now be familiar with the architecture of a data warehouse. And you should also be able to explain how its components work together to facilitate data collection, integration, and analysis. Great work.
Very, very large databases are very hard to get data from. And so ETL pipelines are some of the critical ways in order to ensure that different products get quicker access to the data they need. Hi, my name is Moxie Herrera. I use they, them pronouns, and I'm a software engineer at Meta in the Menlo Park office. ETL stands for extract, transform, and load. This is one of the common ways that data will be transferred to particular areas. So you will have some sort of data source, and then perhaps a staging area for the data, and then a consumer of the data. So splitting it up into different data consumers allows you to do two things. One, have the raw data stored in a backup, in a warehouse, and then it's extracted, then transformed to the data that you need so that it can be loaded by the consumers that need that data at the time of use. The purpose of an ETL pipeline can vary depending on your uses, but fundamentally the point is either to bring together a whole bunch of different data sources or have very large data sources abstracted away from the consumers of the data. The extract is bringing together all those data sources. The transform is doing the data validation, the scrubbing, the cleaning, maybe encryption. And then finally, the loading is where the end consumers are actually taking the data. The exact usage depends on the case. But what this means is that an ETL pipeline is a very common process that's used to solve many different data problems. Part of the point of an ETL pipeline is to take all these different sources that may be built under different systems and bring them into one system that specific consumers can use. This allows for parallelization. And so the decisions are often made around what do the end consumers need, where am I getting the data from, how am I organizing this, and what would lead to the most performant approach to this. One of the most common problems when dealing with data pipelines is sometimes handling the volume of data and the varied sources of data. This can make it very difficult to ensure that your pipeline is up to date and has the data that is needed at the time of use. Understanding the delay and how these pipelines work are very critical to ensure that you are not expecting data consumers to be able to grab data that it's not actually available to them. A change to the database may then trigger a need for a change in the data pipelines that you have built, depending on the needs of the consumer and what the database change is. So what this requires is a strong understanding of the need of that pipeline, what its goals are, and a strong sense of ownership by the stakeholders of that pipeline. These kind of updates happen all the time, and this could trigger all sorts of different changes in the product team. And so this requires a lot of ownership and responsibility and understanding of ETL pipelines for when those changes occur and what changes you need to make to accommodate that. There's a lot of data in the world. In fact, too much data to store in a single database. So ETL pipelines are an absolutely fundamental point in this world of big data, cloud computing, and the metaverse.
So far in your database engineering journey, you've studied and worked with different data models like entity relationship and object-oriented. But these models are built for real-time transactions. When working with a data warehouse or data analytics, you need a model that can optimize data access and queries for specific analysis. In this video, you'll explore the fundamentals of dimensional data modeling. This is a model used to build databases in a data warehouse for data analytics. Global Superstore are in the process of creating their data warehouse. Their next step is to design a data model for their database system that can handle data analytics. The dimensional data model is a good fit. Let's find out more about this model and see how Global Superstore can build it into their data warehouse. A dimensional data model is a data model based on the two key concepts of dimensions and facts. Let's take a closer look at these two concepts. The dimensions represent the different elements of your data. The dimensions define a context or perspective for your measures. Good examples of dimension data elements in Global Superstore's database is time and location. They can measure sales and other aspects of their business in the context of time and location. The term facts represents quantifiable data held within a database. Good examples of Global Superstore's facts include the number of sold products and the profits that they have made. There are two kinds of measures in the fact table: stored measures and calculated measures. Stored measures are aggregated measures stored in the data warehouse, like sales data and product price. This data is loaded from the data source and stored in the database warehouse repository. Calculated measures are calculated from other measures. For example, Global Superstore can calculate their profit by deducting the sold product's cost from the sold price. These measures are performed through queries that rely on calculation rules programmed in the data warehouse database. Next, let's look at the structure of a dimensional data model. A dimensional data model consists of facts and dimensions tables. The dimension table includes the dimensions data elements and can be structured as a hierarchy of data. This facilitates different levels of data analysis. You can navigate through the hierarchy to find the data you need. For example, you can drill down or roll up through the data elements, and the fact table includes the measures data. For example, Global Superstore can use this structure to find their average sales at specific points in time. They can explore data in different dimensional contexts and drill down through different levels. They can use the time and location dimensions to explore the data for average sales per year or by city. Then they can drill down through this data to find average sales per month and even average sales per week or day. There are several best practices that you should follow when designing a data model. Before designing a dimensional data model, you need to be clear about which business activities you want to examine. And you need to know which dimensions provide you with the most meaningful and useful context. Also, make sure you organize data in a way that's easy to understand, access, and query. A common method for designing a dimensional data model is with the use of schemas. One of the most widely used schemas in a data warehouse is the STAR schema. The STAR schema is a common model for designing databases in a data warehouse. It's a simple dimensional data model that consists of facts and dimension tables organized as a star. One or more fact tables sit in the middle of the schema, connected to one or more dimension tables. Global Superstore can use a basic STAR schema to organize their dimensional data model. The sales fact table is in the center of the diagram. It's connected to several dimension tables: suppliers, customer, product, time, and location. Another schema that you can use to design your dimensional data model is the snowflake schema. It's called a snowflake schema because the schema diagram resembles a snowflake. When working with a snowflake schema, you should normalize your dimensions tables to eliminate data redundancy. The best approach to normalization is to group dimensions data into multiple simple subdimensions tables. The disadvantage of this schema is that it increases the number of dimensions tables and requires more foreign keys to connect the tables. So more complex queries are required to join records when performing data analytics. For example, Global Superstore can use the schema to normalize their product dimension table into 3 tables: a products table, a subcategory table, and a category table. You should now understand the concept of dimensional data modeling, and you should be able to explain how the STAR and snowflake schemas work. Well done. At this stage of the course, you should be familiar with the dimensional data model and many of the key concepts related to it. But how do you build a dimensional data model? The process for building a dimensional data model revolves around 4 key steps known as Kimball's dimensional data modeling. In this video, you'll explore the approach and review each of these 4 steps in detail. Let's begin with a look at Global Superstore and their use of the dimensional data model. Global Superstore wants to perform data analytics to understand their recent sales figures. This requires building a dimensional data model that will help them understand their business and the factors that impact on their sales and profits. Before you explore Global Superstore's process, let's quickly recap the purpose of a dimensional data model and take a high-level look at the 4 key steps. A dimensional data model must focus on particular aspects of a business or organization in order to address specific problems. The model is created using a systematic approach that revolves around 4 key steps. These steps include the business processes, the grain, the dimensions, and the facts. Each of these steps is a choice. You need to choose a business process that your dimensional model must investigate. You then need to choose the facts and dimensions that can provide the answers you need. Let's work through each of these 4 steps or choices and understand how they contribute to the process of building a dimensional data model. When building a dimensional data model, the first step is to identify or choose the specific business process to be addressed. Once you've identified the process, you can then determine the grain of data in the data model. Global Superstore have decided that the business process to be addressed is their sales activity. Once you've decided on the process, you then need to choose the level of detail required. This is referred to as the grain. What granularity or level of detail is required for the data warehouse to address your process problem? And what's the lowest level of detail required to address the issue? For example, Global Superstore need to analyze their sales data at both a yearly and daily level. They also need to investigate this data at the global and local level. The next step in the process is to choose the dimensions. In this step, you need to choose the relevant dimensions. In other words, in what context do you need to explore your business activity? As you already know, Global Superstore need to analyze their sales data. And they need to analyze this data in the context of products, customers, time, and locations. So now that you've identified the business process, the grain, and the dimensions, it's time to establish the facts. This is basically answering the question of, what do you want to measure? You need to select the measures that contain numeric data and populate your fact table with these attributes. For example, Global Superstore need to explore their facts using the dimensions tables location, product, and time. They can demonstrate how each of these dimensions impacts the sales. And they can also include relevant attributes that provide useful information about each dimension. Once you've decided what aspect of your business process you need to investigate and chosen the grain, related facts and dimensions, you can then create your schema. Arrange your dimensions in dimensions tables. Global Superstore can arrange their dimensions and measures in a star schema. Their schema examines the performance of their sales activity in the context of 4 different dimensions: customers, products, locations, and time. And within each dimension is a set of relevant attributes that target the required data. Once you've decided what aspect of your business process you need to investigate and chosen the related data and dimensions, you can create your schema. Global Superstore have identified their dimensions and measures step by step based on their business requirements. They can now perform different forms of data analysis to achieve their goals. You should now be familiar with using a systematic approach to build a dimensional data model, and you should also be able to identify and explain each of the 4 steps in which you must make your decisions around data. You've made great progress on your advanced data modeling journey. Congratulations on reaching the end of the 2nd module in this advanced data modeling course. In this module, you explored the architecture of a data warehouse and learned how to build a dimensional data model. Let's take a few minutes to recap some of the key skills you've gained in this module's lessons. You learned that a data warehouse is a centralized data repository that aggregates, stores, and processes large amounts of data from multiple sources. Users can then query this data to perform data analysis. You then discovered that a data warehouse is defined by 4 key characteristics. First, it's subject-oriented, which means that it provides information on chosen subjects or topics. Data warehouses are also integrated, in that they integrate data from a range of different sources. The next key characteristic is non-volatile. Data is maintained in the state in which it was loaded into the data warehouse. And finally, data warehouses are time variant. They aggregate data over a long period of time to measure change. You also reviewed the different forms of data that a data warehouse encounters. There's structured data, which is data presented in a well-defined structured format that's easy to access, manage, and search through. Semi-structured data is data that's only partially structured. It's more flexible, but also requires more effort to analyze. And finally, there's unstructured data. This can include any kind of data without any predefined model. But it's much more difficult to analyze unstructured data than structured and semi-structured data. Once you reviewed the basics of data warehousing, you then moved on to explore the architecture of a data warehouse. A data warehouse's architecture focuses on the design of the components that aggregate, integrate, and analyze data in the data warehouse. It illustrates the flow of data from different sources. It then processes and integrates this data so that users can perform data analysis. The architecture of a data warehouse consists of the following components. The first is data sources, which consist of the data that the organization relies on for its insights. Next is the data staging area. This is where data is prepared for analytics through the ETL, or extract, transform, and load process. Then there's the data warehouse itself, where data is stored. And finally, there's data marts. These are subject-oriented databases that meet the demands of specific users. Once the data has been collected and integrated within these components, the data warehouse users can then perform data analysis and present their findings. It's also important that you follow best practice when creating and working with the architecture of a data warehouse. And make sure that you document the development of the data warehouse so that you can incorporate new functions into the architecture as needed. You then explored a case study of a real-world data project and tested your new knowledge in a quiz item. In the next lesson, you learned about dimensional data modeling. This lesson began with an overview of the fundamentals of dimensional data modeling. You learned that a dimensional data model is a model based on dimensions and facts. Facts represent the measures. These are quantifiable data. Dimensions define the context in which you can explore the measures. There are stored measures, which include aggregated measures that can be stored in the data warehouse. And there's calculated measures, which focus on data that's calculated using data from other measures. You also reviewed the structure of a dimensional data model. A dimension table can be structured using a hierarchy of data. This structure allows for different levels of data analytics. You can drill down or roll up through the data elements to find the data you need. Dimensional data models are also designed using schemas, like a star schema. You can also use a snowflake schema. You then explored some examples of dimensional data modeling in practice. You learned that there are 4 key steps that must be followed when creating a model. First, you need to identify the business process to be addressed. Once you've decided on the process, you must choose the grain. Then choose the relevant dimensions, and decide the measures in the facts table. You then undertook an exercise in which you created your own dimensional model using the skills and knowledge that you gained throughout this module. You should now be familiar with the basics of a data warehouse and its architecture, and the fundamentals of dimensional data modeling. Great work! I look forward to guiding you through the next module in this course, in which you'll learn about advanced data analytics in the context of data modeling. Your databases collect and store an endless stream of data from a variety of different sources. And as you should know by now, the true value of this data is what you do with it. Data is most valuable when it generates insights that help improve services, make plans, and minimize risk. All these insights are generated through data analysis and advanced data analytics. Over the next few minutes, you'll recap the basics of data analytics and explore different types of data measurements. Over at Global Superstore, they've been collecting large amounts of data and storing it in their databases. This data represents an important asset which the store can use to understand and improve their business activities and performance. To take advantage of this data, they need to perform different types of data analysis and measure their data appropriately. Let's find out how Global Superstore can make the most of their data, and start with a recap of data analytics and the types of data analytics they can use. As you should know from previous courses, data analytics involves analyzing data to derive useful information and valuable insights. You can make the most use of data analytics using data analytics tools and data analysis. There are several key types of data analysis that you've encountered so far and made use of in other courses. Let's briefly recap these. Descriptive data analysis presents data in a descriptive format. Exploratory data analysis is used to establish a relationship between different variables, and inferential data analysis focuses on a small sample of data to make inferences. Predictive data analysis identifies patterns in data to make predictions about future performance. And causal data analysis explores cause and effect between variables. Before you can engage in these types of data analysis, you first need to understand the type of data that you're dealing with and ask what kind of measurements should you apply to it. Another key question to ask of your data is if it's quantitative or qualitative. Quantitative data refers to numerical data. This is data that can be counted or quantified. In the case of Global Superstore, this includes the average number of customers who make purchases each day or the average cost of each purchase made. Qualitative data refers to non-numerical data. This is textual and descriptive data, like information about the quality attributes of a product. For example, Global Superstore's qualitative data includes category names or descriptions of products like furniture or office supplies. Once you've determined what kind of data you're dealing with, you then need to organize, identify, and analyze your data. You can perform these actions using 4 different measurement scales. The first of these measurement scales is the nominal scale. This scale describes the identity property of non-numerical data. It's purely descriptive, which means it just identifies the data. In the case of Global Superstore, they can use this scale to identify products in their stock, like a chair or a desk. Each product is one nominal unit of data. The next form of measurement is the ordinal scale. This is a qualitative data type scale, which places data in a specific ranked order. However, it doesn't include decisive criteria to determine the difference between the data elements. For example, Global Superstore can rank chairs using ratings values. So they can use a value of 1 for top quality products, 2 for very good products, and 3 for good products, and so on. However, there's no precise criteria that determines the measurement between each value. There's also the interval scale. This scale includes properties of the nominal and ordered data scales. Its key feature is that the difference between data points can be clearly identified using specific criteria. The scale can also contain both positive and negative numbers, and 0 does not represent an absolute true value. Global Superstore can use the interval scale to provide feedback on products from 10 to -10. Finally, there's the ratio scale. This scale is a quantitative data type that includes properties from nominal, ordinal, and interval scales of measurement. It defines the identity of the data, classifies the data in order, and marks clear intervals. However, it holds an absolute value of 0. Over at Global Superstore, they can use the ratio scale to mark the weight of products. For example, a small table is 20 kilograms, a medium-sized table is 40 kilograms, while a larger table weighs a total of 60 kilograms. In this instance, there's a clear order between variables and an equal distance of 20 kilograms between each measurement. So, all data points can be measured accurately. You should now be familiar with the basics of data analytics, be able to identify different types of data, and explain different types of data measurements. Great work. The more data you collect and store, the more difficult it becomes to analyze and make sense of. So database engineers who run large databases rely on advanced data analytics methods like data mining and machine learning to discover patterns, paradigms, and trends in data. Over the next few minutes, you'll explore these methods and learn how they help businesses and organizations to understand performance through data and make predictions and actionable plans. Global Superstore has been in operation for 15 years. During that time, they've collected huge amounts of data on all aspects of the business, like sales, customers, and marketing. However, the more data they collect, the more difficult it is for them to analyze and understand it. Several years ago, they began using advanced data analytics methods like data mining and machine learning to help make sense of their data. The terms data mining and machine learning are often used interchangeably. While they're both useful methods for analyzing data, they operate very differently. Data mining is the process of detecting patterns in data. You can then gain insights, make judgments, and deliver predictions based on these patterns. Global Superstore used data mining to identify associated patterns between the sales of certain products. For example, many customers who buy tables also buy chairs. So this data suggests that the store might benefit from advertising or selling these products together. Machine learning is the process of teaching a computer how to learn. Specifically, it involves teaching a machine to determine probabilities and make predictions. There are two main methods of machine learning: supervised and unsupervised machine learning. Supervised machine learning involves classifying data based on given labels. For example, Global Superstore can label the available chair and table images as CH and desks as DK. The computer can then learn to recognize, classify, and group these product images based on their labels. Unsupervised machine learning is when data is classified based on shared characteristics, but without the use of labels. So, the machine learns to recognize and categorize images of objects like chairs, tables, and desks based on the shapes in the images. Machine learning makes use of many kinds of data mining models when processing data. Let's take a few minutes to explore some examples of these models. The first model is classification analysis. This model assigns data items into categories or classes of data. You can then use this data to predict your target class for the items. For example, many Global Superstore customers purchase low-priced office products, so they can be classified as low-budget customers and targeted with advertisements for low-budget products. There is also the association rule. The association rule is a model that identifies the relationship between different data elements. It determines if there is a correlation between these elements based on certain criteria. Many Global Superstore customers who purchase cell phones also buy items like phone chargers and battery packs. This data suggests that these products should be advertised and sold together. The next model is outlier detection. Outlier detection is a model that reveals unusual data within a particular data set. In other words, it detects data outliers or anomalies that don't conform to the expected pattern. For example, a group of Global Superstore customers with a shared history of purchasing low-priced products suddenly begin purchasing expensive products. In this instance, the company needs to reclassify these customers and target them with advertisements for more expensive items. Another model you need to be aware of is clustering analysis. The clustering analysis model searches for similarities within a data set. It then separates the data into clusters of subsets based on the similarities it finds, or the common characteristics within the subsets. The model works in a similar manner to the classification analysis model. However, that model is initially assigned to predefined groups, not newly discovered ones. Global Superstore can use the model to classify low and high budget customers based on similar types of navigation behavior in the company's online store. The final model you need to know about is regression analysis. The regression analysis model considers the different factors that impact data. It then determines the relationship between these factors. This model can help Global Superstore to develop a better understanding of their sales patterns. The data shows that each time the store discounts certain products, it leads to an increase in sales. So the store can conclude that discounts impact sales data. You should now be familiar with different methods of data mining and machine learning. You should also be able to explain the different data mining models that machine learning can make use of. Great work! Database analysis isn't just about extracting and analyzing the information you need from the database. How you present your data is also just as important. Good data visualization helps decision makers to interpret the data and make the right choices around it. In this video, you'll review the different factors that inform data visualization, and you'll also explore the different methods that you can use to present your data. Over at Global Superstore, the company's data analysts are performing advanced data analytics to help improve the store's performance. They now need to present their findings to the company. The best way for the data analysts to make sense of the information and present their findings is by visualizing the data. Let's explore some different methods of data visualization that Global Superstore's data analysts can use to present their findings. Let's start with a quick overview of what database analysts and engineers mean by data visualization. The term data visualization refers to presenting or visualizing data in a way that lets decision makers interpret the information quickly and easily. Your role is to remove the noise from the data and present the important elements, like trends, paradigms, and outliers, in a user-friendly way. In other words, how can you tell an informative and engaging story through your data? There are 4 factors to consider when deciding what type of visual data to represent. The first of these is your target audience. Who are you presenting this data to? What's their background? What's their level of understanding of the issues or topics to be investigated? Factor these questions into your presentation. You also need to carefully consider what information your visualization includes, what information answers your audience's questions, and what information is redundant. Another issue to consider is time. How much time do you want your audience to spend examining each chart? Should they be able to understand a chart after just a few minutes of observation, or should it take them longer? And finally, think about the level of accuracy your audience is looking for. Does your audience just need to understand the data in a general sense, or do they need to drill down into finer levels of detail? Once you've answered the key questions, identified your audience, and determined what kind of data you need to show, it's time to decide on your data visualization charts. Each type of chart has a different purpose, and each chart can be used to solve a different type of problem or communicate a different kind of message. What's most important is to select a chart that tells your audience the story of your data in the most appropriate way. Let's explore a few examples of commonly used data visualization charts and find out what kind of message each one communicates. One of the most frequently used charts is a bar chart. This is a comparison chart type. It helps audiences to recognize differences or similarities between data values. You can present data horizontally or vertically to show numerical comparisons across categories. Global Superstore uses a bar chart to depict the sale of products against profit ratio. This shows how much profit is made in each product category. The line graph is another common chart. A line graph shows quantitative data over a continuous interval or time period. Line graphs work by showing connections between the data points on a Cartesian coordinate system. Over at Global Superstore, they use line graphs to show the trend in profits over the last number of years. There's also the bubble chart. A bubble chart shows the relationship between numeric variables. Each variable is assigned its own bubble. Audiences can understand what a bubble chart is saying by comparing the sizes, positions, and colors of the bubbles. For example, the larger bubbles in Global Superstore's bubble chart indicate that the departments each bubble depicts are more profitable than the departments assigned to the smaller bubbles. Next is the map chart. A map chart presents data in geographical areas. Each data variable can be reflected in the map using a variety of different methods, like colors and labels. Global Superstore used map charts to visualize sales across different global regions. And finally, there's the scatter plot graph. This graph plots variables as points on a Cartesian coordinate grid. You can then use these data points to search for correlations between variables. You can also add trending lines for each data group within category labels to show the performance of select categories. Global Superstore used this approach to depict sales and profits across different categories or departments. You should now be able to explain the different factors that inform data visualization and take these factors into account next time you visualize your data. And you should also know how to select the charts or graphs that best communicate the story that you want to tell through your data. Excellent work. Data analytics is a complex process, and the task is beyond the capabilities of traditional database management systems. That's why data analysis is performed using data analytics tools. These tools make it possible for users to view and understand large amounts of data using artificial intelligence. In this video, you'll review some examples of well-known analytics tools and learn about their key features. You'll also explore the Tableau tool, which you'll make use of later in this course for your own projects. Global Superstore's data analysts are performing advanced data analytics to generate data insights that will help inform their business decisions. This approach requires the use of powerful data analytics tools. Using these tools, Global Superstore can use their data to identify new business opportunities, grow their sales, and improve their services, alongside other benefits. Let's find out more about how these tools work and discover how Global Superstore makes use of them. Data analytics tools help database users to perform data analysis. The results of the data analysis generate insights that inform the development of businesses and other organizations. These tools make use of artificial intelligence, machine learning, and data mining. And they provide tools for visualizing data to help you understand and communicate your findings. There are many kinds of analytics tools that you can make use of. The most common tools that database analysts rely on include Tableau, SAS Business Intelligence, and Microsoft Power BI. There are several key features these tools offer which make them useful for dealing with large databases. They can deal with massive amounts of data. They can work with data in many different formats, and they can interact with many different data sources and database systems. In addition, each tool uses advanced data analysis techniques to generate insights, and they provide advanced data visualization tools. These features make it much easier for users to view and understand their data. Tableau is a widely used data visualization tool. There's a free 14-day trial, and it offers a 1-year license for tutors and students in accredited academic institutions. There are several key features that Tableau users can take advantage of when visualizing their data. It stores data in the form of different data types like string, date, and time. It can connect to a wide range of data sources like MySQL, Microsoft SQL, MongoDB, BI, and Oracle DB. And it can interact with many different data sheets and file systems like Excel, JSON, and PDF. In addition to these features, Tableau can also generate interactive dashboards that present data in real time, support scripting in Python and R programming languages, and complete tasks using interactive UI tools like drag and drop. Tableau comes in both desktop and cloud versions. In this course, you'll make use of Tableau Desktop. You can download the software directly from Tableau.com. Now that you're familiar with the Tableau tool, let's explore it in more detail and find out how organizations like Global Superstore make use of it. First, launch Tableau by clicking on the Tableau desktop icon. This opens the Tableau launch page. The launch page offers several different options. Open existing workbooks using Open a Workbook. Work from sample workbooks in the Accelerators section, and access useful learning resources in the Discover section. You can also connect to your data sources using the Connect pane. For example, Global Superstore can choose a Microsoft Excel document as their data source and load the file's data into their Tableau workspace. Select the Tableau icon to switch from the Start page to the Authoring workspace. Once you're connected to a data source, the source connection and related fields appear in the data pane. You can then use the Authoring workspace's user interface elements to create a visualization of your data. Add data to your view using the Marks card or the row and column shelves. For example, Global Superstore can drag measures and dimensions around the workspace as required. This is useful for comparing data and categories. Access commands and navigation tools quickly and easily in the toolbar. Global Superstore often makes use of the sorting icons to arrange bars in ascending or descending order, or use the dashboard to view and work with multiple sources of data at once. You can even create an interactive dashboard that combines different sheets to present relative information to the audience. You can also use Story, a tool that's similar to the dashboard. Story presents sequences of worksheets and dashboards to tell your data story. You should now be able to identify well-known analytics tools and describe many of the key features that they share. You should also be able to access and make use of the Tableau work environment to visualize your data. You're making good progress in developing your understanding of advanced data analytics. At this stage of the lesson, your next question might be, how do I use Tableau? In this video, you'll learn how to connect Tableau to your data sources, then clean and prepare your data for analysis. Global Superstore needs to use Tableau to analyze the records of a large Excel file, but they first need to clean and prepare the existing data. Let's help Global Superstore to connect their Excel data source to Tableau, then clean and prepare the data for analysis. To perform data analysis in Tableau, you first need to establish a live connection to a data source. To establish a live connection, first open Tableau on the Connection page. Under the Connect tab on the left-hand side, click Microsoft Excel. This opens a dialog box that you can use to navigate to the Excel file on your machine. Select and open the file. The Excel file name appears on the left-hand side of the screen. The data from the Excel file is displayed in the data pane. With a live connection, you can make sure that any updates to the original source are automatically reflected in your database. However, it's faster to process a data extract, particularly when dealing with large amounts of data. On the left side of the data pane is the metadata grid. This shows relevant information about the different data fields. You can keep or hide the metadata grid by clicking the Related button. Now that you've connected to the data that you need, you can begin to clean it and prepare it for analysis. This process involves fixing errors in the data and shaping it so that it's easier to understand and analyze. You can do this by performing different types of operations like filtering, sorting, and renaming the data. You'll cover these operations in more detail in a later video. The top of each column specifies the column's data type along with a suitable symbol. You can change these data types as required. Let's take the order date column as an example. Select the small arrow next to the symbol above the column. Click Describe on the list of options that appear. This action shows key information about this field of data. Click the ABC data type and select the Date data type. The data type has now been changed. You can also hide irrelevant table details so that you can focus only on the necessary data. You can also change the number of rows displayed within the data pane. Let's hide the Order Date column. Select the small arrow again, then select Hide. The column is now hidden. To show the data again, click the Tableau settings icon, then select the Show Hidden Fields option. This action displays faded versions of the fields to indicate what has been hidden. To restore these fields, click the small arrow and select Unhide. Your next task is to split the customer name column into two separate columns, one for each customer's full name and another for their last name. Click the small arrow and then select the Split option. This automatically creates two new fields. You can rename them as required. Click the corresponding small arrow, select Rename, and call the columns First Name and Last Name. Global Superstore also need you to create a new data field for their returns. The field must include the final date by which each product can be returned under the company's returns policy. This is 15 days from the date of purchase. Select the small arrow in the Orders Date column and click Create a Calculated Field. Name this new field Return Date. In the calculation editor, enter the following basic formula: order date plus 15. This formula adds 15 days to each order's order date value. This creates a new returns column populated with the relevant data. When finished, click OK. The new calculated field is added to the data pane. Global Superstore's data has now been cleaned and prepared for analysis. And you should now be familiar with how to connect to data sources in Tableau and clean and prepare your own data for data analysis. Great work! Once you've imported your data into Tableau, you then need to prepare it for analysis. However, the process is more efficient if you focus only on the data you need to analyze. With Tableau, you can focus on relevant data using the software's filtering and visualization features. In this video, you'll learn how to filter data and create a data analysis chart in Tableau. Over at Global Superstore, they're preparing to launch a new marketing campaign in Canada. But first, they need to analyze their sales data to optimize their campaign. They can use data filtering techniques to arrange and exclude data so that their records are focused only on Canada. This provides a more relevant, reliable, and accurate level of information. You can help Global Superstore to complete this task by using Tableau. In Tableau, you can filter data in either the data source page or the worksheet. However, filtering data directly in the data source page limits your data analysis in all worksheets to the filtered criteria only. For example, if Global Superstore filter their categories to include only office furniture, then they can't perform data analytics in other categories in the worksheet. Let's begin by applying data filtering in the data source page. Click the Add option under Filters. This opens a dialog box that lists all filtered fields in the data source. Click Add again to add a new filter field. Next, select Region and click OK. Click the Select from List option in the General tab area. Check Canada, then click OK. The data pane now shows filtered records from Canada only. You can repeat this process to add more data source filters if required. To remove a filter, click Edit Filter, select Canada, then Remove, and OK. You can also filter data in the worksheet. Open the Sheet tab at the bottom of the page. In the worksheet, the columns from your data source are displayed as fields on the left side of the data pane. The data pane contains a variety of fields. The fields above the gray line are dimension fields. The fields below the gray line are measure fields. Dimension fields hold categorical data. In the case of Global Superstore, this includes product categories, types, and dates. Measure fields hold numeric data like sales, profit, and quantity. Global Superstore want to compare sales of all category products sold in Canada. To help them with this task, drag the category field from the dimension section of the data pane to the rows in the shelf area. Then drag the sales field from the measure section in the data pane into the columns in the shelf area. The horizontal bar chart that appears shows information about different product categories. You need to filter this data to show only products sold within Canada. Drag the region dimension from the data pane to the filter card. This opens a pop-up window. In the General tab, select Canada, then click Apply and OK. Your data is now filtered to show sales in Canada only. You can also take further steps to make your chart easier to read and understand. Click the swap icon to change the horizontal bar to a vertical chart. Click the descending order icon to filter data from maximum sales to minimum sales. Drag sales to the color part in the marked section of the screen to change the bar colors based on sales. Drag profits from the data pane's measure section to the label mark. This shows the profit of each category in the chart. You can also provide a title for the sheet. In this instance, you can call the sheet Sales in Canada. A lot of the information in the chart is generic. It might be better to add the subcategory to the view to provide more detail around the sales and profits. Drag the subcategory field from the dimension section of the data pane to the columns in the shelf area. Then click on the descending order icon to filter data from the maximum to the minimum values. You can now view all categories and subcategories. You can even focus on one category like furniture. Drag the category dimension from the left data pane to the filter card. Then use the Filter Categorical Data option to retain the furniture category while unchecking the technology and office supply categories. Click Apply, then OK. You can also filter categories according to best-selling items. Drag the subcategory to the filter card. Then select the top tab, tick By field, and enter a numerical value of 2 to view the top 2 categories. Then click Apply. The wildcard can also be used to filter data based on specific patterns. For example, you can type chair in the text field to include subcategories that contain this text value. In this instance, the data returns the chair subcategory. Another filtering technique is condition filtering. You can use condition filtering to select a field of data and define specific rules to be applied. For example, you can select the sales field, then specify a sum value greater than 500,000. Click Apply, and then OK. This returns all values within your data greater than 500,000. To remove all subcategory filters, just right-click the subcategory and click Remove. You can also remove the category and keep the region to focus on Canada. You can now view all sales data related to the furniture category and subcategories in Canada. Global Superstore has now filtered the required data for data analysis using Tableau, and you should now also be able to apply different filtering techniques to your data using Tableau. You're making great progress on your data analytics journey. Once you've analyzed your data in Tableau, you then need to determine the most informative way to present it to your audience. With Tableau, you can present data visually in the form of an interactive dashboard. Over the next few minutes, you'll learn how to create a basic dashboard with multiple views and interactivity. At Global Superstore, they want to create an interactive dashboard that shows profits and sales by country and indicates how profits are trending over time. They can then use this dashboard to compare sales and profits in each country. Help Global Superstore to complete this task by creating worksheets in Tableau as follows. One worksheet to show sales and profits in each country, and another worksheet that shows trending profits. You then need to combine these worksheets in one dashboard where they can interact with one another based on the needs of the user. This tutorial assumes that you already connected to the data source and that all necessary data has been cleaned and prepared for analysis. Let's begin with the map chart. Click the Sheet tab and change the default title to Profit and Sales Map by Country. Double-click Country in the data pane. The map view is automatically created because the country field is a geographic field. Drag the Profits field from the data pane to the color on the marks card. Change the color so that it's easier to identify this data. Next, drag the Sales field from the data pane to the tooltip on the marks card. Select Maps, then Background Maps. In the background pane, click the Normal option. Roll over each country using your mouse to display the name, profits, and sales data. Your next task is to create another view that shows the Global Superstore profit trends over time. Create a new worksheet and change the title and sheet name to Profits Trends. Drag the Order Date field from the data pane to the column shelf. Make sure that the order date has been assigned a data type. Drag the profit fields from the data pane to the rows in the shelf section. Tableau automatically generates a trending chart for profit. You can change the trend line's color set by dragging the profit to the color mark. Select a new color set to differentiate it from other data. Then drag the profits field from the data pane to the label mark. This shows the profits made each year. You've created two worksheets that communicate important information. You now need to combine the two sheets within one dashboard to show how profits are trending within each country. The first step is to set up your dashboard. Click the Dashboard tab, then the New Dashboard option. You can also use the dashboard icon at the bottom of the page. Call your new dashboard Profits Dashboard. To the side of the dashboard pane, you can access the sheets you've already created. Drag the map chart to the empty view within the dashboard. And drag the profits chart below the map chart. The dashboard now has two related charts. Global Superstore can use it to compare profit and sales by country. However, it would also be useful to add some interactivity to this chart. For example, you can add interactivity to view profit trends by clicking on each country. Select the map from the dashboard, then click the Use as Filter icon. Select a country within the map, like Argentina. This shows the sales and profits in the map chart, and it also shows the trend in profits within the selected country. You can repeat these actions for each country. Thanks to your worksheets, Global Superstore can now compare their sales by country. And you should now be able to create a basic interactive dashboard with multiple views and interactivity. You're making great progress. Congratulations on reaching the end of the third module in this Advanced Data Modeling course. In this module, you explored data analytics in the context of data modeling and learned how to perform data analysis using a visual analytics tool. Let's take a few minutes to recap some of the key skills you've gained in this module's lessons. You began the first lesson in this module with an overview of data analytics. You learned that data analytics involves converting and processing aggregated data into useful and meaningful information. You also explored the topic of data analysis. There are several key types of data analysis that you've encountered throughout your database engineering journey. Descriptive data analysis presents data in a descriptive format. Exploratory data analysis is used to establish a relationship between different variables. And inferential data analysis focuses on a small sample of data to make inferences. Predictive data analysis identifies patterns in data to make predictions about future performance. And causal data analysis explores cause and effect between variables. And you also learned that there are two types of data you'll deal with: quantitative data, which refers to numerical data, and qualitative data, which refers to non-numerical data. Once you've determined what kind of data you're dealing with, you then need to organize, identify, and analyze it. You can perform these actions using 4 measurement scales. The nominal scale is used to label data without assigning any quantitative value or order, and the ordinal scale places data in a specific ranked order. The interval scale identifies clear differences between data points using specific criteria. It also can represent negative values. And finally, the ratio scale defines the identity of the data, classifies the data in order, and marks clear intervals. It cannot represent negative values. You then explore the topics of data mining and machine learning. You learn that data mining is the process of detecting patterns in data, while machine learning is the process of teaching a computer how to learn. This can be done through either supervised or unsupervised machine learning. Machine learning makes use of several different kinds of data mining models when processing data. Classification analysis assigns data items into categories. The associate rule identifies relationships or associations between different data elements. Outlier detection is a model that detects data outliers or anomalies that don't conform to the expected pattern. Clustering analysis searches for similarities in data sets, then separates them into clusters. And finally, regression analysis considers the different factors that impact data, then determines the relationship between these factors. In the next part of this lesson, you learned about the importance of data visualization. This means that you must present or visualize your data in a way that lets decision makers interpret the information quickly and easily. When visualizing your data, you must consider the following questions. Who's your audience? What information do they need to know? How much time should they spend examining this information? And what level of accuracy do they require? Once you've answered these questions, you can then choose an appropriate data visualization chart. There are many different types of charts to choose from, including a bar chart, a line graph, and a bubble chart. You can also use a map chart or a scatter plot graph. Each chart serves a different purpose. What's most important is to select the chart that best informs your audience. You then concluded this lesson with a discussion in which you considered what kind of data analytics reports you engage with and how they help you in your tasks. In the next lesson of this module, you reviewed the topic of advanced data analytics. You learned that data analytics tools help database users to perform data analysis. The results of this data analysis inform the development of their businesses or organization. The data analysis tool you worked with in this course is Tableau. Its key features are as follows. It stores data in the form of different data types, it can connect to a wide range of data sources, and it can interact with many different data sheets and file systems. In addition to these features, Tableau can also generate interactive dashboards, support scripting in multiple languages, and it also offers interactive UI tools like drag and drop. You first learned how to download, launch, and navigate Tableau. Then you learned how to import and prepare data in Tableau. This involves setting up a live connection to your data source or importing data into the tool, and cleaning and preparing your data for analysis. This second step often involves actions like filtering irrelevant data, splitting data for greater accessibility, creating new data fields as required, and fixing data types. Once you've connected to the data source or imported your data, you can then filter, analyze, and visualize the data in Tableau. You can filter data using either the data source page or the worksheet. Tableau also lets you filter data using conditions or by adding subcategories. You then learned how to create an interactive dashboard using Tableau worksheets. And finally, you undertook an exercise in which you performed data analysis in Tableau. You should now be familiar with data analytics and data analysis software. That's great progress. I look forward to guiding you through the next module in which you'll undertake a data modeling project. In this course, you explored the topic of advanced data modeling. Let's take a few moments to recap the key lessons that you encountered in this course. You began the course with an introduction to the topic of advanced database modeling. You learned that a data model provides a visual representation of different data elements and shows how they relate to one another. You then explored database modeling in more detail by learning about different levels and types of data models. You discovered that there are 3 levels of database models. There's the conceptual data model, the logical data model, and the physical data model. You also reviewed different types of data models that you can use to design your database, like entity relationship and object-oriented. Next, you learned how to structure your tables to deal with the data anomalies using the 3 main forms of database normalization. These include the insertion anomaly, the update anomaly, and the deletion anomaly. You also explored an example of a data model and designed a database model in an exercise. In the next lesson of this module, you were introduced to MySQL Workbench. You learned that MySQL Workbench is a unified visual tool for database modeling and management. It offers a range of useful features for creating, editing, and managing databases. You then discovered how MySQL Workbench is used to build a data model diagram using the software's Forward Engineer feature. You also learned how you can use MySQL to reverse engineer a model. This means you can create a data model from an existing MySQL database schema. This is essentially the opposite of the Forward Engineer feature. And you can print the model, share it, or apply changes and push it to the database using forward engineering. You also completed this lesson with a quiz item and an exercise in which you designed your own database model in MySQL Workbench. In the next module, you explored the topic of data warehousing. In this module, you learned about the architecture of a data warehouse and built a dimensional data model. You began with an overview of the concept of data warehousing. You learned that a data warehouse is a centralized data repository that aggregates, integrates, stores, and processes large amounts of data from multiple sources. Users can then query this data to perform data analysis. You then discovered that a data warehouse is defined by 4 key characteristics. It's subject-oriented, it's integrated, a data warehouse is also non-volatile, and finally, data warehouses are time-variant. You also reviewed the different forms of data that a data warehouse encounters, including structured data, semi-structured data, and unstructured data. You then explored the architecture of a data warehouse and learned that it includes the following components: data sources, the data staging area, which includes the ETL process, the data warehouse itself, and data marts. Once the data has been aggregated from the data sources, it is then integrated and stored in the data warehouse. It's then organized in data marts, where users can perform data analysis and present their findings. These components control the flow of data from different sources for data analysis and reporting. They also process and integrate this data so that users can perform data analysis. You also explored a case study of a real-world data project. In the second lesson of this module, you explored dimensional data modeling. The lesson began with an overview of the fundamentals of dimensional data modeling. You learned that a dimensional data model is based on dimensions and facts, and it's designed using star and snowflake schemas. You then explored some examples of dimensional data modeling in practice and learned that there are 4 key steps when creating a model. Choose the business process, then the grain, followed by the dimensions, and finally choose the facts. Finally, you undertook an exercise in which you created your own dimensional model. In the third module of this course, you explored data analytics in the context of dimensions and measures, and you learned how to perform visualized data analysis using an advanced analytics tool. You started with an overview of data analytics. You recapped the basics of data analytics and the key types that you've made use of at other points in your database engineering journey. You also learned that there are 2 generic types of data you'll deal with: quantitative data, which refers to numerical data, and qualitative data, which refers to non-numerical data. When you've determined what kind of data you need, you can process and analyze it using 4 measurement scales: the nominal scale, the ordinal scale, the interval scale, and the ratio scale. Next, you learned about the topics of data mining and machine learning. You learned that data mining is the process of detecting patterns in data, while machine learning is the process of teaching a computer how to learn. Machine learning makes use of data mining models to process data like classification analysis, the associate rule, clustering analysis, and regression analysis. You then learned about data visualization. You learned that when visualizing your data, you must consider your audience and the information they're looking for. You then need to choose an appropriate chart that best communicates this information. Finally, you concluded this lesson with a discussion prompt that revolved around what kind of data analytics reports you make use of. In the final lesson of this module, you reviewed the topic of data analytics and learned how to make use of data analytics tools like Tableau. As part of your introduction to Tableau, you learned what its key features are and how they help you perform data analytics. You then learned how to use Tableau to analyze data. This included the following steps: download, launch, and navigate Tableau, load and prepare data for analysis, filter and visualize data, and create an interactive dashboard. Finally, you undertook a lab exercise in which you performed data analysis in Tableau. You've reached the end of this course recap. It's now time to try out what you've learned in the graded assessment. Good luck. Congratulations, you've reached the end of this course. You've worked hard to get here and developed a lot of new skills along the way. You're making great progress on your advanced data modeling journey, and you should now possess an advanced understanding of database modeling. You were able to demonstrate some of this learning in an exercise. Following your completion of this exercise, you should now be able to design a database model in MySQL Workbench, understand the role of the data warehouse in the data analytics process, create a dimensional data model using a data warehouse, and perform data analysis using Tableau and present your results using data visualization techniques. The graded assessment then further tested your knowledge of these skills. However, there's still more for you to learn. So if you found this course helpful and want to discover more, then why not register for the next one? You'll continue to develop your skill set during each of the Database Engineer courses. In the final project, you'll apply everything you've learned to create your own fully functional database system. Whether you're just starting out as a technical professional, a student, or a business user, the course and projects prove your knowledge of the value and capabilities of database systems. The project consolidates your abilities with the practical application of your skills. But the project also has another important benefit. It means that you'll have a fully operational database that you can reference within your portfolio. This serves to demonstrate your skills to potential employers, and not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. And once you've completed all the courses in this specialization, you'll receive a certificate in database engineering. The certificate can also be used as a progression to other role-based certificates. Depending on your goals, you may choose to go deep with advanced role-based certificates or take other fundamental courses once you earn the certificate. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.
Welcome to the Capstone course. You're now within reaching distance of the end of your database engineering journey. In this final course, you need to prove your new skills by helping Little Lemon complete a series of database-related tasks. These tasks include setting up a database in MySQL Workbench using a MySQL instance server, creating an entity relationship or ER diagram and implementing it in MySQL Workbench, and you need to commit the project using Git. You also need to help them create sales reports from the data in their database, build a table booking system, generate data insights using data analytics, and create a database client. Let's take a few minutes to review the processes and tools that you'll use to complete these exercises. In the first set of tasks, you'll help Little Lemon to build a relational database system by designing a well-structured entity model or ER diagram that conforms to the 3 fundamental normal forms. You'll design the ER diagram using MySQL Workbench, a unified visual tool used for database modeling and management. A key feature of MySQL Workbench that you'll make use of is the ability to transform your data model in a physical database schema in a MySQL server. Once you've created the Little Lemon database, you'll then commit your project using Git, the version control system. You'll also make use of GitHub to store your Git repositories. Your next task is then to create sales reports from the data in the Little Lemon database. You'll create these sales reports using database queries, procedures, and prepared statements. Let's look at these in more detail. You'll use virtual tables to make use of data that exists in other tables and simplify data access and queries. You'll also make use of different kinds of join clauses to link records of data between one or more tables based on a common column. You'll help Little Lemon to use stored procedures to create reusable code that can be invoked and executed as required. And you'll also rely on prepared statements that can be used repeatedly without the need for compiling or using valuable MySQL resources. Another task you'll assist Little Lemon with is building a table booking system in their database that they can use to keep track of guests visiting the restaurant. This task mainly consists of using SQL queries and transactions. Let's review some examples of the SQL queries and transactions that you'll use. You'll create data using standard insert into statements. You'll change data in the database using update statements. You'll also delete or drop data using delete statements. And finally, you'll read your data using read queries like select statements. You'll also make use of triggers to store a set of actions in the form of a stored program that you can then invoke automatically when certain events occur. Once you're confident that your code is correct, you'll commit your progress to Git. In the next task, you'll help Little Lemon use their data to generate business insights. You'll carry out this task using Tableau, the data visualization tool. Let's review the process steps that you'll follow to complete this task. You'll first connect your data sources to Tableau. You'll then prepare your data for analysis and focus on the most relevant data. The next step is to create a visualization of your data using its UI elements. Finally, you'll use Tableau to produce interactive, real-time data visualizations in the form of dashboards. These process steps will help to provide clear and relevant answers to Little Lemon's important business questions. Your final task is to help Little Lemon create a database client so that they can interact with their database using a Python-based application. To begin, you'll first need to identify which version of Python is running on your machine. Once you've confirmed that you're running the most recent iteration of Python, you'll need to install the Jupyter IDE to run your code on. You can then open a new instance of the Jupyter Notebook and use it to connect Python to the Little Lemon MySQL database. You can establish this connection using the Python library, MySQL connector, and the pip software package. Once you've set up your Python environment, you can begin working with your database client. So now that you're familiar with the tasks you need to complete, it's time to get started. Don't worry, I'll be here to provide you with guidance along the way. You can also refer to the relevant learning material from previous courses if you need more help. Best of luck. In this lesson, you need to help Little Lemon set up their database project. There are 3 key steps required to set up the project. Set up the database in MySQL Workbench using a MySQL instance server. Create an entity relationship diagram and implement it in MySQL Workbench. And then commit the project. Over the next few minutes, you'll recap these topics and learn how you can make use of them in the lesson. To help Little Lemon build their relational database system, you'll first need to design a well-structured entity relationship data model, or ER diagram. You'll need to make sure that the diagram conforms to the 3 fundamental normal forms. By conforming to these forms, you'll ensure the integrity of your database and avoid the insertion, update, and delete anomalies. As you've discovered in previous courses, there are many professional tools that you can use to design an ER diagram. In this project, you'll work with MySQL Workbench. You should be familiar with MySQL Workbench from other courses, so for now, let's just quickly recap the basics. MySQL Workbench is a unified visual tool that's used for database modeling and data management. Its key advantages are that it's open source, cross-platform, and provides support for a visual SQL editor. It also lets you transform your data model in a physical database schema in a MySQL server. If you haven't already installed MySQL Workbench on your operating system, then you can download and install a copy from dev.mysql.com/downloads. Once you've downloaded a copy of MySQL Workbench, run the installer file and make sure to install the following: MySQL Server, MySQL Workbench, and MySQL Shell. The installation process is relatively straightforward. However, if you do face any challenges, you can refer to the installation material in the previous courses, or visit the Oracle website for a detailed set of instructions. Once you've created the Little Lemon database, you then need to commit your project. You can commit a project using Git. Git is a free, open-source distributed version control system. You can use it to manage all source code history. You can keep a history of your commits, revert to previous versions, and share code to collaborate with other developers. You can download and install Git from the URL git-scm.com/downloads. Your Git repositories are typically stored on GitHub. GitHub includes the source control management features of Git, along with other useful features. These features include project management, support ticket management, and bug tracking. You can also use it to share, access, and store repositories, including backups. To sign up to GitHub and get started, visit the official site at github.com. Now that you're familiar with the required technology, you can begin helping Little Lemon to develop their database system. You can set up the database in MySQL Workbench, create an ER diagram, and commit your model. If you need more information on any of these topics, then you can review the learning material from previous courses. Good luck! In this lesson, you helped Little Lemon set up their database project. There are 3 key steps that you carried out to set up the project. You set up the database in MySQL Workbench using a MySQL Server instance. You created an entity relationship or ER diagram and implemented it in MySQL Workbench. And then you committed the project. Let's take a few minutes to recap how you completed these tasks in the module. To help Little Lemon build their relational database system, you designed a well-structured entity relationship data model or ER diagram that conformed to the 3 fundamental normal forms. By conforming to these forms, you ensured the integrity of your database and avoided the insertion, update, and deletion anomalies. There are many professional tools that can be used to design an ER diagram. In this module, you worked with MySQL Workbench. MySQL Workbench is a unified visual tool that's used for database modeling and data management. There are several key advantages of the tool that you made use of in your project. Its key advantages are that it's open source, cross-platform, and provides support for a visual SQL editor. It also lets you transform your data model in a physical database schema in a MySQL server. You are able to download and install a copy from dev.mysql.com/downloads. Once you downloaded a copy of MySQL Workbench, you ran the installer file and made sure to install the following: MySQL Server, MySQL Workbench, and MySQL Shell. Once you created the Little Lemon database, you then committed your project using Git. Git is a free open source distributed version control system. You used it to manage all your source code history, keep a history of your commits, revert to previous versions, and share code to collaborate with other developers. You downloaded and installed Git from the URL git-scm.com/downloads. You are able to store your Git repositories on GitHub. GitHub includes the source control management features of Git along with other useful features. These features include project management, support ticket management, and bug tracking. You are also able to use it to share, access, and store repositories, including backups. Now that you've reached the end of this module summary, the next stage of this module is to complete the module quiz and then review the additional resources. When you've completed these tasks, you can then progress to the next module. Little Lemon need to create sales reports from the data in their database. You can help them to produce their sales report by querying their data. You can query their data using virtual tables, joins, stored procedures, and prepared statements. Recap the basics of these tasks and then see if you can help Little Lemon. Little Lemon can query their database using a virtual table. As you should know from previous courses, a virtual table makes use of data that exists in other tables. It doesn't physically store any data. It's more like an interface that provides access to data in the database. There are several benefits to these tables. They simplify data access and queries. They can be used to create a join from virtual and base tables. You can use them to efficiently manipulate and filter data, and they support database security. When creating virtual tables, you'll make use of joins to build a view from multiple tables. Joins are used to link records of data between one or more tables based on a common column. You might use a join to find information about a specific activity or object within the database, or you might need to find where the relevant information exists in more than one table. There are several types of joins that you've explored within these courses. These include inner join, left join, and right join. There's also the self join and the full outer join. You can make use of these joins to query Little Lemon's database and retrieve the information they need. You'll also need to help Little Lemon using stored procedures. The main purpose of stored procedures is to create reusable code that can be invoked and executed efficiently. This makes your code more consistent, reusable, and easier to use and maintain. So instead of typing the same code repeatedly, you can save your blocks of code as stored procedures that you can then invoke when required. You can create as many procedures as you need, and they can include multiple parameters. Your code can also include various types of SQL code. Just make sure each one has a unique name. Remember that how you create a stored procedure depends on the task that you need to achieve. You'll also assist Little Lemon with the use of prepared statements. Each time you create SQL statements, they need to be compiled and parsed by MySQL before they can be executed. A more efficient method is to create a prepared statement that only needs to be compiled once and can then be used repeatedly. In other words, you can create a prepared statement that MySQL compiles and parses just once before it's executed. So each time the statement is invoked, MySQL knows that it's ready to use and safe to execute. Prepared statements are a much more efficient and optimal way of executing statements without using valuable MySQL resources. You should now be familiar with the techniques and methods that you can use to create a sales report for Little Lemon. If you need more information on these topics, then remember that you can review the learning material from previous courses. Well done. Little Lemon need to build a table booking system within their database. They can then use this system to keep track of guests visiting the restaurant. You can use your knowledge of SQL transactions to help them create this system. You can help them to create the system using SQL queries, transactions, and CRUD operations. Developing a table booking system requires the use of SQL transactions or queries. As you know by now, transactions are statements that are executed within a database. The main types of statements that you need to use include create, read, update, and delete queries. These are also known as CRUD operations. Let's run through the basics of how you can use these queries to complete the tasks in this lesson. You can help Little Lemon to develop and populate their table booking system by creating data in the form of new bookings. You can create data using a standard insert into statement. Just be sure to identify the following within your syntax: the table you want to create the data within, the columns that must be populated, and the values that they need to contain. Execute this statement to create the data within your database. There might also be instances in which the data that you originally created needs to change. Perhaps someone wants to update their booking, or maybe they've cancelled their booking, so their data needs to be deleted from the table. You can carry out these actions using update and delete statements. Use an update query to alter information within the table. Identify the following information within your query: the name of the table to be updated, the columns to be updated, and the new values to be added to these columns. If you're deleting or dropping information from the table, then you'll need to use a delete query. Your delete query must contain the following information: the name of the table that contains the data to be deleted, and any conditions related to that data. You can enact these conditions using a where clause. Once you've created, updated, or deleted data within the booking table, you'll need to run tests to make sure that your queries have been executed successfully. You can carry out these tests by reading the data. A read query returns all information that matches the criteria within your statement. An example of a basic read query is a select statement. In this case, you must make sure that the select statement contains the following: the name of the table and columns that hold the data, the values you require, and any conditions required to help you target the data. You can also enhance your transactions with the use of triggers. A MySQL trigger is a set of actions available in the form of a stored program. This set of actions is then invoked automatically when certain events occur. You can use triggers for different types of events, like CRUD operations. To use a trigger, you first need to create it using the create trigger statement. Then define the trigger type. Is it an insert, update, or delete trigger? And should it be executed before or after the event? You also need to define the trigger's logic, specify which table it's assigned to, and how it should be applied to the table. You've explored many different examples of read queries within this course. The important thing to remember is to make sure that you include conditions within your statement that target the exact data you need. This is good advice to follow for all types of operations. Once you're confident that your code is correct, you can commit your progress to Git. It's also a good idea to enact version control. This way, you can keep track of snapshots that show the project in different stages of development. You can then roll back to previous versions if required. You should now be ready to make use of SQL queries and transactions to help Little Lemon develop a booking table system within their database. If you need more information on these topics, remember that you can review the learning material from previous courses. Good luck. In this module, you helped Little Lemon to create sales reports from the data in their database. You also helped them to build a table booking system. Let's take a few minutes to recap the tasks, processes, and tools you completed or made use of in this module. In the first task, you created a sales report for Little Lemon by querying the data in their database using virtual tables, joins, stored procedures, and prepared statements. You helped Little Lemon to query their database using a virtual table to make use of data that exists in other tables. The benefits of the virtual table are that you are able to use it to simplify data access and queries, create a join from virtual and base tables, efficiently manipulate and filter data, and support database security. You also made use of the join clause to link records of data between one or more tables based on a common column. There are several types of joins that you were able to make use of in this module, including inner join, left join, and right join. You also had the opportunity to use the self join and the full outer join. You also helped Little Lemon to use stored procedures. Stored procedures are used to create reusable code that can be invoked and executed efficiently. By using these procedures, you made your code more consistent, reusable, and easier to use and maintain. So instead of typing the same code repeatedly, you were able to save your blocks of code as stored procedures that you could then invoke when required. You were able to create many stored procedures, and you could include multiple parameters in each one. You were also able to include a range of syntax like SQL statements, variables, and control structures, while making sure that each one had a unique name. And how you created your stored procedures depended on the tasks that you needed to achieve. You also assisted Little Lemon with the use of prepared statements. Each time Little Lemon creates SQL statements, they need to be compiled and parsed by MySQL before they can be executed. You showed them that a more efficient method is to create a prepared statement that can be used repeatedly without the need for compiling. Prepared statements are a much more efficient and optimal way of executing statements without using valuable MySQL resources. MySQL compiles and parses a prepared statement just once before it's executed. In the second lesson of this module, you helped Little Lemon to build a table booking system in their database that they could use to keep track of guests visiting the restaurant. You were able to help Little Lemon develop and populate their table booking system by creating data in the form of new bookings. You created data using standard insert into statements while identifying the following within your syntax: the tables you wanted to create the data within, the columns to be populated, and the values that they needed to contain. You then executed your insert into statements to create the data within your database. There were also instances in which the data that you originally created needed to change. You were able to carry out these actions using update and delete statements. You used an update query to alter information within the table while identifying key information in each of your queries. When you were deleting or dropping information from the table, you used a delete query, again making sure to identify key information in your query. Once you created, updated, or deleted data within the booking table, you ran tests to make sure that your queries were executed successfully. You carried out these tests using read queries like select statements. In this case, you made sure that your select statements contained the following: the name of the table and columns that held the data, the values you required, and any conditions required to help you target the data. You also made use of triggers to store a set of actions in the form of a stored program that you could then invoke automatically when certain events occur. To use triggers, you first created them using the create trigger statement. Then you defined the trigger type. For example, you specified if they were insert, update, or delete triggers, and if they should be executed before or after the event. You also defined the logic of your triggers, specified which tables they were assigned to, and how they should be applied to the table. Once you were confident that your code was correct, you then committed your progress to Git and enacted version control. You have helped Little Lemon to create sales reports and a table booking system using database queries, procedures, and prepared statements. Well done. I look forward to providing you with more guidance in the next module. Little Lemon need to perform advanced data analytics to generate data insights that can help to inform their business decisions. They can then use these data insights to inform their business decisions, like identifying new opportunities for growth or improving services. This task requires the use of powerful data analytics tools like Tableau. With Tableau, Little Lemon generate insights using its data analysis features. They also need to connect their data source to the software, prepare the data for analysis, and present their insights using worksheets and interactive dashboards. In this video, you'll recap the key process steps and features of the tool and find out how you can make use of Tableau to help Little Lemon generate their business insights. Tableau is a widely used data visualization tool. There are several key features it offers that users can take advantage of when analysing data. For example, with Tableau, you can connect to a wide range of data sources, process large amounts of different data types, and create visualized data charts. You can also generate interactive real-time dashboards, script in Python and R, and complete tasks using interactive UI tools. The dashboard interface offers many useful features for analysing data. You can connect your data sources to Tableau using the Connect pane in the launch page. Once you connected to a data source, the related fields appear in the data pane. You can then use the authoring workspace's UI elements to create a visualization of your data using worksheets, dashboards, and story. You can also use the worksheets to add data to your view using the marks card. Or you can analyze and visualize data using the row and column shelves. You can make use of Tableau's other useful features to access commands and tools in the toolbar menu, work with multiple sources of data in the dashboard view, arrange data in ascending or descending order using sorting icons, and you can use Story to present worksheets and dashboards. Once you've loaded data into Tableau, you then need to prepare it for analysis. There are several steps involved in this process, including splitting data for greater accessibility, creating calculated data fields, fixing data types, and filtering data. With Tableau, you can focus on relevant data using the software's filtering and visualization features. By filtering data, you can focus only on the data you need. You can also drill down, roll up, and filter data to show it from different perspectives or in different levels of detail. Tableau can also be used to filter data using either the worksheet or the source data page. However, filtering data directly in the data source page limits your data analysis in all worksheets to the filtered criteria only. One of Tableau's key features is its ability to produce interactive, real-time data visualizations in the form of dashboards. A well-organized dashboard can help to provide clear views and relevant answers to Little Lemon's important business questions. Once you've analysed data in Tableau's worksheets, you can then combine data from multiple sources. You can add filters or drill down or roll up into specific information. You've now recapped the key features of the Tableau tool. You should now know how to make use of this tool to create worksheets and interactive dashboards that can help Little Lemon to generate business insights from their data. If you need more information on any of these topics, then remember that you can review the learning material from previous courses. Good luck. Little Lemon need to create a database client so that they can interact with their database using a Python-based application. You can help them by completing the following tasks. Review the version of Python installed on your machine. Install a suitable integrated development environment or IDE for Python. And connect Python to the Little Lemon MySQL database. Let's take a few minutes to review these tasks. As you just saw, the first task is to identify which version of Python is running on your machine. Open the command prompt and type Python --version to check which version of Python is running on your operating machine. If Python is correctly installed, then Python 3 should appear on your console screen. This means that you're running Python version 3. There should also be several numbers after 3 to indicate which iteration of Python 3 you're running. Make sure that these numbers match the most recent version on the python.org website. If you search for Python and see a message that says Python is not recognized as an internal or external command, then review your Python installation or the relevant documentation on the Python website. Once you've installed Python or confirmed that you're running the correct version, you then need to choose an IDE to run your code on. An IDE is software that you can use to display your code. In this course, you'll use the Jupyter IDE to demonstrate Python. To install Jupyter, type python-m pip install Jupyter within your Python environment. Then follow the Jupyter installation process. Once you've installed Jupyter, type Jupyter Notebook to open a new instance of the Jupyter Notebook to use within your default browser. The next task is to connect Python to your MySQL database. You can create the installation using a purpose-built Python library called MySQL Connector. This library is an API that provides useful features for working with MySQL. The MySQL connector must be installed separately using a package installer called pip. The pip package is included with the Python software that you installed. Create a new notebook instance and name it Configuring MySQL Connector. Then install the connector using pip. To install the connector, type an exclamation mark and pip to call the package. Then type the install command. Next, type the name of the library, which is mysql-connector-python. Make sure you type Python with a lowercase p. Then press Shift and Enter or select Run to execute the code. The final step is to check that your environment has been correctly configured. Type import mysql.connector as connector and click Run. If there's no output in the cell, then the library has been imported successfully. You should now know how to install and configure your environment to help create and connect a database client to Little Lemon's database. If there's any parts of this lesson that you need more guidance on, then you can review the specific learning material in previous courses. Great work! In this module, you help Little Lemon to perform advanced data analytics to generate data insights to inform their business decisions. You also help them to create a database client that they could use to interact with their database using a Python-based application. Let's take a few minutes to recap the tasks, processes and tools that you used in this module. In the first lesson, you used Tableau to help Little Lemon generate insights using the tool's data analysis features. Tableau is a widely used data visualization tool. There are several key features it offers that you were able to take advantage of when analysing data. For example, with Tableau, you were able to connect to a wide range of data sources, process large amounts of different data types, and create visualized data charts. You were also able to generate real-time interactive dashboards, script in Python and R, and complete tasks using interactive UI tools. You were also able to make use of the dashboard interface's features to analyze data. You connected your data sources to Tableau using the Connect pane in the launch page. Once you connected to your data source, you then used the authoring workspace's UI elements to create a visualization of your data using worksheets, dashboards, and story. You also used the worksheets to add data to your view using the marks card, and analyze and visualize data using the row and column shelves. You then prepared your data for analysis using process steps like splitting data for greater accessibility, creating calculated data fields, fixing data types, and filtering data. With Tableau, you also focused on relevant data using the software's filtering and visualization features, so you could focus only on the data you need. You also used the drill down, roll up, and other filtering features to show the data from different perspectives or in different levels of detail. You also use Tableau to produce interactive real-time data visualizations in the form of dashboards. Your well-organized dashboards help to provide clear views and relevant answers to Little Lemon's important business questions. In the next lesson, you helped Little Lemon to create a database client so that they could interact with their database using a Python-based application. You first identified which version of Python was running on your machine using the command prompt. Once you confirmed that the correct version of Python was correctly installed, you checked which iteration of Python 3 you were running. And you checked that it matched the most recent iteration on the official Python website. Once you confirmed that you were running Python, you then chose an IDE or integrated development environment to run your code on. In this course, you used the Jupyter IDE to demonstrate Python. You followed the Jupyter installation process and then typed Jupyter Notebook to open a new instance of the Jupyter Notebook to use within your default browser. You then connected Python to the Little Lemon MySQL database. You created the installation using a purpose-built Python library called MySQL Connector. You were able to do this using the pip software package. Then you checked that your environment was correctly configured to ensure that the library was imported successfully. Once you set up your Python environment, you were able to begin working with your database client. You completed an exercise in which you added or implemented query functions using Python to query the Little Lemon database. Finally, you committed your progress to Git. You have helped Little Lemon to perform advanced data analytics to generate data insights to inform their business decisions. And you have also helped them to create a database client that they can use to interact with their database using a Python-based application. Well done. I look forward to providing you with more guidance in the next module. Congratulations, you've almost reached the end of this capstone course and your database engineering journey. In this final module, you'll need to demonstrate your knowledge in a peer review exercise and graded assessment. But before you begin, let's recap the tasks that you helped Little Lemon to complete in this course. These tasks include setting up their database in MySQL Workbench using a MySQL Server instance, creating an entity relationship or ER diagram and implementing it in MySQL Workbench, and committing the project using Git. You also help Little Lemon to create sales reports from the data in their database, build a table booking system, generate data insights using data analytics, and create a database client. Let's take a few minutes to review the processes and tools that you use to complete these tasks. In the first set of tasks, you help Little Lemon to build a relational database system by designing a well-structured entity model or ER diagram that conform to the 3 fundamental normal forms. You design the ER diagram using MySQL Workbench, a unified visual tool used for database modeling and management. The key feature of MySQL Workbench that you made use of is its ability to transform your data model in a physical database schema in a MySQL server. Once you created the Little Lemon database, you then committed your project using Git, the version control system. You also made use of GitHub to store your Git repositories. Your next task involved creating sales reports from the data in the Little Lemon database. You created these sales reports using database queries, procedures, and prepared statements. Let's take a quick look at some of the different types of queries that you used. You used virtual tables to make use of data that exists in other tables and to simplify data access and queries. You also made use of different kinds of join clauses to link records of data between one or more tables based on a common column. You helped Little Lemon to use stored procedures to create reusable code that they could invoke and execute as required. And you also relied on prepared statements that could be compiled just once and then used repeatedly. Another task you assisted Little Lemon with involved building a table booking system in their database that they could use to keep track of guests visiting the restaurant. This task mainly consisted of using SQL queries and transactions. Let's review some examples of the SQL queries and transactions that you used. You created data using insert into statements. You changed data in the database using update statements. You also deleted or dropped data using delete statements. And finally, you read your data using read queries like select statements. You also made use of triggers to store a set of actions in the form of a stored program that you could then invoke automatically when certain events occurred. Once you were confident that your code was correct, you committed your progress to Git and enacted version control. In the next task, you helped Little Lemon use their data to generate business insights. You carried out this task using Tableau, the data visualization tool. Let's review the process steps that you followed to complete this task. You first connected your data sources to Tableau. You then prepared your data for analysis and focused on the most relevant data. The next step was to create a visualization of your data using its UI elements. Finally, you used Tableau to produce interactive real-time data visualizations in the form of dashboards. These process steps help to provide clear and relevant answers to Little Lemon's important business questions. Your final task was to help Little Lemon create a database client so that they could interact with their database using a Python-based application. To begin, you first identified which version of Python was running on your machine. Once you confirmed that you were running the most recent iteration of Python, you installed the Jupyter IDE to run your code on. You then opened a new instance of the Jupyter Notebook and used it to connect Python to the Little Lemon MySQL database. You established this connection using the Python library, MySQL connector, and the pip software package. Once you set up your Python environment, you then began working with your database client. So, now that you've recapped the tasks you completed, it's time to begin the peer review project. Don't worry, you've worked hard to make it this far, so I'm sure you'll do your very best in the project. Best of luck. Congratulations! You've reached the end of this capstone project course. You've worked hard to get here and developed a lot of new skills along the way. You made great progress on your MySQL journey. This course and all you have achieved is really a culmination of all the previous courses you've completed in this database engineering program. You understand the basics of database engineering and MySQL syntax. You have a solid foundation in database structures and management, and you're familiar with advanced MySQL. You're also familiar with the basics of Python. You understand and can implement advanced data modeling techniques, and you demonstrated your skill set in this final course by designing a database project. With this course, you are able to reinforce and demonstrate the learning and practical development skill set you have gained throughout this program. This was achieved through hands-on guided practice around the creation of a fully functioning database system for Little Lemon. The graded assessment further tested your knowledge of database engineering. Now that you've completed the final project, it's a great time to pause and reflect on your journey. You can reflect on the completed course from several vantage points. You could consider the links between this course and the previous ones you've completed, or you could reflect on the process of completing the project. For example, what were the hardest parts of the project? What were the easiest? What experience did you gain from working on the project? And would you benefit from revisiting previous courses? Whether you're just starting out as a technical professional, a student, or a business user, this course end project proves your knowledge of the value and capabilities of database systems. The project consolidates your abilities with the practical application of your skills. But the project also has another important benefit. It means that you have a fully operational database that you can reference within your portfolio. This serves to demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. You've completed all the courses in this specialisation and earned your certificate in database engineering. The certificate can also be used as a progression to other role-based certificates. Depending on your goals, you may choose to go deep with advanced role-based certificates or take other fundamental courses. Certifications provide globally recognised and industry-endorsed evidence of mastering technical skills. You've done a great job and you should be proud of your progress. The experience you've gained shows potential employers that you are motivated, capable and not afraid to learn new things. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.
Hello and welcome to this coding interview preparation course. This course will help prepare you for the unique and challenging aspects of a potential coding interview, including some of the approaches to problem solving and computer science foundations that you may need to be aware of or apply. Let's take a moment to preview some of the key concepts and skills that you'll learn. In the first module, you'll start by discovering what a coding interview is, what it can consist of, and the types of coding interviews that you might encounter. You'll also explore how you can prepare yourself for a coding interview, including a focus on communication, such as explaining your thought process, handling mistakes, and the STAR method. You'll also learn about how to work with pseudocode to demonstrate how you might reach a solution, some important tips that might help with any practical solution design, and how to test your solutions. Next, you'll get an introduction to computer science, starting with the fundamental concepts of binary, and how binary relates to real-life hardware and computing. You will explore memory and the key components of computer memory, read access memory, RAM, and read-only memory, ROM, and how your computer uses memory to perform its tasks, processes information, and store data. Next, you will take a dive into time complexity and the key concept that underpins this, Big O notation. And you will discover some of the types of Big O notation and how this applies to algorithmic processing. You will explore space complexity, which is essentially the space required to compute a result. In the second module, you will learn about data structures and how each one comes with certain benefits and limitations. So understanding each of these can be really important when designing a solution. You will start with basic data structures by addressing the implementation and capabilities of data structures between various programming languages and the similar patterns of the overarching architecture. You will explore the main basic data structures: strings, integers, booleans, arrays, and objects. You will go on to examine some collection data structures, starting with lists and sets. Then you will learn about stacks, queues, and trees, before moving on to some advanced data structures, namely hash tables, heaps, and graphs. In the third module, you will get an introduction to algorithms, including the types of algorithms available to you and how best to work with them to sort and search your data. You will start by exploring sorting algorithms and how working with sorted data or having the ability to sort your own data can result in significant time savings. And you will explore the three main types of sorting: selection sort, insertion sort, and quick sort. And you will learn that each approach has its trade-offs and is more effective in some environments than others. Next, you will discover searching algorithms and how each type provides its own framework for problem solving. You will also gain insight into time and space complexity in both searching and sorting algorithms. You will take a deep dive into the processes and underlying mechanisms involved with divide and conquer, recursion, dynamic programming, and greedy algorithms. Finally, in the last module, you will get the chance to recap on everything you've learned throughout the course before taking the graded course quiz, which will test you on all of the key concepts and skills you have learned throughout the course. In this video, you have had a broad overview of the course. Specifically, you have discovered how this course will help you prepare for the unique and challenging aspects of a potential coding interview, including some of the approaches to problem solving and computer science foundations that you may need to be aware of or apply. Now, let's get started.
It takes approximately 39 months to find software engineers and developers in tech hub cities in the US.
The interviews that you will go through sometimes have skills that you don't normally use in your day-to-day job.
It's not just about how well you can program, it's also about how well you're displaying a lot of interpersonal skills, how well you're able to drive projects, how well you're able to collaborate with others.
You don't need to worry about showing up in a suit. You really can just kind of wear whatever, be yourself, and focus on the technical aspects of the interview. Hi, my name is Julie, and I am a software engineer on the IG shopping team at Meta New York.
Hi, my name is Moxie Herrera. I use they, them pronouns. I'm a software engineer in the social impact org at Meta, and I work out of the Menlo Park office.
My name is Chanel Johnson. I work remotely in Maryland for Meta, and I'm a software engineer for the Facebook App Core Architecture team, where we work on infrastructure for the Facebook mobile app.
My name's Mari Batulando. I am a software engineer for the Web3 monetization team within Meta, and I work on different ways creators and influencers can make a living off of the Facebook platform using Web3 technologies like NFTs and cryptocurrency.
I think it can be broken up into three general areas. One is the application process, one is actual interviewing, and one is the calibration process when they discuss your packet and give you an offer. In terms of the actual interview process, it's broken up into technical, architecture, and behavioral. For the application phase, it's recruiters kind of screening your resume, your work experience.
The recruiter then will meet with you and talk with you more to get a better idea about your skills, your experiences, what you're looking for to make sure that you're a good fit for the role.
Phase 2 is the technical aspect of it. There can be a range of 1 to 4 or 5 or even more interviews there.
So this could be things like a coder pad interview where you're on the phone or over a voice chat with a recruiter or a engineer to kind of go through some technical challenges. You'll have some behavioral interviews. where people are just kind of engaging of what it's like to work with you, how do you solve problems.
And then oftentimes there are architecture interviews as well, where you build kind of an end-to-end product, discuss the full architecture for that. Phase 3, the final phase, is when everyone involved in the process kind of gets together and discusses how you did throughout the phases and if they should extend an offer to you.
If you decide to take on the offer, you go through what is called boot camp, a process where you get to learn the ropes of how it is working at Meta, and also sit with the teams that you're interested in so that you know what choice you end up making, and you get to choose ultimately what team you go in. If you are interviewing for a specific pipeline like iOS, Android, or ML or AI, you should expect some questions that deal with that specific domain. So for example, in my case, I was interviewing for the iOS pipeline. So in addition to those algorithms and data structure questions that I got asked, I also got asked some iOS questions or some questions that I deal with in my day-to-day work as an iOS engineer. So you can imagine similar things as if you were an Android engineer or if you were an AI or ML engineer.
I think in the application phase is when a lot of candidates get screened out. What can really help there is crafting your resume and focusing on real experience that will really help when it comes to software engineering roles. So if you don't have job experience, totally fine, work on side projects. And that will show both, concrete experience and a drive that you're actually interested in working on the role that you're applying for.
I would say the coding interview portion is where a lot of people get disqualified. There can be many reasons for it, but the biggest reason I see is that sometimes when you're writing out your code, the person being interviewed is not explaining their thought process, what's going on. They're not asking clarifying questions. Sometimes if the interviewer gives them a hint, they're not listening. So communication skills is where I also see a lot of people getting disqualified in the coding interview portion.
Some candidates I see do not have a structured process for answering problems they may not have heard or seen before. And they kind of just go cowboy coding and just start coding without even knowing what they're supposed to solve. So I think having a robust problem-solving process for questions you may or may not have seen before is very important in doing well in these coding interviews.
One common problem is people get stuck and they get so wrapped up in it that they're unable to kind of take feedback. What interviewers are looking for are a holistic approach to the problem. So it's not just about solving the problem, it's about how you go about it. It's about collaboration with the interviewer. So that's a really important piece to remember.
The biggest thing that I've learned is to really be myself. I found it much more successful and way less stressful to just be who I am unapologetically. But it also means whenever I come forward as like a candidate, like I am presenting myself as I am and not trying to hide anything, given that this is who I want to be at work. This is who I want to be in my life. And I think having that mentality has made it so much easier regardless of the outcome of the process.
Think really hard about what you want and choose companies that resonate with what you value. There are other things other than compensation and just the prestige of a company that matters in how happy you are with the company. So make sure you make a list of those and consider that whenever you are choosing companies.
My biggest piece of advice is just going through as much practice as possible. So 2 main ways to do that, I think, is 1, while you go through lead code problems or mock interviewing, doing the whole thing end to end. Even if you're unable to solve the problem, you get stuck, you don't know what to do, finishing it out as if it's a real interview, it'll give you really good practice for when you actually get to the interview. And then the second thing is apply to as many places as possible. It gives you the best chance of getting interviews. And then once you're in a real life interview situation, it's a lot easier if you've already had experience doing that before. It really helps calm the nerves and it helps you get more practice in.
There's not all just only like one particular person that we're looking for when it comes to tech. We want different backgrounds and different perspectives and experiences because that's the only way we're going to make our products better. We need that. It's such a rewarding process to make an impact and actually for the better, and just meet with people and keep learning. You will never get bored at this job, never.
As you start to interview, you will face many ups and downs. And these are all experiences you can learn from. If you keep pushing, keep learning, you will eventually get to a role where you can start an amazing career in technology.
The amount of preparation you're going to do is going to lead you to having a really big impact in the world, because software is just everywhere and it's used by millions and billions of people. So I think it's well worth the preparation, the amount of effort it takes to land a job at a very influential and impactful tech company.
A technical interview is where you demonstrate your competency to code. Normally, you would have completed a screening call and demonstrated that your soft skills are suitable for the company. Soft skills relate to your ability to conduct yourself socially. This includes communicating clearly, having a good work ethic, and that your presentation aligns with the company values. The technical interview is to determine that you are technically capable of the responsibilities of the role. In this video, you will learn how to approach the technical interview. When going for a coding interview, it will help you to keep the following steps in mind. Prepare to succeed. Solve the problem conceptually first. Employ appropriate tools. And lastly, optimize the solution. Doing a deep dive into these concepts will help you understand how to apply the method. Firstly, prepare to succeed. Many candidates might feel some trepidation at doing a technical interview. What happens if a question is asked and my mind blanks? Fortunately, there are steps that you can take to prepare for success. Failing to prepare is preparing to fail. Solve the problem conceptually first. Before employing a solution, it is a good idea to first have a clear picture of the question and what the answer will look like. Take some time to ensure that you are clear on what is being asked. An interviewer will have no issue with you seeking clarification from the onset. If there is a whiteboard, then use it. Jot down the major points of the problem before outlining a potential solution. Here is an excellent opportunity to show your ability to reason a problem using pseudocode before writing a single line of code. Demonstrating your ability to reason out a problem is halfway to it. Remember, one can always be taught to code. An ability for problem solving is a much sought after ability. Be vocal as you assess the problem and show the interviewers how you engage with problem solving and why you elected one approach over another. It can be a big help if you can equate the problem with one you already know. Later in the course, there is a video on the practice of divide and conquer. This is a good opportunity to employ that. Breaking the problem into smaller ones can help to solve a seemingly complex problem. If there is an additional time constraint and you exceed the allowed time, you will still be able to show functional chunks of code. Employ appropriate tools. The types of problems presented in a coding interview will have to be completed during the interview time. Thus, the solutions will not be excessively complicated in nature. They are designed to test your problem-solving ability on a microcosmic level and your awareness of the available tools. Consider the classical count the socks problem. You are given an array that represents sock colours. Yellow socks are represented by 1, blue socks by 2, red socks by 3, green socks by 4, and lastly orange socks by 5. Sock colours equal the numbers as explained, namely 1, 2, 2, 1, 1, 3, 5, 1, 4, and 4. Determine how many pairs of the same colour socks exist. So, there are 4 ones, which equates to 2 pairs of yellow socks. 3 and 5 represent odd socks. Although it is a red and an orange sock, they don't have matching socks to form pairs. There are 2 2s and 2 4s, which each represent a pair of blue and green socks. To solve this problem succinctly, you can utilise an appropriate data structure. Later in this course, you will review data structures. One video outlines how a dictionary stores key value pairs. A solution would be to use the sock colours as keys and the count as values. Then, iterate over the dictionary and retrieve all odd numbers, which indicates the presence of any odd socks. While there are many programmatic ways of solving this, the use of existing structures minimizes the code required and demonstrates familiarity with fundamental building blocks. When possible, always utilize existing approaches rather than attempting to implement manual solutions. In addition to familiarizing yourself with staple structures, review common sorting and searching algorithms before engaging in any technical interviews. It is good practice to optimize your code. That means writing or rewriting code so a program uses the least possible memory or disk space and minimizes CPU time or network bandwidth. Coding the solution is a good step towards a respectable solution. Ensure you make time to optimize your code. Another concept you will meet in this course is time and space complexity. Can you demonstrate to the interviewer that you understand these crucial concepts? Put simply, it is a way of measuring how fast and how much space your solution will take. When presenting your answer, outline your solution's time and space complexity, and then see if you can improve. Identify any repeat or overlapping code. Demonstrate that you can modularize this code into a function that is callable repeatedly and reuse code when possible. An often repeated principle for good programming is dry. Don't repeat yourself. It is the idea to only say a thing once in code and reuse as often as needed. Additionally, if there are portions of your code that are no longer required as a result of modularizing or as a result of an avenue of thought that was not completed, remove it. Avoid excessive compiler calls. If you are searching for a value in an array, terminate the loop when the item is found. A very achievable optimization on your code is to include a return statement when a value is found, or to use a loop that is dependent on a Boolean. As soon as a result is found, the loop can be terminated. This increases overall efficiency and reduces time complexity. Space complexity is all about being clever with memory usage. Whenever you can, avoid creating more variables than needed. In this video, you learned about some approaches that can be used regardless of the challenge presented. Even if you're not familiar with the problem or don't achieve a result in the time allotted, always strive to demonstrate your reasoning and best practice approaches. Prepare for technical interviews by doing practice solutions to online problems and, when possible, employ a similar methodology to each challenge so that regardless of the challenge faced, you are working from a comfortable framework. A coding interview can appear like a daunting task. There will always be elements of the unknown involved, and your desire to succeed may add some pre-interview nerves. Just stay calm and think logically. Good luck. The success of an interview is almost fully dependent on how you communicate with the interviewers. You wish to convey your suitability, and the company would like to find a candidate that is appropriate for the role. In this video, you will learn about verbal and physical or non-verbal communication. Never underestimate the power of first impressions. It is important that every interaction with you as a potential employee reflects the capabilities that you will bring to the organization. The first non-verbal sign that you can show is punctuality. It is good practice to arrive at least 10 minutes before the scheduled meeting is supposed to start, particularly if you are unsure of the specific venue where the interview will be conducted. It takes time to navigate a building, and you wish to appear composed and ready for the interview, not out of breath and flustered. Over the course of the interview, ensure that you maintain eye contact and actively listen to the questions that are being asked. Dress appropriately for the meeting. Generally, a job interview calls for you to wear professional or business attire. Make sure your clothes are clean and neat. That shows respect and reflects positively on yourself. Finally, maintain a good posture and refrain from squirming and needlessly touching the face or wringing the hands. While being nervous about and during a meeting is understandable, These gestures may unintentionally convey a sense that you don't feel up for the task. A great way to settle the nerves is to have done your due diligence prior to the meeting. Make sure you understand what the job entails and what the company does and stands for. Although it is important to understand the importance of nonverbal communication, verbal communication is equally important. You need to be able to speak to your interviewers. A good indicator of how to conduct yourself in an interview is to observe the interviewers. Listen carefully. They will lead with questions to see if you fit the required skills and personality profile. Typically, an interviewer will aim for the 80-20 rule, speaking for 20% of the time and allowing you to present yourself for the other 80%. So, allow the interviewer to direct the question to you completely before answering. Use clear and concise language in your answers. The temptation, particularly if you have done diligent preparation, is to try and respond to a question with everything you know on the topic. This may lead to some rambling. A better answer is one that stays on topic and allows for the opportunity for further questions. A good interviewer will follow up with related questions, so this allows for the conversation to flow. Refrain from exaggerating your abilities or being negative towards yourself. Be careful not to use emotive terms that can convey negative attitudes about yourself. For example, rather than saying, "I failed at that task," you could say, "That task was challenging, but provided me with some ideas for future areas of research to explore." Additionally, avoid excessive slang, cursing, or inappropriate humour. A good methodology to follow when conducting an interview is the STAR method. Initially, the interviewer will attempt to make you feel welcome by giving you an opportunity to talk about yourself. What is on your CV? What do you know about the company or the role? As the interview progresses, the discussion will focus more on your abilities and suitability for the role. It is important that you can convey why you are a good fit. Typically, questions will focus on the business needs, either technologies that are being used or problems that have had to be overcome. The interviewer wants to know how you would respond to issues that arise when engaged with the job. Therefore, try to answer questions using the STAR method. Include the following 4 points when answering a question: the situation, the task, the action, and lastly, the result. Here are some examples to demonstrate the method more clearly. What is the context of the situation? What is the project? And what are the challenges faced? Looking at the task, what would your responsibilities and assignments be? What actions will you take to rectify or address the challenges? What are the results or outcomes of your actions? How did taking this approach impact the result? Using this approach as a template for an answer will give depth to your responses. It provides a workable framework for an answer. It also gives the interviewer a chance to respond with more related questions on areas you feel comfortable discussing. Let's recap what you have learned in this video. An interviewer will be on the lookout for candidates that can clearly convey a concept. Your first task is to communicate why you are suitable for the role. This is done verbally and non-verbally. Finally, the STAR method is a very efficient framework for engaging with technical questions that will arise over the course of an interview. In this video, you have learned that verbal and non-verbal communication is key during an interview. In any given role in a company, you may have to deal with the stakeholders, whether it be complications with the role or why a given solution is the optimal path to take. So, take what you have learned about communication and apply the principles with confidence.
Almost half of software developers, according to data from a popular employment website, find the coding interview portion the most stressful portion out of all of the technical interview.
You are going to be asked a lot of technical problems, a lot of architectural problems, organizational problems, They really want to know who you are as a person and what you value.
When I was interviewing, one way that I practiced was I had an actual stuffed animal that I would talk to. And this just really forced me to practice the interview end to end as if I was actually talking out loud.
I think the interviewers at Meta have been trained very well to make the interviewee feel welcome and comfortable in solving problems together. My name is Mari Batulando. I am a software engineer at Meta, and I work in the FB Web3 monetization team, where I help creators and influencers make a living by using the Facebook product.
My name is Moxie Herrera. I use they, them pronouns. I'm a software engineer in the social impact org at Meta, and I work out of the Menlo Park office.
Hi, I'm Julie. I'm a software engineer on the IG shopping team at Meta New York.
My name is Chanel Johnson. I work remotely in Maryland for Meta, and I'm a software engineer for the Facebook App Core Architecture team, where we work on infrastructure for the Facebook mobile app.
There are generally 3 different types of interviews: technical, which is your regular elite code interviews, architecture interviews, and then behavioral. The technical interviews, the leak code-esque questions, you'll typically have 2 to 4 of these in the interview process. 1 or 2 will be as a screen, and then there'll be a couple more after you pass the initial screen. And these are just going to be 20 or 30 minutes per question, just your classic leak code questions. The architecture interview is going to be about a 45-minute to hour-long interview where you'll get a question of how to build kind of an end-to-end feature. So this can either be more product-oriented, like build Tetris, or it can be more back-end oriented, kind of focused on how data flows and how to scale this to many users. And then finally, for the behavioral interviews, you can expect questions like about your experience working with other people, collaborating, challenges you've faced, exciting projects that you've worked on.
Questions I usually ask is, what is an experience that you've had when working on a team that things did not go well? And the main reason I ask for this is because at Meta, you're going to have to be working with a lot of people. It's not just a solitary job. So you need to learn how to communicate and how to really learn and grow with people.
When I was interviewing, I was asked a lot of general questions that I would expect as an iOS engineer. So for example, how would I build the newsfeed surface in the Facebook app? What objects will I make? How will those objects talk to each other? What networking APIs do I expect? And being able to, at a high level, describe how I would tackle these challenges and how I would structure the app as an iOS engineer. So that's a very classic question.
One advice I would give in order to practice for interview questions is to talk out your solution when you're whiteboarding it. So one thing I would do is, like with friends or colleagues, when you write out your solution, explain your thought process on what's going on. Are you considering time complexity? Are you considering how to make this faster? How to reduce space? These are things that we also want to see as interviewers, because when you're coding on the job, these are things you need to think about. So this is a good practice for you to explain when you go through your code of like, hey, this is why I'm doing this because of X, Y, and Z, and I'm also considering this.
As an interviewer, I am actually rooting for you to do well, because what I want as an interviewer is to not sit there and stare at the screen for 45 minutes watching you struggle. I would much rather see you succeed and for us to work together on a problem so that I can gather as much signal from you as I can, so that I can make a good decision whether or not you would be a fit for Meta.
In terms of dress for the interview, the key is to really just be yourself. Wear something that you're comfortable with. No one expects you to show up in a suit. I get a lot of interviewees that are wearing just a t-shirt and jeans.
I am really looking for a candidate that is willing to explain their thinking, willing to engage very deeply, and show a high level of confidence and knowledge.
So the most common mistake I see people making is they might be a really talented iOS engineer, but their software general skills might be lacking. So make sure you're preparing for those general algorithms and data structure types of questions, because they will come up when you are interviewing, regardless of the pipeline that you're interviewing for.
Sometimes in the technical challenge, you'll get stuck. And the worst thing you can do is say nothing, because I can't read your mind and I don't know what you're doing. So you really want to explain what you're thinking for, how you're stuck, why you're stuck, because even if you don't get the answer right, if you can show that you have a good understanding of the problem, that can be enough to get you to the next round.
What really impresses me about candidates is when they come prepared for the interview. And you should obviously come prepared to the interview, but when they've done their research on the company, they know the values and they know how they apply to their values and what they can bring to Meta.
What really impresses me about a candidate during an interview is when they can take feedback from me. So even if they are on the right track already, sometimes if I can see that and push them a little bit more, that's a really good sign that they can hear my feedback and work with me to solve the whatever problem is at hand. It gives a good indication that it's someone that I would want to work with in real life.
Interviewing is really about showing who you are. It's really about, showing what you know, how you grow, how you learn. And there's not a single trick to it. You really have to kind of figure out a little bit about yourself and how you display these things and make it work for you. A candidate that's very enthusiastic, excited to be there, and has a really positive demeanor. That just really shows that that's someone I want to work with, someone that's going to be passionate about the work they do. And that is what I think leads to success, is that passion.
On the other side of the interviews, even though it can be a really long process, it is really rewarding to start to actually work on the products that people use every day. At a place like Meta where things scale so large, it's really cool to see one of the features you build being used by millions of users.
And you get to work with the smartest people I've ever met in my life. And that will help you grow as an engineer. And you would be shocked at how much you will learn and grow within a short time here.
Thanks for watching. Hope that you were able to learn some good tips at interviewing at Meta, and good luck on the rest of your journey.
In this video, you will learn about binary numbers, what they are, and how computers use them to represent human language. You will learn how positional encoding can turn a limited set of numbers into an infinity-sized representation of values. Lastly, you will learn how computing the power of a number can be applied to determine how many states this simple representation can hold. Traditionally, you count using 10 different digits, 0 to 9. This stems from the early development of maths. It was a natural progression resulting from humans having 10 fingers and 10 toes. Counting with the use of 10 digits is referred to as base 10. Base 10 means you have 10 different numbers to use before you have to add another digit and reuse numbers. Each time you exhaust the range, you reset the number on the left and add a 0 to the right. This new digit has to be 10 times greater than the digit to its right. The number on the right is the reset, and the count begins again. The use of the position of the number to denote a progressive increase in value is called positional notation. When you consider it, it is an early implementation of an algorithm to allow for the recording of an infinite number of values. Simple in implementation, but very powerful in effect. Binary works using the same positional notation approach. It is another common counting approach that employs base 2. This means that all of the values are represented with either a 1 or a 0. Computers store information as bytes. Each byte is made up of 8 bits that can either be 1 or 0. As you have now learned, in decimal, the count would come to 9, and you would add another digit and reset. In binary, the same thing happens, but in this case, only 2 digits are used. To progress the count, you move the number left. Move the 1 to the left until all configurations of 1s and 0s have been used. at which point you add another 0 to the end. At this stage, all the numbers are reset to 0 apart from a single 1 at the beginning. Let's explore it step by step. Start to count with a 0, then add 1. To get to 3, start back at 0 again, but add a 1 on the left. As soon as all the 1s are full, start back at 0 again and add 1 to the number on the left. But that number is already at 1. So it also goes back to 0, and 1 is added to the next position on the left. Binary has many uses in computing. It is a very convenient way of translating electricity into computer code. If a signal is present, a 1 is displayed, otherwise a 0 is used. The binary counting system allows these base 2 signals to amount to a significant amount of information, transportation and storage. This is the same way as Boolean numbers are stored. A Boolean value is either 1 for true and 0 for false. Some powerful applications can be built using this simple information representation. The ASCII, American Standard Code for Information Interchange, is a map of binary to character encoding, or a mapping from binary to text. There is a binary number reserved for each digit and character, as well as for a number of special characters, like a question mark, brackets, full stop, and even the spacebar. It was already mentioned that a byte is made up of 8 bits. Each bit can take the value of 0 or 1. So that raises the question, how many different values can be represented in each byte? Here we would use exponentiation, or counting the power of a number. An example would be 2 to the power of 3. That is 2 multiplied by 2 multiplied by 2, which equals 8. Now consider that you have a lock with 4 different digits. Each digit can be a 0 or a 1. How many potential pass numbers can you have for the lock? The answer is 2 to the power of 4, or 2 times 2 times 2 times 2 equals 16. You are working with a binary lock. Therefore, each digit can only be either 0 or 1. So you can take 4 digits and multiply them by 2 every time, and the total is 16. Each time you add a potential digit, you increase the possible permutations. So, the same lock with 5 digits would have 2 to the power of 5, or 32 different combinations. Now, coming back to our original question, how many different representations can there be in a byte? It was already mentioned that a byte is made up of 8 bits, which can be either a 0 or a 1. 8 bits would have 2 to the power of 8, or 256 different combinations. In this video, you learned about binary numbers, the language of computers. While at first glance it seemed quite limited to on or off, you learned that through the use of positional encoding, it could be used to represent a much larger number set. You learned how computers can use electricity to store and read numbers, and how exponentiation, or counting the power of a number, relates to counting unique states, and how to use it to count the number of possible combinations a number lock could have. Binary is the language of computers. Understanding how it is used to store information will give you a greater understanding when discussing data and the structures that hold it. In a previous video, bytes were introduced. Each byte consists of 8 bits. A bit is the simplest form of computing memory. In this video, you will learn about the Central Processing Unit, or the CPU, and the roles and functions of the different types of memory. Typically, a computer will be made up of a series of memory blocks, which contain both information and instructions on how this information needs to be processed. Memory capacity then refers to the number of bytes that a computer can hold. There are different types of memory that need to be considered, namely cache memory, main memory, and secondary memory. Firstly, to better understand the various layers of memory, it is important to pause and consider how a computer works. A computer functions around the Central Processing Unit, or CPU. This takes both information and some instructions on how this information is to be processed. All this information exists as bytes, or a series of ones and zeros that are determined by a small electrical current. The CPU can work faster than information can be transferred to it. Often, a CPU will be working on a number of different tasks near simultaneously. The switching between tasks can allow information to be transferred into the cache for processing and the results to be stored in the appropriate location. The proximity of a memory cell to the CPU can reduce the time it takes to load the information. Therefore, quicker and more expensive memory is always found near the CPU. So, an important concept to consider when discussing memory is the transfer rate. This relates to the speed at which a computer can transfer memory into the cache for processing. Now that you better understand the processing part, let's explore the different types of memory and start with cache memory. Cache memory is the most expensive form of memory and lives close to your CPU chip. When the CPU receives an instruction to process some information, it first checks the cache to see if the information is here. If the information is available in the cache, it is processed. If it fails to find the required information here, the information is not processed. The CPU then queries the larger, slower main memory, then loads this information into the cache for processing. Storing recently accessed information in the cache can improve the effectiveness of your system by reducing the search and transfer time of regularly used data. Much like a metro in a large metropolis, cache memory is organized in zones of importance. The most readily required information is in Zone 1. Each subsequent zone is of lesser importance and is numbered Zone 2, 3, 4, and so on. Next, you will learn about main memory. A computer's main memory consists of read access memory, RAM, and read-only memory, ROM. Main memory holds only the information that a computer is currently working on. It can be volatile or non-volatile. Volatile memory stores information actively, so if the computer loses power, it is lost. Non-volatile memory retains its information when the power is cut. ROM, as the name suggests, is read-only, meaning the information cannot be overwritten. This memory is programmed once at the factory and cannot be altered. Typically, one will find instructions and data that are critical for a computer's function here. ROM is busiest when the computer starts and information on the required application is loaded. RAM is programmable. It can retain new information and instructions. RAM holds the current data and instructions that are in current use. The amount of RAM your computer has is directly correlated to how fast it can go. This is because of the transfer rate. Large amounts of RAM mean that the system does not need to transfer information constantly. Instead, it can hold and run a number of applications at once using RAM. All the memory needed to operate these applications needs to be available from your RAM. Having too many programs open will affect the performance of your system by exhausting your RAM memory. There are a number of algorithms for reading and storing these memory addresses that fall outside the perimeters of this course. Now, let's explore secondary memory in more depth. Secondary memory relates to external memory that can be plugged in externally and used to increase the storage capacity of your system. Accessing secondary memory is slower and requires transferring all required information and instructions into RAM. Examples of secondary memory would include cloud storage, external hard drives, and memory sticks. In this video, the various components of memory have been discussed. You have learned how all memory allocation revolves around the CPU, which oversees the reading, processing, and storing of information on the computer. You have also learned how there are different types of memory that vary in speed and importance. This informs their proximity to the CPU, with quicker, more expensive memory cells found nearer the source. This information should assist you in understanding how your computer works much better. When developing applications or evaluating efficiency, it is always useful to have a metric or a lens through which you can evaluate fitness for function. Evaluation in computer science will often consider two aspects, namely time and space. In this video, you will learn how to evaluate time efficiency or gauge performance by the time taken to complete a task. You can refer to this as the time complexity of a task. An application must return information within an acceptable time frame. These days, people expect an instantaneous response when clicking on a website. There might, however, be some extra scope afforded to more complex queries depending on the user's needs and expectations. Big O notation is a metric for determining an algorithm's efficiency. Put simply, it gives an estimate of how long it takes your code to run on different sets of inputs. In this video, the amount of time an algorithm will take is considered. Some of the big O notation you will encounter include the following: O of 1, O of log n, O of log n, O of n, and so on. So how do you measure the quickest possible time that something can be computed? You make use of a constant time algorithm where it takes O of 1 time to compute. Put simply, it means that no matter what is entered into a system, it will only take one computation. A simple example to illustrate this is to consider printing the first item in an array. In this instance, no matter how many values exist in the array, the approach has a big O of 1. Things can get more complex if you need to do a search. Consider that you have an array of 10 items, and you wish to know if a certain value is in this array. You might apply a loop and check each item to see if the value exists. In this example, the complexity is said to be O of n. This is called linear time. The search is going to be equal to the length of the array passed. The larger the array, the more time is required to search it. So, if in place of 10 items you have 100 items, then the search will take 10 times as long. Let's explore an example. Each operation comes at a time price for time complexity. So, O of 1 means it costs one single computation, and O of n means it costs n computations. For example, you wouldn't say it takes 45 seconds, you would say the complexity is n. So for every n action, that is plus 1 on our final result of complexity. If n equals 100, it is 100 checks. The complexity is still O to n, only n means it is 10 times longer. This means that your application speed depends on the size of the data being processed. Print array at position n is an example of an O to 1 operation. That means print the doc at whatever n is. It doesn't matter how big n is, the cost is always 1. Let's continue to O of log n. This search is less intensive than O to n, but worse than O to 1. O of log n is a logarithmic search, so it will increase as new inputs are added. But these inputs only offer marginal increases. A good example of this in action is a binary search. Imagine you are playing a guessing game with the following prompts: too high, too low, correct, given a range of 100 to 1. You may decide to approach the problem systematically. First you guess 50 and it is too high. Then you guess 25 and it is still too high. You then decide to go 12 or 13. It is still too high. What is happening here is that you are halving the search space with each guess. So while the input to this function was 100, using a binary search approach, you should come upon the answer in under 6 or 7 guesses. This solution would be said to have a time complexity of O log n, even if n, the range of numbers entered, is made 10 times bigger. It will not take 10 times as many guesses. Let's move on to O(n squared). O(n squared is heavy on computation. This is a quadratic complexity, meaning that the work is doubled for every element in the array. A good way to visualize this is to consider that you have an array of arrays. The first loop will equal the number of elements inputted, namely n. The second loop would also look at the number of input elements n. So, the overall complexity of running this approach can be said to be n times n which is n squared. So, how will you visually represent the problem? This graph displays the algorithm for time complexity. The x-axis relates to the number of inputs and the y-axis relates to the time taken. Notice that as the number of inputs increases, it has a different impact on the gradient of the line for all cases but O of 1. In this graphical representation of how n relates to the number of computations taken, the best time to aim for is O to 1. O of log n is still very good. O to n is acceptable, and O(n) square is not great. Of course, it is not always possible to tell how long an approach is going to take. Let's return to the example of looking for something in a loop. While you could say that to search a loop takes O to n time, this might not always be the case. Consider that the item being searched for is the first in array. Then the return will be in O1 time. Pretty good. Equally, the element might be missing, so every item must be searched. O(n) time. The middle case would be that it is found around the middle of the loop O of n over 2. When evaluating an approach, there are 3 definitions used: best case, worst case, and average case. To conclude, in this video, the notion of time in relation to complexity was introduced. You have been given something to consider when implementing a solution to a problem. A good question to ask yourself before you start is how many computations does my solution employ, and is there a better way? Now that you use a metric to evaluate your solution to a given problem, you can start thinking of its efficiency in relation to time complexity. This is not the only way to consider a solution, and in the next video, the focus will be placed on space complexity. In a previous video, you learned that the time spent on an algorithm depends on the problem's complexity and data structure. Another consideration when evaluating suitability is space. How much memory will a given solution take? This is often a trade-off with time. The selection of this data structure will pivot on what your priority is: speed or compactness. Some algorithms, like the hash tables you learn about later in this course, provide very fast lookups in O of 1 time. However, to work efficiently, they must have a lookup for every element stored. This results in a space complexity of O of n. The big O notation for space complexity is the same as for time: O of 1, O of log n, O of log n, and so on. In all these notations, n refers to the size of the input. This is often measured in bytes. Different languages have different memory costs associated with them. In Java, for instance, an integer requires 4 bytes of memory. A blank array will consume 12 bytes for the header object and an additional 4 bytes for padding. Thus, if n refers to an array of integers size 4, then the total memory requirement is 32 bytes of memory. When discussing space complexity, you have to consider what the increase in input size has on the overall usage. The space complexity of a problem can be broken into 2 sections, namely auxiliary and input space. Auxiliary space is the space required to hold all data required for the solution. It refers to the temporary space needed to compute a given solution. Input space refers to the space required to add data to the function, algorithm, application, or system that you are evaluating. Consider when you are learning long division. You may have been taught using a methodical approach that involved breaking each computation into simpler steps. To achieve this, you would create a table to hold the temporary calculations. Some complex problems require the same additional allocation of space to hold their workings temporarily while the solution is being calculated. Big O space complexity allows for the auxiliary space required for coming upon a given solution. So it can be said that space complexity equals input space plus auxiliary space, that is, the space required to compute a result. Remember that you calculated the space complexity where an integer requires 4 bytes of memory. You added the 12 bytes of the header object and the 4 bytes for the padding. The total was 32 bytes. However, consider that the size of the array is doubled to 8 integers, space complexity is now computed the same way, and the total will be 48. The space complexity is higher. Adding additional input did not increase the size of the auxiliary space, so when computing the big O, you can discount the auxiliary size if it is not impacted by increasing the input size. Knowing that each decision made in computing a solution requires memory, it is worth noting the aspects that can increase memory usage. Some common memory actions could be assigning variables. These can be temporary variables when computing a solution, as with the long division analogy before. Creating a new data structure. Some solutions require that a new array be created to contain the values or a duplicate array that retains index locations. Creating a new data structure instance has an O to N auxiliary memory cost. Function calling and allocation also have additional memory overheads. It is worth bearing in mind how space is being used when designing an application. Creating a new variable to contain a value in place of overwriting an existing one will impact your space efficiency. This impact is greatly increased if you needlessly copy arrays or complex data structures with high data overhead. Additionally, writing functions that use complex structures when simpler, less intensive structures will suffice can incur a penalty, particularly if these structures need to be duplicated in computing a solution. In conclusion, in this video, the concept of Big O was expanded from one focused on time consideration to one that includes space complexity. It was highlighted how there is often a trade-off between speed and memory efficiency. Additionally, there were some observations on the efficient use of space when designing a solution that is worth bearing in mind. Well done! You've reached the end of the introduction to the coding interview module. Let's take a few moments to review what you learned during this module. You began the module with a course introduction, where you were informed of the content of the coding interview prep course. You then moved on to the coding interview lesson. Your first lesson focused on the technical coding interview, primarily to determine that you are technically capable of the role's responsibilities. You learned about the steps that you must keep in mind when this interview is conducted. You were taught that using the appropriate tools is always important, and that you have to keep time constraints in mind. You then learned about code optimization and should be able to write or rewrite code so a program uses the least possible memory or disk space and minimizes CPU time or network bandwidth. To summarize, you learned about some approaches that can be used regardless of the challenge presented. Even if you are not familiar with the problem or don't achieve a result in the time allotted, always strive to demonstrate your reasoning and best practice approaches. Prepare for technical interviews by practicing solutions to online problems and, when possible, employ a similar methodology to each challenge. This will assist you in the future, so that regardless of the challenge faced, you are working from a comfortable framework. You then focused on communication and the importance of first impressions. You were introduced to verbal and non-verbal communication and the importance of both. You learned about the STAR method and how to use it to your benefit when communicating with interviewers. You should now be able to look at the context of a situation and the challenges faced, the responsibilities around the tasks involved, the actions required to address the challenges, and lastly, the outcomes that need to be achieved. To summarize, you should now be able to clearly convey a concept during an interview. Communicate why you are suitable for the role in a verbal and non-verbal manner. Finally, use the STAR method for engaging with technical questions that will arise over the course of an interview. You then moved on to the next lesson, where you were introduced to computer science. You started with binary, where you learned about the difference between base 10 and base 2. You then discovered positional notation. This is the use of the position of the number to denote a progressive increase in value. You were then introduced to how a computer stores data as bytes, and that each byte is made up of 8 bits that can either be 1 or 0. You were also given some examples. You examined the concept of exponentiation, or counting the power of a number. This was followed with examples where a lock with a different number of digits was used to explain the concept. You should now be able to apply this knowledge and understand that binary is the language of computers. Next, you explored memory. The first concept you learned about was memory capacity, which refers to the number of bytes that a computer can hold. You also learned about the different types of memory that need to be considered, namely cache memory, main memory, and secondary memory. You should know by now that to better understand the various layers of memory, it is important to pause and consider how a computer works. You learned about the transfer rate, or the speed at which a computer can transfer memory into the cache for processing. You then explored cache and secondary memory and should be able to describe the differences. You were then introduced to the concept that a computer's main memory consists of read-access memory, RAM, and read-only memory, ROM. You should be able to describe the role of the main memory and distinguish between RAM and ROM. You should now be better positioned to work with memory. You then moved on to explore time complexity, where you learned how to evaluate time efficiency or gauge performance by the time taken to complete a task. You discovered Big O notation, which is a metric for determining an algorithm's efficiency. Thus, it gives an estimate of how long it takes your code to run on different sets of inputs, or it considers the amounts of time an algorithm will take. You were given some examples and should have a solid idea of how to measure time complexity. You then learned about space complexity. It is not just the speed of an algorithm that is important, but also how much memory will a given solution take. To understand space complexity, you were introduced to the concept of auxiliary space, which is the space required to hold all data required for the solution, also referred to the temporary space needed to compute a given solution. The other concept was input space, which referred to the space required to add data to the function, algorithm, application, or system that you are evaluating. To summarize, space complexity equals input space plus auxiliary space. That is the space required to compute a result. You have done some quizzes on all the topics mentioned. That's a great start to your learning journey in this course, and all this content should empower you to have excellent coding interviews in the future. Having a knowledge of data structures is useful for any coding interview you may encounter, from basic data structures like strings, booleans, or arrays, to more advanced data structures like collections, graphs, and heaps. Understanding the data you are working with and the most appropriate structure to use can be very beneficial. In this video, you will be introduced to data structures and the two main types, mutable and immutable. You will also learn what to look for when considering a given data structure in your own applications. A data structure models an object so that it can be stored and organized easily in computer memory. It can be a simple immutable structure that does not change after creation, or it can be a mutable structure that facilitates operations to be performed on the contents. Operations might include updates and queries to be performed on the contents of the structure. On the surface, it may seem that a mutable structure should always be used. However, mutable structures require time and effort to model, and some objects are very complex and not easily modeled. Other concerns, such as space, may be a factor. Understanding the underlying mechanics of data structures can be a great advantage because decisions to use a particular data structure can have far-reaching implications on a project's progress. While the implementation and capabilities of a data structure can range between various programming languages, the overarching architecture generally follows similar patterns. Here is a universal classification of data structures that categorizes the different types of structure into two main branches, linear and nonlinear. This relates to how the elements are stored within the data structure. A linear structure relates to how the information is stored. The elements of the structure are arranged one after another or sequentially, reflecting the order that they were inputted. Examples of linear structures are arrays, queues, stacks, and lists, and it infers that each element is attached to the element that precedes it. Some languages will demand that only similar types of data are stored on the same structure. Therefore, you will have integer lists or string arrays. Other languages will allow for mixed arrays. This would mean that storing an integer and string in the same array is not prohibited. This easy approach can come at the cost of error handling down the line. For example, imagine you have created an array and want to find the sum of your values, only to discover that the total is 3 pineapples and 1 apple. Once a simple structure has been created, such as a list or array, it will contain an index. An index is a way of accessing elements that may not necessarily be the first or last instances. Generally, use of an index is done through appending square brackets and the location of the item as an integer. So array 4 would indicate that the required element is the 4th item of the array. However, programming languages are predominantly zero-based, which means that the count will start at 0. Therefore, array 4 would actually be the 5th item in the array. Accessing an array through the use of an index can throw an error if index location 8 is requested, but there are only 7 elements in the array. A common feature of these structures is that most languages have a built-in length method that will inform as to how big an array is. An example of this would be calling array.length in Java or placing it inside a len function in Python. While the mechanism of how to retrieve the length varies, it is possible in most programming languages. Arrays and lists are typically first-class objects. This means that all functionality that is available to other variables is available to them. This definition generally indicates that a data structure can be passed as a parameter to a function, returned as a result, or assigned to a variable. When passing a list or array to a function, care should be taken that the structure is actually passed and not just a reference to the structure. This can be a memory-saving device used to prevent copying the information. However, such instances can cause an error if a change in the structure inadvertently affects the array in the calling environment. In this example, a string has been added to a list of integers, and because the new list points to the initial list is also changed. Therefore, it is better to make a copy of the array and pass the copy to the function. Another memory-related issue to be mindful of is memory leak. Memory, as previously mentioned, can be arbitrarily allocated. If this memory is not used, then it is good practice to deallocate the memory location. As a result of careless programming or other issues, it is possible that a program makes repeated calls that result in excessive memory being allocated and not then deallocated. Over a prolonged time, or through repeated calls, this can cause the application to run out of memory and crash. Most compilers have sophisticated algorithms for detecting and deallocating memory to avoid this issue. In contrast to linear structures, there are non-linear instances such as trees or graphs. These structures do not allow you to traverse the data in one smooth motion. Instead, you can investigate certain paths. The makeup of these structures means that they can include natural sorting, which makes querying for specific data very quick. You will learn about different types of sorting later in the course. In this video, you had a general overview of data structures, including their two main types, linear and non-linear. You have also learned about some of the considerations that should be made when deciding the type of data structure you should use. As you progress through this module, you will explore these structures further and learn about some of the individual strengths and weaknesses. Have you ever needed to store some data but were unsure about what sort of data structure to use? It's a common coding problem. In this video, you will discover two important data structures that could be used, lists and sets. Both are very useful data structures with their own strengths and weaknesses. Lists and sets are common in many programming languages. Let's get started by exploring lists. In most programming languages, lists are represented as objects. This means that in addition to storing data, they also have their own inbuilt methods. Here, an inbuilt sort method is used to arrange the numbers in a list. As with arrays, it is common to find lists that are declared as either a string, an integer, or float. In some programming languages, you can have lists with mixed element types. A list is an abstract concept that refers to a container of elements. A stable implementation of a list is done using either an array or a linked list. An array-based list is an ordered collection built using arrays as the underlying data structure. As such, they are subject to the same strengths and limitations associated with arrays. Array-based implementations relate to the initial sizing, rather than simply pointing to another node, as with a linked list. Some languages require that you initially determine how big a structure will be, while others allow for dynamically growing structures. It should be noted that this freedom is somewhat surface level. For many dynamic structures, there is an initial size automatically configured at instantiation. When this limit is reached, the array will copy itself into a new structure with a larger size allocation. Therefore, the decision not to arbitrarily allocate space at the onset may come at a cost at runtime, when such data structures may have to expand multiple times during the execution of other operations. Consider the computation costs of a list dynamically growing while performing operations in a loop. In this case, it would help to set the initial list size to be larger rather than dynamically growing, which can be costly due to having to create and copy over values into increasingly bigger lists. A linked list works differently. A linked list contains two pieces of information: the data and a pointer to the next list item. A linked list begins with an empty list and can grow dynamically by introducing new cells to the list. To grow a linked list, you simply have to add a new node and point the list at its location. This makes them very fast for storing large amounts of data. The flexibility of linked lists is achieved by including some additional storage requirements. Notably, in each node, there must be some reference to the nodes around it. There is also a head and a tail. The head is a unique node that indicates that it is the start of the list, and the tail indicates where the list ends. This approach to growing the size of the data structure is very powerful and can lead to very large but manageable data sets. So, what do sets entail? Set is very similar to a list. However, a set will store its elements in an unordered way. Though there are some possible implementations of ordered sets, sets have some unusual tendencies. A set will only hold unique elements. So, adding an element that already exists to a set will make no difference to the data stored there. The unordered process in which sets store their information means that printing out a set will not necessarily reflect the order in which the element was added to the set. Once a value has been added to a set, it cannot change. Instead, you would have to delete it and add a new value instead. Sets are exceptionally fast to search. This is because of its internal mechanisms. A set uses hash tables to determine where to store the elements of a set. Therefore, each number that is passed to a set will have a hashing function applied to it. A hashing function can be defined as an algorithm that takes in some data and maps it to a fixed size value. The value is theoretically unique, and every time the function is applied to the data, the same value is returned. This means that searching a set can be done in O1 time. This is due to the mechanism that is used to save values in a set. You will learn about hashing functions in more detail later in the course. A ON approach would be to iterate over the entire data structure to check for the presence or absence of a value. Sets instead apply the mapping function to the input data and check the resulting output to see if a value exists there. If it does, then the value is returned. If it doesn't exist in the set, then the data was not stored in the set and hence will return a false. While sets can perform an exceptionally quick search, performance degrades when dealing with very large datasets. This is due to the nature of the hashing function. The more values retained, the more risk there is of clashing. Clashing is when the hashing functions return the same unique mapping for two different values. The larger the dataset used, the more likely clashing is prone to happen. So, there we are. In this video, you have explored two very important and useful data structures, lists and sets, and learned about the strengths and weaknesses inherent in both. You should now have a greater sense of when to use each, depending on the storage needs of the solution. So, what is the difference between a stack and a queue? And what does it mean to use one of these data structures over another? Well, in this video, you will learn about stacks and queues, the difference between the two, and why you might choose to use one over another depending on the requirements of the solution. Stacks and queues are abstract data structures that have many different implementations depending on the programming language. The unique principles that are common to both are how elements are added and removed. While lists and arrays allow for random access, stacks and queues employ sequential access. This limited approach to holding data can be very useful when you want to control how the data is accessed. Let's start by exploring stacks in a little more detail. Stacks are linear data structures with strict ways of adding and removing items. As the name suggests, a stack is a collection of elements that are stacked on top of one another. What this means is that it is impossible to pull items from the middle. Instead, a stack works with a strict first in, last out or FILO basis. This can also be phrased as last in, first out or LIFO. It's a simple yet powerful concept that informs you that items can only be retrieved from the top of the stack, which determines the order in which you can retrieve them. An example of this principle in action is hitting Ctrl-Z in a URL, Word document, or any coding environment. Ctrl-Z undoes the very last action. Hitting it again will undo the previous action, and so forth. To extend the analogy, Ctrl-Y will redo the action or push it by adding it back to the stack. Stacks tend to have very few methods: push, pop, is empty, is full, and peek. The functions of these methods correlate with their names. Push will add an item to the stack, and pop will remove it. Is empty checks that the stack contains nothing, and is full is a Boolean that will return true if there is no more room in the stack. You might have heard of the popular computer question and answer platform named after this very issue, namely Stack Overflow. So, popping an item takes it from the top of the stack, and calling pop again will return the next item in the stack. Pop can be called until there is nothing left in the stack. Push then will place an item on the top of the stack. It is worth noting that by calling pop or push, you are changing the stack. You have now learned about all the methods except peek. So what does that entail? To have a look at the contents, one would call peek, which allows you to view the top item without removing it from the stack. So calling it will not change the state of the structure, unlike pop or push, which permanently alters the stack. Some implementations will include a search feature for looking through the stack, though this won't always be the case. Now, let's explore an example. Imagine that an application generated a deck of cards. You could create a stack of 52 playing cards, and each time a card is dealt, it is removed from the top of the stack, just as in a real deck. Using a stack in this way would simplify the code required for maintaining the state of the deck. Now, let's explore queues. A queue is very similar to a stack in that it tends to have the same methods. It can create, insert, remove, and check the state of the queue. Unlike a stack, a queue works on a first in, first out, or FIFO basis. Again, the name is a good indicator of how the structure works. As an example, Imagine you have a line of people waiting to get a burger at a fast food restaurant. The first person to enter the queue gets served, and each subsequent customer stands behind the one in front and is processed in turn. As with the stack, a queue will pop the selected item from the structure, though different languages have different implementations for this. The element that is removed from the queue is the one at the bottom. In other words, the least recently added item, or the first to join the queue. Using a real-world IT example, a server balancing system usually uses a queue to retrieve tasks. The structure would hold each task in order of insertion, and when a server becomes available to process the task, the first task entered into the queue would be removed and passed to that server. In this video, you have learned about stacks and queues and the differences between them. These are very useful tools to have in your programming toolkit, and knowing them will be an advantage when dealing with problems requiring a structured way of accessing and inserting data. In previous videos, you have learned about data structures like lists, stacks, and queues. Another data structure you have not yet learned about is trees. So what exactly is a tree in the data structure context? Trees are a powerful data structure that gives you great flexibility in adding and searching values. The inherent structure of the tree can allow you to understand a lot about the relations between the data stored, which can save a lot of time and code when extracting information from the data. In this video, you will explore the general structure and inherent features that trees provide. You will also learn about some of the different types of trees and the advantages of using a tree data structure. So, let's get started. A tree is a very complex data structure that resembles a tree in design. It consists of nodes that are linked with one another. A node can be a parent or child node. A parent node may have a connected set of children nodes. Nodes with no children are referred to as leaf nodes. As with a tree, nodes can branch off in different directions, allowing for powerful search and storage features. Generally, we can look at a tree as a graph-like structure that has nodes that contain data and edges that model how each node relates to one another. When discussing trees, it is important to know some of the terminologies. The top-level node is referred to as the root. Each subsequent node down that is connected to this node is referred to as a child node. Nodes that have the same parent are referred to as siblings and are considered to be on the same level. One might picture a chapter of a book where the subsections correlate to connected nodes. The theme of these nodes will be of a very similar nature. Other branches would be other chapters that still fall under the general theme but on different topics. A path refers to a series of connected nodes. You might assume a connection between two nodes by determining the shortest path. This is to say, the quickest way that you can move from one node to another. Intuitively, nodes with shorter paths will have more in common. The depth of a node refers to how many edges there are from the parent to the root or the longest path. The height of the tree refers to the number of edges between the topmost node to the deepest node within the structure. And finally, the size of a tree refers to the total number of nodes within the tree. There are many variants and implementations of trees, such as binary trees, B trees, and B+ trees. There are also quad trees and AVL trees, to name a few. While all of them will contain the general theme outlined, their use and implementation differ slightly, depending on the type of tree being applied. There are many advantages to storing your data in a tree-like structure. The connections between the nodes indicate a relationship that is inherent in your data. They can store information in a hierarchical fashion, where the topmost content is stored in the upper nodes, and more in-depth information can be retrieved by traversing a given branch to a tree. They are also very efficient for inserting and deleting data due to the flexible way in which they are implemented. The non-linear nature of a tree means that there are many ways of traversing the data. In binary trees, this feature can be very useful when storing data. A left node has a lesser value, while the right node indicates that there is a greater value. Let's demonstrate that with some data values. The first data contains the value of 23. Then a 4 is added. Because it is less than 23, it goes to the left. Following is a 1, also less than 23, but also less than 4. That also goes to the left. The next number to follow is 30. Because it is now larger than 23, it goes to the right. A 24 is added, and because it is less than the 30, it goes to the left. But the 56 that was added goes to the right of the 30 again. One can traverse a tree in depth first or breadth first method. A depth first method involves visiting every node from top to bottom sequentially. A breadth first method involves searching each node on the same level before ascending to the next level and repeating until the root node has been reached. More benefits of trees are that they can be used to model file systems on your laptop, class hierarchies like those found in Java, or modeling hierarchies in organizations. In this video, you explored the general structure and inherent features that trees provide. You also learned about some of the different types of trees and the advantages of implementing a tree data structure. At this point of the course, you have been introduced to several different data structures, and you've discovered that there's not a perfect way of storing information. Instead, there is a wide variety of approaches, each of which is an appropriate solution depending on the problem. In this video, you'll learn about what a hash table is, its structure and inherent features, and how it works. You will also explore some of the advantages of using hash tables and discover what is meant by collisions in hashing. A hash table contains several slots or buckets to hold key value pairs. It requires a hashing function to determine the correct bucket to place the data into. A hashing function is any algorithm or formula that is applied to a key to generate a unique number. Each data item to be stored must have a key and a value. The key is taken, and the hashing function is applied to it, such that it is reduced to a fixed size value. There are a variety of hashing functions one could apply. You may be familiar with them in relation to compression. When you want to send information over the internet, you might first compress the size of it to a manageable number of bytes, send it over the internet, and then decompress it on the other side. This is an example of how hashing works. It reduces the key to a small, manageable size, which then acts as the index indicator. What information is used to generate the index is dependent on the application. It might be the data itself, if it is small enough, or it might be the last 4 digits of an employee ID number, or it might be a key in a dictionary. Most programming languages have built-in hashing functions like MD5, SHA, or CRC32. So, implementing a hashing function is a straightforward job. When discussing Big O notation, the idea that speed and space are often at odds with one another was introduced. This means that you can reduce the time taken to retrieve an item, but in doing so, you add overhead to your application. Hash tables prioritize speed over space and can retrieve an item in O of 1 time. Recall the discussion on arrays. When you want to check if a value exists, a search must be executed that checks each element of the list and makes a comparison with the target value. Worst case scenario, this will take O of n time, or in other words, if the element was at the end of the array, it must make n checks. Hash tables offer an alternative approach to storing and searching data. This is done through use of an index. To achieve this, you must implement an algorithm that takes in a key and maps it to a value which is stored in an index. Then, when a new key is presented, the algorithm need only run the same function and determine where in the index the value lies. Much like an index in a book, this will drastically speed up the time it takes to identify the location of some data. You are likely to find hash tables used in caches, dictionaries, database indexes, and sets. Consider a scenario where you have an array of 10 keys which are numbers 0 to 9. You elect to employ a hashing function to decide where in memory to store these numbers. You opt for a simplistic approach of applying the modulus of 20 to the numbers. So, for each key from 0 to 9, you apply your hashing function. Start with 0 mod 20 equals 0, 1 mod 20 equals 1, 2 mod 20 equals 2, 3 mod 20 equals 3, and so forth. In this way, you would generate 9 unique values which are used to represent in memory where the data associated with those keys is placed. This example is simplistic but illustrates the mechanism behind creating hash maps. The issue arises when the number of keys to be stored grows beyond 20. Remember, 1 mod 20 equals 1, but 20 mod 21 also equals 1. Let's move on to collisions in hash tables. What are collisions in hash tables? A hashing function will apply a clever algorithm that will reduce the size of the key to a manageable size. Some approaches are more intricate than others. So, what happens if the result of 2 hashings is the same? To expand on this idea, it is worth pondering on von Mises' birthday paradox. Due to probability, sometimes an event is more likely to occur than we believe it to. In this case, if you survey a random group of just 23 people, there is actually about a 50-50 chance that 2 of them will have the same birthday. This is known as the birthday paradox. Say there are 24 employees in a company and a clever hashing function has been applied that takes the date and month of their birthday and uses this as an index. With only 24 employees and a hash table of 365 index slots to hold a reference to them, you may think that the probability of any 2 employees sharing a birthday is unlikely. In fact, it has been shown that it is over 50% likely to occur. Next time you're at a party, be sure to check if any 2 attendees have the same birthday to check for yourself. What this illustrates is that there will be duplicate hashes generated when the hashing function is applied to the key and that allowances must be made for it. There are a few solutions to the issue. One solution is to grow the table every time a collision occurs, then increase the complexity of the hashing approach, redistributing the values to new addresses. In this way, a table will grow organically to match the size of the data required. Another is to create a linked list at the point of collision and simply store the additional values. So, in the event of a collision, instead of storing a value, you would instead store a linked list of values. In this video, you discovered what hash tables are, their structure and features, and how they work. You have also learned that hashing is a very clever approach to generate O of 1 time searches using a hashing function and an index. You explored collisions and how they can be used to inform the size of the table, and you even learned that if you are at a party with more than 24 guests, it is more likely than not that at least 2 will share the same birthday. A heap may not sound like a particularly promising name for a data structure. However, it is a very important organizational tool and combines some features and benefits of other data structures. In this video, you will learn about the structure and features of heaps. You will also discover how heaps can be used to organize elements from least to most important, and how, by limiting the functionality of heaps, productivity can be increased. So, let's get started with heaps. A heap is a specialized data structure that is modeled like a tree, but behaves in a similar way to a queue, though with a notable difference of assigning priority to some elements. Each element in a heap has a key value, and the priority can either be the smallest or the largest key value. Heaps that place priority on the lowest valued key are called min heaps, and ones that place the priority on the maximum value are called max heaps. Heaps were first introduced as a means of storing and searching data efficiently, but since then, it has been recognized that there are a number of very useful operations that a heap can be applied to. A heap has a few select core operations that it can perform. Insert, find_min, and delete_min for a min heap, and insert, find_max, and delete_max for a max heap. For the rest of this video, the discussion will revolve around min heaps, but you can reverse everything said and it will apply to a max heap. The only difference between the two is where the priority is placed. As with many of the data structures discussed on this course, these methods are the fundamental elements that constitutes a heap. Different implementations in different languages could have additional methods added. An instance of which may be decrease key. This is where the value of a key is changed, the motivation for which would lie with the priority of the key in real-world instance changes. When discussing trees, it was mentioned that binary trees sort values in order of size. If the value is less than the node, go down the left path. If the value is greater than the node, go down the right path. Because of this underlying architecture, heaps are often built using binary trees, though another approach would be to make an array act in a way that mimics the behavior of a binary tree. The minimum value is placed on the root node, and each subsequent value is placed on the hierarchy where their value dictates. This means that to retrieve the minimum value from a heap is O of 1, because it will be stored always at the root. Unlike a stack, retrieving a value does not cause it to be moved from the tree. Instead, a delete min method exists that can be called if the intent is to remove items as they are processed. Typically, a heap would not support operations such as deleting items other than the priority element. The reason being that a heap is built for specialized purpose that involves identifying the most important item and returning this in the shortest time possible, then queuing up the next item of importance. Deleting items in the tree would require restructuring the tree, and this would lead to a degradation in performance. If you are looking for a data structure that can act in this way, then you might consider structures other than a heap. Insertion into a min heap is done through propagation. Each item is inserted at the root. A comparison is then made with the left value. If this is less than the newly inserted item, they are swapped. This continues until the newly inserted item has no greater value above it, and the value below is lower. Insertion in a heap can be achieved in O of log n time. Having examined the underlying mechanisms that power a heap, you may now have some idea of how this data structure can be applied. Considering that its inherent structure prioritizes a particular value from a group of elements, the natural application would be for scheduling. This could apply to CPUs, routers, or packet handling. Additionally, one could imagine that such a structure would be useful in prioritizing certain tasks like interview scheduling, where the key used to store the candidate may relate to what stage of the interview process they lie at, or what priority the role has within the organization. Having a process that automatically applies schedules based on importance can be a huge time-saving device. In this video, you have gained a greater understanding of heaps and how they can be used to organize elements from least to most important. You have been shown that by limiting functionality, productivity can be increased. As with the selection of any data structure, it is important to find the right tool for the right job. When considering a given problem in computer science, it is always important to consider what executions might be required to solve your problem, and through this reflection, choose an appropriate data structure to hold your data. Consider that you might work for a large internet company that wants to store a directory of locations and their connectedness to one another. In this illustration are cities plotted in relation to one another. Notice how every possible detail need not be recorded. Say, for instance, you want to know how far Chicago is from Boston. You can easily deduce this from the way in which the data is organized. The same approach could be used to model internet destinations, relationships between words, or people on a social network. This approach to saving information is a graph-based approach. In the coming video, some terminology and advantages to this approach will be outlined. This structure illustration is a graph that is made up of nodes to denote destinations, and edges that show how each node relates to another. The presence of values between the nodes means that this is a weighted graph. There are no arrows present, which means that this is an undirected graph. In contrast to a directed graph, an undirected graph has no order of precedence. One way to think about directed and undirected graphs is like two-way and one-way streets. Sometimes it helps when ordering data to highlight some progression, when in other instances, the edges are there just to show association. A path, then, is a sequence of two or more nodes that are connected by an edge. A connection in a directed graph is considered weakly connected if the edge is only one way. However, if there are two connections going either way between two nodes, then it is said to be strongly connected. At this point, you may be considering that a graph resembles a tree. In some ways, you can say a tree is a simple graph. Notably, a tree has a starting point and models a hierarchy with parents and children. A graph is a far more complex structure that has no beginning or end. Two nodes bordering one another are called neighbours, and nodes that are connected through a neighbour are said to be adjacent. Graphs like trees can be traversed breadth first and depth first. Recall a breadth first search involves visiting every node on the same level, then going lower, and a depth first search involves drilling into the end of every branch before moving on to the next one. A breadth first approach involves choosing a given starting location and iterating over all the neighbouring nodes. Each neighbour will have a connection of connected nodes, which can be added to another data structure already mentioned, the queue. In this way, you can systematically visit every node. To achieve a depth-first search, you can employ a stack. Recall, a stack processes elements differently than a queue. While the queue prioritizes first in, first out, a stack focuses on last in, last out. So, by placing all of the neighbour nodes systematically on a stack, you would ensure a depth-first traversal. Graphs are a much-studied data structure and are the basis of many algorithms that have been developed to establish importance between nodes. Regardless of the element stored in the node, one notable one is shortest path. What is the quickest way to get from node A to node E? The edge weights would inform as to the cost of choosing each path. This approach is used when routing internet packages on the internet, or when calculating a journey on Google Maps. Another common graph-based challenge is the travelling salesman. A salesman has a select few nodes to visit. What is the best route to plot that hits all the nodes in the shortest time? This would be used in package routing. Given X destinations and Y vehicles, plot out the most efficient route so that all packages get delivered with the least spending of resources. In this video, you learned how graphs give you the opportunity to model data in a flexible way that facilitates inferring information on the data by how it is stored. This versatile approach only retains the minimum of information. The distance from Chicago to Boston is not stored anywhere, but can be deduced. It's easy to query different questions without changing the makeup of the data. Calculating the best time when walking can easily be substituted in place of driving with minimal fuss. There has been a whole field of statistics devoted to inferring information from node placements, which can be levered to make inference on any data stored there. Well done! You've reached the end of the Introduction to Data Structures module. Let's take a few moments to review what you learned during this module. You started the module with a lesson on basic data structures. This ranged from basic data structures like strings, booleans, or arrays to more advanced data structures like collections, graphs, and heaps. Understanding the data you are working with and the most appropriate structure to use can be very beneficial. You learned about a simple, immutable structure that does not change after creation, and mutable structure that facilitates operations to be performed on the contents. You then took a deep dive into all the types of data structures. To refresh your memory, here is a universal classification of data structures that categorizes the different types of structure into two main branches, linear and nonlinear. Examples of linear structures are arrays, queues, stacks, and lists, and it infers that each element is attached to the element that precedes it. You learned about the structures in detail and should now be able to describe each of them. You then moved on to focus on nonlinear data structures. In contrast to linear structures, there are nonlinear instances such as trees or graphs. These structures do not allow you to traverse the data in one smooth motion. Instead, you can investigate certain paths. You then moved on to the next lesson, where you were introduced to lists and sets. You learned that, as with arrays, it is common to find lists that are declared as either a string, an integer, or float. In some programming languages, you can have lists with mixed element types. You also learned that some languages require that you initially determine how big a structure will be, while others allow for dynamically growing structures. That was followed by a section on linked lists and how they work. Remember that a linked list contains two pieces of information, namely the data and a pointer to the next list item. You then learned about sets and how they work. A set is very similar to a list. However, a set will store its elements in an unordered way. Following sets, you were introduced to the hash functions and their role in searching in sets. Sets are exceptionally fast to search. You then moved on to the next video on stacks and queues in the same lesson. To refresh your memory, stacks and queues are abstract data structures that have many different implementations depending on the programming language. The unique principles that are common to both are how elements are added and removed. You learned that stacks and queues employ sequential access and use the empty stack, push, and pop methods to move and/or add and remove items. You also learned about the FILO first in, last out, and FIFO first in, first out principles. When you visited queues, you learned that a queue is very similar to a stack in that it tends to have the same methods. It can create, insert, remove, and check the state of the queue. Unlike a stack, a queue works on a first in, first out, or FIFO basis. Again, the name is a good indicator of how the structure works. The last video in this lesson focused on trees. Trees are a powerful data structure that gives you great flexibility in adding and searching values. The inherent structure of a tree can allow you to understand a lot about the relations between the data stored, which can save a lot of time and code when extracting information from the data. You learned about tree structures and how data moves in a tree. In the next lesson, you were introduced to advanced data structures. First, you learned about what a hash table is, its structure and inherent features, and how it works. You also explored some of the advantages of using hash tables and discovered what is meant by collisions in hashing. Let's quickly revisit what this entailed. You were introduced to the hash function and learned that the key is taken and the hashing function is applied to it in such a nature that is reduced to a fixed size value. You learned about compression with an example from our field of experience. When you want to send information over the internet, you might first compress the size of it to a manageable number of bytes, send it over the internet, and then decompress it on the other side. This was followed by an explanation of how hash tables offer an alternative approach to storing and searching data through use of an index. To achieve this, you must implement an algorithm that takes in a key and maps it to a value which is stored in an index. The next video in this lesson focused on the structure and features of heaps. You also discovered how heaps can be used to organise elements from least to most important, and how, by limiting the functionality of heaps, productivity can be increased. You learned that heaps could place priority on the lowest valued key and are then called min heaps, and ones that place the priority on the maximum values are called max heaps. A heap has a few select core operations that it can perform, namely the insert, find, and delete of items. Following this, you learned that deleting items in the tree would require restructuring the tree, and this would lead to a degradation in performance. To summarise, in the video about heaps, you have gained a greater understanding of heaps and how they can be used to organise elements from least to most important. You have been shown that, by limiting functionality, productivity can be increased. As with selecting any data structure, it is important to find the right tool for the right job. Finally, you focused on graphs and set the scene as follows. When considering a given problem in computer science, it is always important to consider what executions might be required to solve your problem, and, through this reflection, choose an appropriate data structure to hold your data. Consider that you might work for a large internet company that wants to store a directory of locations and their connectedness to one another. An illustration of cities plotted in relation to one another was used to explain all the concepts, such as a weighted graph, an undirected graph, and that in contrast to a directed graph, an undirected graph has no order of precedence. Following that, you learned that a connection in a directed graph is considered weakly connected if the edge is only one way. However, if there are two connections going either way between two nodes, it is said to be strongly connected. In this video, you learned about the key concepts and topics covered throughout this module. You have done some quizzes on all the topics mentioned. You are getting more equipped for your future. Good luck with the next module. Sorting a set of data might sound like a straightforward task, given what you have already learned throughout this course. However, it can be surprisingly challenging when you get into the details. In this lesson, you'll explore sorting algorithms and the different sorting methods that are available to you. You'll be introduced to some of the various approaches to searching, such as linear and binary. You'll also discover the steps involved in implementing both of these approaches and explore the advantages they offer. You'll also learn about the steps required for implementing selection, insertion, and quicksort, and discover the strengths and weaknesses of each sorting approach. There are several algorithms that have been developed for this challenge, and some data structures that had previously been discussed, like binary trees and heaps. Both of these data structures have been designed with the aim of retaining the data in a sorted manner. Working with sorted data or having the ability to sort your own data can result in significant time savings. Therefore, a data set of elements that can be ordered is fundamentally necessary. This order could be alphabetically, sequentially, chronologically, by size of shape, or by hue of colour. The actual metric that is used is less important than the fact that they can be arranged in an ascending or descending order. A second consideration that's factored in is whether the ordering is permuted, meaning reordered, or has been accomplished by creating a copy whilst keeping the original list. Selection sort is an early approach to sorting. It mimics how a human might approach the problem. The underlying principle is very straightforward. You start by searching through a list to identify the smallest element. Then, switch this with the first element so that the smallest element is placed at the top. Now the previous occupant of the top spot has been switched into the vacated spot in the list. This is repeated for every element in the list until the list has been ordered from the smallest through to the largest. Let's explore this in an example. You'll see in this diagram element 35 at index location 0. In a selection sort, a comparison is made between the element at index 0 and each element in the array until the lowest is found. Equally, element 46 in the next location is compared to each element and in this case switched with 6. Next is element 36 found at index 2. You'll notice that element 9 at index 3 is deemed the smallest. However, the entire array must be searched. This process is continued until every element is ordered by size, smallest to the left, largest to the right. Another straightforward approach to sorting is insertion sort. Rather than searching through all the elements, this approach begins by examining the first two elements in a list. The smaller of the two is then moved to the front. This is repeated for every element, each one being compared to the element on its left. A subsequent switch to the left is made if it's found to be smaller. So, element 2 is compared with element 4. It's found to be smaller, so a swap happens. Next, element 2 is compared with element 1. It's found to be larger, so no more comparisons are made. Then, element 3 is first compared with element 4. It's found to be smaller, so a swap occurs. Next, element 3 is compared to element 2. It's larger, so no further comparisons are made. Let's explore an example of this. On screen, you'll notice an array of numbers. The first element, 35, has nothing larger to the left, so it remains where it is. Then, element 46 is compared and is also left where it is. Next, you see element 36. This is compared with location 1. It's smaller than 46, so they are swapped. Checked against location 0 shows that no further swaps need occur for this element. At step 3, you'll notice element 9. This is compared with 46 and is therefore swapped to location 2. It is further compared with location 0 and 1 and swapped again. Next, the element found at location 4 is compared with location 3 and swapped. It's further swapped with location 2 and location 1. It's also compared with location 0, but as it's greater, no further movement is made. The process is continued, moving from right to left until the entire array is sorted. Both the insertion and selection sort are straightforward approaches working on a simple paradigm. Quicksort is a more sophisticated approach that is more complex to implement. However, it shows far greater efficiency. Quicksort operates on the principle of pivots. The algorithm selects an element in the array as the pivot. Then, all items in the array larger than this value are moved to the right of the pivot, and all elements less than the value are moved to the left. This process is repeated for both sides of the pivot until all the items are sorted. Let's explore this in an example. Here, element 9 is selected as the pivot point. Using quicksort, all items that are less than 9 are swapped left, and all items larger than 9 are swapped right. Therefore, the smaller elements have now been moved left after this first split. In this example, these smaller elements are 6 and 3. Applying the same procedure again to the resulting array terminates when 3 is found to be the only element not split. Now, taking the values that are greater than the original selected pivot, you select a new pivot. In this case, 36 is selected and a further swapping of elements is performed. Finally, the remaining unsorted index locations are swapped in relation to a new pivot. Once all elements have been sorted, the algorithm terminates. There are many additional sorting approaches that can be used, with some approaches even forming hybrids of these existing ones. In practice, you probably would not write your own implementations, as there are excellent implementations in every language. The goal here is to show how they operate under the hood, so that you can choose the best one when faced with a given problem. As with data structures, there is not one sorting algorithm that provides the best result in every given scenario. Each approach has its trade-offs and is more effective in some environments than others. You will learn more about the efficiency of these approaches when compared to Big O notation soon. In this video, you've explored sorting algorithms and the different sorting methods that are available to you. You have also learned about the steps required for implementing selection, insertion, and quicksort, and discovered the strengths and weaknesses of each sorting approach. In the previous video, you explored sorting and were introduced to several sorting approaches that can be used for a dataset. However, What if you need to search this data for a specific element? In this video, you'll be introduced to some of the various approaches to searching, such as linear and binary. You'll also discover the steps involved in implementing both of these approaches and explore the advantages they offer. In computer science, searching is a fundamental operation. When provided with a collection of data, there may be a need to identify specific elements within this data. However, the exact description of the element does leave room for some interpretation. From the onset, you might consider the question: given a hash table, is there a key value pair that matches this key? This is a simple like-for-like comparison that will produce either the absence of a unique key or the return of a unique key. Some considerations when making a search might include finding the largest number in this array, or the smallest, or to return the median number from this collection of numbers. However, what if the value does not exist? What should be returned? Returning a null value can interfere with an application's ability to run afterwards. When doing a search, you need to consider what safeguards should be put in place when there is no value returned. You should also consider if the search is supposed to return the first instance of the value or the last. In the additional reading at the end of this lesson, there is a link to a talk from Tony Hoare, the inventor of null, who refers to it as his billion-dollar mistake. The simplest search that you can implement is a linear search. If you have an array of elements, a linear search begins at the start of the index and searches through the array until an appropriate element is found, or there are no more elements to check. In this approach, the best case scenario would be O of 1, and worst case, O of n, as each element would have to be checked before it's possible to say that the target element is absent. In relation to data structures, it has been shown that some have inherent sorting tendencies, such as a heap or a binary tree. You can also take any data structure and apply a sorting algorithm to it before applying a searching approach. Using a binary search will halve the search space at each iteration. On screen is a data list. A binary search will firstly check the halfway point and determines if the element is greater or smaller than the target element. If the middle element is less, then the left half of the list is discarded and the right half becomes the focus. So, now only the right half of the list is queried for the middle value. Again, if it's less than the target element, it is once again discarded, and the right half of that filtered list will be examined. In this way, the algorithm halves the search space at each iteration. This approach is quicker than a linear search, but does require the data to be sorted before beginning the search. It may not seem like a reasonable requirement to have this, but if your data is read more often than it is updated, then such a solution might be an appropriate implementation. Again, as with the linear search you covered earlier, the best possible outcome from this approach is that the element is found in the first go O of 1. However, the worst case scenario is less optimistic. After the first search, the list is halved. If this iteration is not successful, it is halved again. Then after the third division, it is halved again, and so on. Therefore, it can be said that after j iterations, it is n over 2 to the power of k, or in other words, O log n. This is considerably more efficient than a linear approach. However, it is worth bearing in mind that any perceived gain in time needs to be offset by the time taken to sort the list. If the list is updated regularly, this can become a costly process. In this video, you explored binary and linear search functions, the steps taken to complete these searches and how they work. You also learned how the application of Big O can be used to estimate the efficiency of both. You've even learned how through some clever adaptations to a standard approach, it's possible to seriously improve performance. Keep up the great work. In the next lesson, you'll start learning how to work with algorithms. The divide and conquer paradigm offers a useful framework for thinking about how to solve a given problem. It encompasses two principles discussed in this module, namely recursion and breaking problems down into smaller problems. In this video, you will learn about the divide and conquer paradigm and how it offers a framework for problem solving. You will also learn about the mandatory and optional steps involved in the divide and conquer paradigm and what advantages this paradigm brings to computers. So how does the divide and conquer algorithm work? The algorithm comprises two steps with an optional third, namely divide and conquer, which are the mandatory steps, and combine, which is an optional step. In the divide step, the input is split into smaller segments and processed individually. In the conquer step, every task associated with a given segment is solved. The optional last step, combine, is combining all the solved segments. This will not happen in every instance, but will for the example provided. The following is an example of the divide and conquer paradigm. When discussing sorting approaches, it was shown that there are many ways to solve a problem. Using sorting as our example, let's discuss another sorting approach that can be solved using a divide and conquer approach. Merge sort is a sophisticated approach for sorting an array. It starts by halving the array. These two halves are then halved and halved again. This process is repeated until there is only one element remaining. Then the process reverses and each smaller list is sorted before rejoining the part it was halved from. This solution to a problem is based on the idea that by breaking a problem into smaller problems, it is easier to complete the overall task. To gain greater intuition on how divide and conquer can be applied to merge sort, let us explore a real-world example. Consider you and 3 housemates have decided to do the shopping together. After having compiled an extensive list, you all go to the supermarket. One solution might be that you all walk around the supermarket and pick up each item from the list. A better approach might be to break the list into 4 parts and each take a section. This would reduce the overall time spent in the shop. Though this might cause an amount of overlap between parties, a further optimization of the task then might be to first sort the list so that all similar items are together. For example, all the beverages, the fruits, the meats, and so on. Then, assign each member a given area of the supermarket. This would be an even more efficient approach to completing the task. They say a problem shared is a problem halved. So how does this work on computers? There are 2 immediate advantages, namely parallelization and memory management. Parallelism is when you have different threads or computers working on the same problem at the same time to complete it in a quicker time. A benefit to employing divide and conquer solutions is that you can then employ parallelism when coding. Now, let's explore memory management. With the merge sort example, consider that each array can be sent to a different core or server depending on the architecture of your organization, and the results are then returned. It might be that the data being processed is too large to hold in memory and must be processed in chunks. Additionally, the boss may have provisioned access to cloud computing, so the solution can involve accessing an online server and exporting some of the problems from the company servers. All this contributes to managing your available memory. In this video, you are introduced to the paradigm of divide and conquer through an example of merge sort and how it offers a framework for problem solving. Some various terminology associated with it, as well as how this approach lends itself to real-world computer optimization approaches, were demonstrated. You also learned about the mandatory and optional steps involved in the divide and conquer paradigm, and what advantages this paradigm brings to computers. In a previous video, you learned about the divide and conquer paradigm. In this video, you are going to learn about recursions and how to implement the requirements for a recursive solution. One of the basic tenets of any given language is its ability to perform loops. Loops enable us to perform actions repeatedly until the desired output is achieved. Unlike humans, computers never tire of performing the same mundane task repeatedly. An alternative approach to solving a problem than a loop is recursion. The practice of having functions call themselves is referred to as recursion and the focus of this video. Recursion is when a function calls itself with a smaller instance of a problem repeatedly until some exit condition is met. So what is required for recursion? There are three requirements for implementing a recursive solution, namely the base case, the diminishing structure, and the recursive call. Let's look at an example relating to binary to better illustrate these three requirements. Consider a challenge where you are tasked with finding the exponent of a number. Recall that calculating an exponent of a number is to determine how many potential permutations can be derived from it. This was discussed when demonstrating how binary can be used to represent a range of characters. The base case ensures that the function will not continue to call itself and eventually ends. Line 1 outlines a function that will take two arguments, x and n. The base case is if n equals 0. In this instance, the program will terminate. Line 4 is the second part of the conditional statement. If a termination point has not been reached, call the function again with a reduced structure. In this instance, the goal is to multiply x by n to find the total number of potential states that could exist for the binary number. Reducing the input value is as important as establishing a base case. This way, the function will eventually reach the base case and cease to call itself. The third component of a recursive function is to include a call to itself. This happens on line 5, where the exponent is accepting the diminished structure. The structure can be said to be diminished because the size has been reduced from one call to another. Each time the function is called, a new instance is created on the call stack. Calling the above function with x equals 2 and n equals 3 will result in 3 instances being created and placed on the call stack. This increases computational cost as resources are required to make a function call. However, the computation from each result will be retained on the call stack. This can be useful when computing hierarchical problems or problems where one can benefit from knowing which steps resulted in a given outcome, like traversing a graph. Let's explore an example of the use of recursion. Consider the video on binary search. A binary search function will accept an argument of a list and a target value. First, the middle point of the list is checked against the elements to determine which half of the list to check. This process is repeated until the target element is found or deemed to be not there. You might consider solving this problem through a loop or recursively. The input to the recursion would be a list and a search element, and the recursive function would call itself until the target endpoint is reached. So why then use recursion when a simple loop will do? Some problems lend themselves well to recursive calls. Consider calculating the Fibonacci of a given number. Fibonacci is a sequence of numbers where the first two numbers are 0 and 1, and every other number is the sum of the previous two numbers in the set. Calculating the result involves passing a number, calculating the output, changing the number, then calling the function again with a new integer input. Writing the code this way means that you can simply call the function with a different integer, and it will return a breakdown of the required steps. Readability is a strong plus for recursion. Sometimes when a problem requires many checks, a loop can quickly become unwieldy. Recursive solutions reduce the amount of code required to solve a problem and can be easier to read and understand. Finally, one would employ a recursive approach as part of a divide and conquer solution. Here, the problem is broken into smaller steps and repeated to come upon the optimum solution. In this video, recursion has been introduced. You have learned that while recursion can add some computation overheads to a problem, it can also result in eloquent, easily read code. Additionally, that recursion epitomizes a divide and conquer solution, breaking the problem into its smallest components and solving those. In the build-up to dynamic programming, you have learned about the divide and conquer paradigm and recursions. In this video, you will learn about the concepts of memoization and dynamic programming. Dynamic programming is a programming paradigm that promotes solving problems by breaking them into smaller problems and solving these. The solutions are then stored in an appropriate data structure for later use. The advantage to this is that if these subproblems require being computed again, one only searches for the answer instead of computing the problem again. The technique of solving subproblems and storing them to save time on a potential future lookup is known as memoization. Dynamic programming relates to two concepts already encountered in the previous videos. Let's have a quick refresher on these concepts. The first is divide and conquer. That is, taking one large problem and breaking it into a smaller set of subproblems and then solving these. The second is a subset of this, known as recursion. Recursion is the practice of coding a solution that avoids running loops, but instead uses multiple self-calls in coming upon a solution. Dynamic programming is an extension of these approaches, which in addition involves keeping a record of results generated from running the subproblems each time they are newly run. In subsequent runs, instead of recomputing results, a lookup is queried for the last time the question was asked. As said, this approach is called memoization. And to reinforce the concept, this is when the results of previous calculations are stored and used in place of rerunning the calculations when the compiler identifies that the computation has been run for a previous task. To exemplify this, consider the question posed in the video about binary numbers. How many combinations were possible with a binary lock of 6 digits? In a previous video, it was shown that you can discover this through exponentiation or finding the power of a number. So the same lock with 6 digits would have 2 to the power of 6 or 64 combinations. So 2 to the power of 6 equals 2 times 2 times 2 times 2 times 2. Alternatively, you can divide these into two groups where you have calculated 2 times 2 times 2 and again 2 times 2 times 2. That will result in 8 times 8 and again give the same result. Applying a divide and conquer approach to computing this efficiently using memoization would reduce the computations by first calculating to the power of 3 and again 2 to the power of 3. By applying memoization, the first 2 to the power of 3 would be computed, then reused for the second bracket, reducing the overall computation required. So, what sorts of problems are good fits for a dynamic solution? The dynamic programming approach is commonly applied to combination or optimization problems. One example of a combination problem already mentioned is the Fibonacci sequence. Another instance you may encounter in an interview is the knapsack problem. This is both a combination and an optimization problem. Say for a planned camping trip, you can fill a knapsack with required items. Each item has a weight cost to it. A torch equals 1 kilogram, water equals 2 kilograms, and the tent equals 3 kilograms. Additionally, each item has a value. The torch equals 1, water equals 2, and the tent equals 3. In short, the knapsack problem outlines a list of items that weigh different amounts and have different values. You can only carry so many items in your knapsack. The problem requires calculating the optimum combination of items you can carry if your backpack can carry a certain weight. The goal is to find the best return for the weight capacity of the knapsack. To compute a solution for this problem, you must select all items that add up to a given weight and contain a given value. The weight carryable will change. This problem can be applied to resource allocation, where you have so much CPU power and X tasks to run, just like the capacity of a CPU dedicated to completing tasks. Sometimes the weight will be 7 kg, and other times it might be 10 kg. Dynamic programming involves saving the computations used to come upon a given solution. So, if you have computed an optimum selection for 7 kg and it is raised to 10 kg, you will not have to rerun the initial computations again. This can be a time-saving metric. When computing dynamic programming solutions, you must firstly determine the objective function. That is, the description of what the optimum outcome is to be. Next, you must break the problem into smaller steps. One approach already discussed for achieving this can be the use of recursive functions. That is, functions that will call themselves repeatedly until a solution is come upon. They should be written in such a way that you can change the outcome without altering the code for the methods already written. To conclude, in this video, it has been shown that dynamic programming is an approach that looks to optimize solutions to a given problem. It uses principles of memoization and overlapping subproblems to identify when an objective function can be achieved quickly, optimizing the computation steps required. In this video, you will learn how you can implement this paradigm to solve complex problems by using greedy algorithms. There is a philosophical principle called Occam's razor. It states that the simplest solution is almost always the best one. This problem-solving principle argues that simplicity is better than complexity. In our case, the greedy algorithm is the simple solution. This is an alternative approach to dynamic programming, as this approach seeks to present an immediate solution for a task and favors local optimization over a more holistic global approach. When engaging with a problem subdivided into segments, utilizing a dynamic programming approach would find a globally optimal solution so that each subproblem is solved and the best subset is selected and implemented. A greedy approach would instead look at the list of solutions and implement a local optimization. Usually, the current most rewarding option is chosen. To make this more clear, let's take an instance of a CPU that has a list of tasks to be completed. Applying the dynamic programming approach would entail selecting a subset of activities that could be completed within a given time and executing these tasks. With the knapsack analogy, this would involve determining what subset of items to pack that would maximize the value in the process of filling the bag. A greedy algorithm approach to this would be always to select the most valuable item and place this in the bag, giving no thought to what other items this would exclude from the process. Thus, in our CPU example, a greedy approach would involve selecting first the shortest running program and then the next shortest program, and so on. While this might not lead to a globally optimized solution, it will reduce any overhead in calculating the most efficient subset of items. To better understand how these two approaches would differ, let us consider the problem of the shortest path. The image shows a map with 9 different nodes: A, B, C, D, E, F, G, H, and S. Each node is connected to another node by a weighted path. This weight reflects the cost that would be incurred by selecting this path. Thus, in our CPU example, a greedy approach would involve selecting first the shortest running program and then the next shortest program, and so on. While this might not lead to a globally optimized solution, it will reduce any overhead in calculating the most efficient subset of items. You are now faced with making a journey from E to F and want to plot the most effective route. A dynamic programming approach would involve creating a table and calculating each potential node from E. From there, it would introduce the next set of nodes and calculate the accumulated cost. This approach would undoubtedly arrive at the most efficient solution. Using memoization, after the initial calculations were made, they would be saved, and subsequent journeys would benefit from a quicker computed time. This is a bottom-up global approach to the problem. A greedy approach would differ in its methodology. Instead of trying to find an optimal subset of connected routes, it would instead begin at node E and look at each available connection. Thus, it would have a selection of weights, namely 5, 3, 2, 4, and 12, which correspond to nodes C, B, D, G, and H. The lowest value in that array is 2, which corresponds to node D. Following the greedy principle, it would make this selection and progress to the next node. Assuming that the data structure was a directed graph, it would be presented with a further 3 nodes, A, F, and G, that have the values of 7, 5, and 6 respectively. Since F is the final location, it would select F and arrive at its destination happily, having amassed a total penalty of 7 for travel time from E to D and then to F. That carries a weight of 2 plus 5. Visually, you can see that this is the most efficient approach, and it was come upon without creating an exhaustive table of combinations and computing all routes. However, had the node between G and F had a penalty of 2, then it would have selected a less optimal solution. This is the trade-off when choosing a greedy approach over a dynamic one. While the overhead for a greedy algorithm is low and coding a solution is quite straightforward, it will not always guarantee that the best option is returned. You now have a greater understanding of the greedy algorithm approach. In addition, you have seen how it compares with a dynamic solution and thus deepened your grasp of the strengths and weaknesses of this alternative approach. Next time you are plotting a route in Google Maps, consider the selection of routes that are offered and think about how these routes might have been calculated. Well done! You've reached the end of the Working with Algorithms module. Let's take a few moments to review what you learned during this module. You began the module with a lesson on sorting and searching. First, you learned about why sorting is important and explored the 3 main methods for sorting: selection, insertion, and quicksort, and examined the steps involved for each method that these algorithms use to sort data, and explored the strengths and weaknesses of the 3 sorting approaches when choosing an algorithm to use for a given solution. Importantly, that there is not one sorting algorithm that provides the best results in every given scenario. Next, you learned about searching algorithms, which are a fundamental concept in computer science, and some of the various methods that are used by algorithms for searching. You explored 2 core approaches to searching: linear and binary. Linear searches progress through every item in a given data structure until a specific item is found, whereas binary searches half the search space at each iteration. You also learned the steps involved in implementing both approaches and some of the advantages they offer. You also took a deep dive into time and space complexity for both searching and sorting algorithms. You then moved on to the next lesson, where you were introduced to working with algorithms. Here you learned about different approaches to working with algorithms. First, you explored the divide and conquer paradigm. In the divide step, the input is split into smaller segments and processed individually. In the conquer step, every task associated with a given segment is solved. And the optional last step, combine, is combining all the solved segments. And you discovered how the divide and conquer technique offers an effective framework for problem solving and the various benefits that it provides. Next, you explored another important algorithmic approach, recursion. Recursion is when a function calls itself with a smaller instance of a problem repeatedly until some exit condition is met. And you learned that there are 3 requirements for implementing a recursive solution, namely the base case, the diminishing structure, and the recursive call. You were then introduced to dynamic programming, which is a programming paradigm that promotes solving problems by breaking them into smaller problems. You explored the concept of memoization, the technique of solving subproblems and storing them to save time on a potential future search. And you examined the process involved to compute a dynamic programming solution. Essentially, this can be outlined as first, determining the objective function. That is the description of what the optimum outcome is to be. Next, breaking the problem into smaller steps, and then deciding which dynamic programming approach you would like to apply to achieve your desired outcome. Finally, you learned about greedy algorithms. In comparison to the dynamic programming approach, a greedy approach would look at the list of solutions and implement a local optimization. Usually, the current most rewarding option is chosen. You explored how a greedy algorithm approach could be implemented to reach a solution, and that there is a trade-off when choosing a greedy approach over a dynamic one. While the overhead for a greedy algorithm is low and coding a solution is quite straightforward, it will not always guarantee that the best option is returned. With all the knowledge you have acquired, all that is left is to complete the final quiz for this module before moving on to the final module, where you will complete the graded assessment. And then you've really made it. You're so close. Good luck and enjoy the rest of your journey. In this course, you have learned a range of concepts and skills as you prepare for a coding interview. Let's take a few moments to recap the key topics that you learned about. In the first module, you started by discovering what a coding interview is, what it can consist of, and the types of coding interview that you might encounter. Your first lesson focused on the technical coding interview, primarily to determine that you are technically capable of the role's responsibilities. You learned about the steps that you must keep in mind when this interview is conducted. You were taught that using the appropriate tools is always important and that you have to keep time constraints in mind. You also explored how you can prepare yourself for a coding interview and the importance of first impressions, including a focus on communication, such as explaining your thought processes and handling mistakes. You learned about the STAR method and how to use it to your benefit when communicating with interviewers. You also learned about how to work with pseudocode to demonstrate how you might reach a solution, some important tips for practical solution design, and how to test your solutions. In the next lesson, you got an introduction to computer science, starting with an overview of binary, where you learned about the difference between base 10 and base 2. You then discovered positional notation, the use of the position of the number to denote a progressive increase in value. You then moved on to explore key components of computer memory and how it works. You should know by now that to better understand the various layers of memory and should be able to describe the differences. You learned about the transfer rate, or the speed at which a computer can transfer memory into the cache for processing. You then moved on to time complexity, where you learned how to evaluate time efficiency or gauge performance by the time taken to complete a task. You discovered Big O notation, which is a metric for determining an algorithm's efficiency. You explored space complexity, which is essentially the space required to compute a result, and that any decisions around space complexity are not just based on the speed of an algorithm, but also on how much memory capacity a given solution will use. There will always be a choice to prioritize speed or compactness. In the second module, you learned about data structures. This ranged from basic data structures like strings, booleans, or arrays to more advanced data structures like collections, graphs, and heaps, and how each one comes with certain benefits and limitations. You explored all the types of data structures and how they are classified into two main branches, linear and nonlinear. Next, you were introduced to stacks and queues, abstract data structures that both have specific characteristics around how elements are added and removed. When you visited queues, you learned that a queue is very similar to a stack in that it tends to have the same methods. It can create, insert, remove, and check the state of the queue. Unlike a stack, a queue works on a first in, first out, or FIFO basis. Finally, you found out that trees are a powerful data structure that give you great flexibility in adding and searching values. Following this, you went on to examine some advanced data structures, namely hash tables, heaps, and graphs. Next, you explored heaps. You discovered how heaps can be used to organize elements from least to most important, and how, by limiting the functionality of heaps, productivity can be increased. Finally, you examined graphs. This structure illustration is a graph that is made up of nodes to denote destinations and edges that show how each node relates to another. The presence of values between the nodes mean that this is a weighted graph. There are no arrows present, which means that it is an undirected graph. In contrast to a directed graph, an undirected graph has no order of precedence. And you learned that a connection in a directed graph is considered weakly connected if the edge is only one way. However, if there are two connections going either way between two nodes, then it is said to be strongly connected. In the third module, you had an introduction to algorithms, including the types of algorithms available to you and how best to work with them to sort and search your data. You started by exploring sorting algorithms and how working with sorted data or having the ability to sort your own data can result in significant time savings. You discovered why sorting is important and explored the three main methods for sorting: selection, insertion, and quicksort. Next, you went on to discover searching algorithms and how each type provides its own framework for problem solving. You explored two core approaches to searching: linear and binary. Linear searches progress through every item in a given data structure until a specific item is found, whereas binary searches halve the search space at each iteration. You also gained insight into time and space complexity in both searching and sorting algorithms. You then moved on to the final lesson, where you were introduced to working with algorithms. Here you learned about different approaches to working with algorithms. First, you explored the divide and conquer paradigm. You learned that in the divide step, the input is split into smaller segments and processed individually. In the conquer step, every task associated with a given segment is solved. And the optional last step, combine, is combining all the solved segments. Next, you explored another important algorithmic approach: recursion. Recursion is when a function calls itself with a smaller instance of a problem repeatedly until some exit condition is met. And you learned that there are three requirements for implementing a recursive solution, namely the base case, the diminishing structure, and the recursive call. You were then introduced to dynamic programming, which is a programming paradigm that promotes solving problems by breaking them into smaller problems. And you examined the process involved to compute a dynamic programming solution. Essentially, this can be outlined as first determining the objective function. That is the description of what the optimum outcome is to be. Next, breaking the problem into smaller steps, and then deciding which approach you would like to apply to achieve your desired outcome. Finally, you learned about greedy algorithms. In comparison to the dynamic programming approach, a greedy approach would look at the list of solutions and implement a local optimization. Usually, the current most rewarding option is chosen, and you looked at an example of how a greedy algorithm approach could be implemented to reach a solution. While the overhead for a greedy algorithm is low and coding a solution is quite straightforward, it will not always guarantee that the best option is returned. So, there is a trade-off when choosing a greedy approach over a dynamic one. Well done! You have covered so many important concepts and approaches throughout this course. It is a real achievement, but it should also serve to prepare you for any potential coding interviews that you may go on to attend. All you have left to do is to take the final course quiz before wrapping up the course. Good luck! You've reached the end of this coding interview preparation course. You've worked hard to get here and accumulated a lot of knowledge along the way. You've made great progress on your developer journey. You should now understand the unique and challenging aspects of the coding interview. Specifically, you should be well prepared with some interview soft skills that will help you to be ready when you go for your coding interview, the foundations of computer science, and some problem-solving methods to apply to any challenge you may face in an interview scenario. Following your completion of this course in coding interview prep, you should now be able to prepare for the interview process, offer strategy and tips for successful interviewing, and openly discuss the emotional components of the process. The key skills measured in the graded assessment revealed your knowledge and understanding of data structures in the context of coding interviews, the concepts and usage of algorithms, how to visualize an algorithm, and combining new and previously learned coding patterns to solve problems. Congratulations! You've successfully completed all of the courses in this program. At this stage, you may want to consider registering for another course, specialization, or certificate pathway. Certifications provide globally recognized and industry-endorsed evidence of mastering technical skills. Whether you're just starting out as a technical professional, a student, or a business user, the courses you have completed and the range of practical projects you have in your portfolio will prove your knowledge and ability as a developer. These can serve to demonstrate your skills to potential employers, and not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. You've done a great job so far, and you should be proud of your progress. The experience you gained so far will show potential employers that you are motivated, capable, and not afraid to learn new things. Again, congratulations on finishing this course, and good luck with the rest of your educational journey.